DSP compression mode in other Elecraft products.
Yeah, and just so you guys know, it's controlled envelope single sideband. It's not polar modulation, but it's a method of improving on the old RF speech clipping that all of us have used either in DSP or on radios for years. And it gets you 6 to 8 dB according to what the ARRL did on the K4 review. And we use the same family but slower DSPs in the KX2 and the KX3. And for QRP low power, of course, that's a godsend if you can get it, because that's like a free amplifier. But I can't guarantee it. We have not had time to go back and look at putting that in. I've got my DSP engineer, when he gets free from a couple other projects, that he's going to look at it and we'll get it in. So if we can get it in, we will, but I can't guarantee it yet.
Okay. I think we need to move on. Sorry. We'll try to answer your question.
By the way, I'm at the booth right after this, so when you guys come over, just if you didn't get questions answered here, corner me over by where you see all the K4 remote stuff on the corner close to our sales, left-hand side of the booth, and I'll be glad to talk to you.
Okay.
Go ahead.
Just hand that mic to N6UOP.
Okay.
And he'll be our runner when we have questions later. Okay. Thank you. We're done.
Okay, I'm going to go run back. So
Don't trip. Thank you, Eric. Okay, this is the talk I've given before, but there's some new stuff and some of the old stuff. To save time, I may skip over quickly because it's all on video on YouTube. You can just watch it there, and I haven't changed those slides. But some of the slides are updated, so hopefully you'll get something out of it today. These links have been updated, and by the way, I'm going to put a PDF version of these slides on my QRZ page maybe this afternoon when I get back to the hotel. And so you'll be able to click on these links and go directly to what I'm trying to show you there, K4 manuals page. Their online manual has been updated, the programmer's reference, and a little document on how to turn your K4 on and off remotely. And the release notes from the beta are now online as well. And everybody here really should join the Elecraft K4 groups.io. That's where all these questions are answered. That's where they announce the Zoom calls where we do interactive problem solving. And there's also files on there. That's a private group, so you can't find it with Google searches. It was created that way. We're sorry, but somebody else created it that way, and we're stuck with it. There's lots of good files there, including a 500-page summary of all the good tips that have been posted that DL2FAG compiled. That's the bottom link there. And a new link that I'm putting on here is the Basic Remote Connection Guide by W7IY. I'm going to repeat that link later when we talk about how to connect a remote. But if you really need help and you can't find it, please do search the forum first. Don't try to use Google. I'll talk about that. But there is a nice interactive Zoom conference we have every Sunday. Our host is here. Go ahead, stand up, Dave, N8. There you are. He's running the Zoom every Sunday except today or tomorrow or Sunday. Yeah. And thank you for hosting the Zoom call for us. We do a lot of interactive problem solving, help people with their routers to forward ports if they can't figure out how to do it and they're trying to get remote to work. But yeah, you see, the problem is people are using Google and ChatGPT and others to ask questions about the K4. That doesn't really work. They kind of have access to the manuals, but they don't have any access to the knowledge base and all the files in the private group, so they can't give you much good information. So what's new since last year? Well, we just announced, or they just released the Beta 3 R38 software firmware in the K4, and it improved the remote operating experience. Now they have an update to the K40 remote control panel as well, which wasn't around last year. What's brand new, is Mike here yet, KF50? I was hoping you would be here by now. UK4 software, which is like what the virtual K4 software was going to be, but Elecraft has discontinued that. Mike has, or tabled it, let's say, but QK4 is demoed in the booth over at Elecraft, and it's free remote control software, and it's the same interface, and it works on Windows and Mac and even Raspberry Pi, and some folks have compiled it for Linux. It's open source, it's free, and you'll see pictures of that later. And of course, they added spectral subtraction noise reduction as an option in the NR button, and that enables you to quiet the background noise on phone, and it even works a bit on CW. And they've modified the K4, so now it automatically reboots in the same state it was in when you powered it off. So if you had test mode on when you powered it off, test mode will be on when you power it on. If you had split on when you powered it off, split will be on when you power it back on. So If you want to override that and you always want it to start up in split mode or split off, you can put a command into the startup script, and then it won't run that command every time it powers up. This is an old tip, but it's a goodie, especially if you haven't learned about this button. It's labeled norm in yellow. Remember, yellow means you hold down the button in most cases. So if you hold it down for the filter knob for 2 seconds, it resets the filter, recenters everything, and when the things get messed up, it makes your filter sound correct. Unfortunately, the K4 remembers the filter and bandwidth and shift and all of that stuff per band and per VFO. So you change bands, or change modes, you can see a totally different bandwidth. Your norm button is your friend, and use it. A lot of folks think they have to do it like an old radio, that I have to plug my headphones in when I want to mute the speaker, and I have to take my headphones out when I want to listen to the speaker. There's no reason to wear out your headphone jack by doing that. Just, you can leave a headphone plugged into the rear panel all the time. And by default, there's a button on the K4 labeled PF3, but you can program another button if you want to, that just toggles the speakers plus phone setting on or off. So you leave the headphones connected. If you want to hear the speakers, you hold down PF3, and it toggles it to yes. Press it again, toggles it to no. And you can take any menu item you see that you're often using, and you can put it on a PF key just by tapping that PF key. So here's like an example of that. Here's a picture of the menus. Some folks that don't have external speakers connected, they may want to mute the internal speaker. So you could put the scroll bar up there on that top line that says speakers internal, and then hold down the PF2 key, which is below the clear key there. And yellow means you hold down that button. And then it'll prompt you and say, do you want to assign this menu item to the PF2 key? If it's an on-off menu item, pressing that key toggles it on and off and prints a message. If it's another menu item that has more options, it just opens the menu to that item so you can change things. So the manual is in the radio, but it's kind of hard to use. It's online in the same format. You can open any browser anywhere, on your phone, wherever, to the K4 manual. I suggest you bookmark the latest manual, follow this link when you get the PDF, and then you can use the Control F key in your browser to find. And they've added a change history section at the bottom, so you can see what's changed in the manual, like they added SSNR support. And they made the error messages searchable. Some of them were kind of buried. So if you do see an error message on your screen like error 68.input asserted at power up, which only appears very briefly if you've got a stuck key when it powers up. I've solved a lot of problems. My radio doesn't transmit anymore. What happened? Well, I had a stuck key, a stuck paddle. The paddle spacing was wrong. The K4 is not going to transmit until you clear that problem. And you only see the message for like half a second at power on, right just before it boots up to the main screen. So if you power it on, walk away, you'll never see the message. So watch that K4 screen carefully at boot time if you're having trouble for a message that unfortunately goes away all too quickly. A lot of folks have their factory defaults. They've never touched the waterfall display settings, and it comes up looking like this. I don't know why they made these the default, but if you've got this much noise in the waterfall, it's next to useless. You can't see the weak signal traces very well. You can't find clear frequencies. And so I'm just going to go through this pretty quickly to save a little time here, because I've covered this in last year and it is on the video, that there's a bunch of settings to fix. I like changing the auto ref offset to 4, which reduces some of the noise. The factory default's a little lower. And the most important thing is the vertical axis scale. Change that to at least 80 dB, and then you'll get a nice range of signals, and you won't have big loud signals pegging the meter at the top. If you've just got a little vertical whip or something, the default is fine. But if you have a real HF antenna, or you're on 40 or 80 meters, you're going to need more range. So I'm not going to go over these in detail just to save a little time. But at the very bottom there, I do talk about double tapping, or tapping twice, the A to B button. That copies all your settings that you've made from pan A to pan B, because everything is independent, and it's unfortunately per band and per VFO, the span and scale, not scale, but the spans and stuff. Okay, so I'm going to go through these quickly, because just showing you where the buttons are. You tap display at the bottom of the screen, and then you would hold down that button because it's in yellow. That means you want to hold down to adjust the scale. And when you see this symbol anywhere in an Elecraft window, that means the VFO knob is not going to move the VFO. It's going to move whatever the menu says. So if you rotate the VFO knob, You don't have to touch the screen and press the plus and minus. You can just quickly adjust the scale by rotating the VFOA knob. And whenever you see that symbol on the screen, if you're turning the VFO expecting a signal to change and it doesn't, it's because that's on the screen, which means I've taken over VFOA. They've also taken over B and RAT and other ones. They don't work either when that thing's displayed. A lot of folks find this helpful to set the display. So at the fixed 2 mode, you just keep tapping that button and it toggles through fixed 2 and track and center and fixed 1 and static and other ones. Fixed 2 works the best. It means the window stays still until the cursor goes off the screen, then it moves half a page. So you kind of get half a screen on the left and the other half on the right. And it does have some old data in it, but it scrolls away pretty quickly. And you can similarly adjust the span by how wide the scope is. And I've been recommending to folks to use the RAT knob, set it at alternate function to pan center. Then you don't have to go through those menus. If you just want to set the edges of the scope to the band edge so you don't see any out of band stuff, you can just rotate the VFOA knob. Once you set this menu to pan center, then rotating the VFOA knob when none of the LEDs are on, that means RAT and XIT are off. That means the knob's going to do the alternate function, which would shift the scope edges until you get it right where you want it. Once you get it that way, and this is probably, again, I repeat, the most important feature of the K4 that people really could use, and that is the quick memories, the per band quick memories. And so once you have everything set, your filters, your scope edges, you want for CW this, and you want for phone that, and maybe FT8, you want a real narrow span and on that frequency. Once you get it set that way on that band, go ahead and hit store and press one of the memory keys, and it'll say quick memory M1 for 40 meters is saved. You do have to repeat it on each band, but once you do that, you find that you never touch the mode or button anymore. You switch to a band, say recall M1 if I want CW, recall M2 if I want phone, everything is set. And I use M3 for RIDI and M4 for FT8 mode, or data. I'm going to skip this pretty quickly here, leaves a little more time. Is K4SV here yet? There you are. Okay, good. The factory default has this TX antenna configuration set to all. Most people don't have all 3 things plugged into the antenna jacks. Or using all 3. You don't want to accidentally switch to an antenna you don't have. So just check the boxes, and if you only have an amplifier connected, make sure only antenna 1 is connected. And that's telling you what is switchable by tapping the antenna switch. That arrow I've got on the left there is the antenna switch. Just tap it and it cycles through those antennas. By the way, if you do make a change here, you should always tap the antenna button after so it resets the cycle. And if you want to rename your antennas, like antenna 1 is Yagi or something like that, in my case, antenna 2 is a dummy load. The way you get to this menu, it's a little obscure. When you first get the radio, you would tap the RX antenna button that I've got the arrow there on the left. And that brings up this menu of buttons, and you hold down the antenna buttons, you can put a name on them, like I've got dummy load, and a pop-up keyboard comes up. Here's a tip for you. It's rather awkward to type on this on-screen keyboard. You have to keep shifting to change numbers and case and stuff like that. It's really very clumsy. Just plug in a USB keyboard and start typing. Whenever you see this screen, you can use your USB keyboard and mouse. You can copy and paste. You don't need to type on the screen. You just plug a USB keyboard into the K4, and then you can start typing and hit enter and that stuff. Then once you've got all your antennas labeled, switch that function of that RX antenna switch to use subset. That means instead of popping up that menu of buttons every time I tap the button, it's just going to cycle like the old K3 did from one to another. Whatever checkbox you connect, it's going to cycle only to those antennas when you tap the RX antenna button. If you don't have any receive antennas, you only have one antenna, and it's only the transmit antenna on antenna 1. Don't check any box except equal TX antenna. And if you check both antenna 1 and equals TX antenna, you're going to have duplicates in your chain, and every time you press it, you're going to think, oh, it didn't work, because it's dumb. It goes box by box. Whatever's got a check mark, it cycles through those. And it's separate for the receive antenna and the subreceiver. So if you tap subreceiver, you also got to change it to use subset. Well, how do I change my subreceiver antenna? Instead of tapping the RX antenna button, well, it says sub-ant in yellow below it. So you hold down the sub-antenna if you want to switch your subreceiver antenna to a beverage or a quiet loop or something like that, and play around with diversity mode. So you're using 2 ears, one on each different antenna. It's a big advantage in many listening situations. And if you decide you want to go rename your antennas again, you got to go back. Got to change the function of the button to display all. And then when you tap the button, it'll show you those buttons on screen where you can relabel your menus. And the K4 is very good about always telling you what every receiver transmitter is doing. So here on the left-hand side, and you don't have to have dual pan mode up, by the way. All these are displayed whether you have dual pan mode up or not. So here we're using antenna 1 as the receive antenna on the VFO A or the main VFO. Always in yellow or amber here is the transmit antenna. That's right in the middle. And the antenna being used by the dummy load and its preamp and so on is set here and shown on the right-hand side for VFOP. So you don't have to have dual pan up to see that. And by the way, this clock over here on the left, it's also a button, though it doesn't look like it. When you tap that button, you get the status display, and you can change what you see in that window. I tend to use the last one on the right there, time and transmitter, so it just has a timestamp. I don't need to see the date. And if you hold down those buttons, you can do some other things. Okay, this menu kind of confuses a lot of people. It's a little hard to explain, but you tap the display button, and then you just tell it which display do you want to change. So if you highlight LCD and EXT, or the ampersand in between them, then let's see if I can show you where that is. You see the laser pointer? So this ampersand, when you tap that one, it highlights both. You tap this ampersand, it highlights both. So this is talking about monitors, and this is talking about pan adapters. So a lot of folks don't even have an external monitor plugged in, and they tap mini pan, and it says subreceiver must be on. Well, it's because somehow the EXT monitor got set to pan B at some point, and even though they can't see it, it's trying to complain that you've got pan A and pan B, and you can't have a mini pan. Also, each receiver can only display two things, either a mini pan and a regular adapter, or two regular adapters, but it can't do all three at once. That's why you have to turn on the subreceiver. So you can fix this a lot of times. You tap that, and then you just keep tapping this pan equals button down at the lower left there until it cycles from pan equals A to pan equals B to pan equals A plus B, and then back. And if you hold it down, you can adjust the waterfall height independently of your main and external monitors. Okay, how are we doing here? Ooh, all right, so people want to know, how do I pick out the weak signals, and what about this new spectral subtraction noise reduction? Well, the first tip is that the APF is really good for CW signals, maybe a little better than SSNR, because SSNR is really optimal for phone. You tap main RX, and then you want to set the APF bandwidth to 50. I think the factory default might be 30, although they might have changed it at this point. Unfortunately, it's remembered per band and per VFO, so you got to go ahead and change your APF bandwidth to 50 on all bands, and then it'll remember it. And I like to you can hold down the APF button to turn it on, but that's slow and awkward, and usually you don't want to waste time. So what I do is I program a K-pod switch with these commands, AP/ or AP $/, which means toggle it on and off. So I can do that with a single tap and quickly pull out a weak CW signal. Let's talk about how do we get to this new spectral subtraction noise reduction. Well, it's the same way as you used the old noise reduction, which is still there. You tap the NR button to turn it on or off, but you hold down the button, and below that it says ADJ, and that means noise reduction adjust. And now you get this new menu that they've added in R38 Beta 3. At the bottom, there's a button labeled SSNR that I've got the arrow on there. If you tap that button, it toggles it to the old LMS mode, and you tap it again, and it toggles this noise reduction, and you can also tap the on or off button to switch it. You can change the level by tapping the screen and using plus and minus, but again, when you see this this guy down here, this symbol here means, oh, I can just rotate the VFO and A knob to change things. But, you know, it's a little awkward because all of a sudden you're kind of tuning in a station and you're adjusting the noise and you're trying to move the VFO and you can't because this noise reduction screen is up. So I think a better way is to program some macros that increase and decrease the noise reduction. So the commands they've added now in this beta are NRS for SSNR mode, and you can do plus and minus to increase the level instead of having to bring the screen up. Now you have the VFO knob, and you can adjust it. So what level are people using? Well, it all depends on how much noise you have. You know, it's going to be different on every band, and every day it might be a little different. So you're going to be adjusting the SSNR level to your liking as much as possible. So I would, you know, it's kind of a pain to hold down that NR button and go to this menu and start fiddling with it. So I would just play with getting a macro button like on a K-Pod to do plus and minus. And if it goes below 0, it turns it off. And if it goes above 0, then it turns it on. So you can do all of that with just 2 commands. I'm going to skip over this pretty quickly. If you do want to do logger generated CW, PTT, or FSK, then you can program the pins, the virtual pins and the USB virtual serial ports to do CW and PTT keying. You don't need a WIN key. And in your N1MM software, you can just say that COM port is set for doing keying of CW on DTR and keying of PTT on RTS. A lot of folks get confused when they plug in the K4. How do I tell which one is PC1 and which one is PC2? Because Windows does not guarantee that the lower COM port number is 1 and the higher COM port number is 2. I've helped a lot of guys, and they end up with, you know, PC1 is on COM 8 and PC2 is on COM 6. And how do you figure that out, and how do you fix that? Or how do you even label these like I've done in the device manager here? Well, labeling it requires some registry editing, so I'm not going to get into that here. You don't want to usually mess with the registry, but you can put the labels in. And I have another talk on my QRZ page, talks about everything you want to do with USB and serial ports. And it explains in detail how to put labels on your COM ports. But what I want to cover today is how do I figure out if this COM port is 1 or 2? Because I need to know, because I've got one program for RIDI and one program for CW. I need to know which is which. So it's a little complicated, but anyway, you're in Device Manager. You pick that port that appeared when you plugged in the K4 USB cable. You right-click, you select Properties, and then you go to the Details tab that I've underlined here in red. And I know it's hard to see, but you next select the device instance path as the property. Shortcut, just tap the letter D, and it scrolls that drop-down list to device instance path. And then right at the end, right before the backslash and 4 zeros, there's a number. &1, I know you can't see it from back there, but it's &1 or &2. &1 is your USB PC1. In this case, it's COM3, and &2 is COM4. I'm looking at the title bar to tell me which COM port I looked at. That's how you can tell. And if they screwed it up and you want to make it more logical, you can use the port settings tab and the advanced button, and you can renumber the COM ports. But close all your software while you do that. We talked in the past about using the EQ to make your sideband have more punch. You go ahead and you tap TX, and then you tap the TX EQ button. Don't hold it down, just tap it, and you get this nice slider that comes up. And I've adjusted this a little bit from the prior recommendation. I decided that used to be 0 at the end, boosting the 3200 hertz. And I've decided you get a little more punch if you boost that to 6. And you can do this with one big command, so you don't have to individually move each slider, and then go ahead and back up your settings so you can get back to it. Another tip is that if you want to hear the difference between your boost and your no boost, you just tap this flat button over here on the right, and this guy right here. Each time you tap it, it goes from 0 and then back to what you have. So you can go off, on, just by tapping that. There's no command for it, unfortunately. But then you can hear the difference, and you can, in your monitor, you can hear what that EQ is doing. If you have a Heil mic that already has the EQ built in, you probably just want to set it to flat. But if you have like a INRAD W1 or Yamaha CM500, any kind of PC mic, they're pretty flat, and they have too much bass, and you have no punch in your audio. So this is my recommended EQ setting. Somebody earlier was asking about voice memories. It's very easy to program and activate the voice memories in the K4. You get 8 of them, 4 in each bank, and you simply record. You just have your mic plugged into the radio. You hit record button, and then this one right here, it says record right here. and then tap the M1 key. You start talking, CQ contest, and tap it M1 again to save. Don't tap record again, that cancels it. Go ahead and tap record, M1, talk, tap M1, it saves it. And then to play it, all you do is hit the button if you want your logging software to play that internal voice message, which sounds better than any external sound card for voice keying. Just send these commands PB1 through PB8. And when you hit escape or send an RX command, it stops the DVR. You hit the foot switch, it stops the voice memory. And even now, if you talk on Vox, it'll interrupt the voice memory. So let's talk about remote access, which is a big deal, and a lot of people have questions about that. Let's get our terms defined here. We have something called the server K4, which is the one that's connected to your antenna, is the one you're trying to reach to make QSOs with. How does that work? Well, it's going to just listen for incoming connections over very specific, unchangeable TCP/IP ports. What's a TCP/IP port? Well, you can think of it like a unique number that comes in over the Ethernet that the device listens to. And your K4 is going to get what's called a private IP address. It means that only your local LAN can see it. And it usually starts with these numbers like 192.168 or 10.0.0 on Comcast modems. And you can't use any of those IP addresses outside. They're private to your own internal LAN. Everybody can see each other inside your LAN. Outside world can't see those addresses. They're going to get the same ones. But what is unique to your house is what's called an external or public IP address. It's really the IP address of your router, but think of it as your house address. Everything inside your house is accessible from the outside world if you forward ports to them. And so you tell your router, I want to, any incoming message on this port, send it to that IP address of my internal K4. So, in the client K4, that's the guy who's connecting to this server. And it is the one that is going to use an ordinary internet connection, no port forwarding required, just to connect to your house. But you can't put in, when you're outside your house, you can't put in these private addresses. It can't get to them. So how do I connect to my server? You tap the globe icon. I'll show a screenshot. How do you set up the server first? You can't connect to any server by default. They're all turned off by default. So you have to tap the globe and then a button labeled server settings. This is on the server side. And you're going to have to put in a password. Now, the default password is Elecraft K4. It does not work. So if you try to leave it at the default password, nobody's going to be able to connect. And I believe the maximum connection count is also set to 0, and nobody will be able to connect. So I would change that to 2 or 3, and I would definitely give it a password. Don't try to use real fancy, complicated passwords with semicolons and special characters. You're going to screw everything up. Just use numbers, letters, and upper and lowercase, and you'll be fine with the password. So what about those ports I talked about? And this is hard-coded into the K4. It only listens on port 9204 for a special encrypted communications thing that's only used by Elecraft and some software. Most of the software, like SDR control or K4 control for the Mac, it's using a different port because it's using a different security mechanism. Both will work. If you want to use both programs, both the K40 and K4 control, you need to set up both ports. But the K4 is always listening on those ports. And you have to go into your router and you have to tell it any incoming traffic on this port, and it can be any number you want, but most people just keep them the same. Any incoming traffic on 9204, send it to my internal IP address over here, and port 9204. Any incoming traffic on 9205, send it to that K4. And if you have 2 K4s, you're going to have to use different external port numbers. It's just the address of the device inside your house. Think of it like the P.O. box or the apartment number. Apartment complex has one external street address, bunch of box numbers, and that's what that kind of represents. And configuring the router for doing port forwarding is a little different. It all depends on your router. There's a menu to access it, or you have to use the app on your phone. Elecraft is documented in detail if you have a Comcast modem, you use the Xfinity app to forward the port, and they documented that detail in the manual. All the other routers, you're going to probably need help with configuring it. There's this basic remote connection guide by W7IY that explains this kind of stuff in more detail. And then the server settings button that I talked about that you'd set on the server, that's over here. So after you tap the globe icon down here, you're going to get this menu to come up. available servers and who do you want to connect to. But tap this server settings button. That's where you set, they do this on the server side. That's where you set the password and the max connection counts. And then this is a client over here. And you would, before you connect, you got to tell it what you want to connect to. This is an IP address, not an internal one. If you're putting 192.168 or whatever, that'll work inside your LAN just fine. And as a matter of fact, the other K4s will find anything on your LAN, but any other K4 on your LAN. But normally, you're not using a virtual private network. You have to put the public IP address there, and you can give it any name you want, like my house, and then here's where you click and type in the password. By the way, the password screen comes up so you can't see what you're typing. I don't have a screenshot. There's a little eyeball icon that you can tap, and then you can see what password you're entering in. So that's what you have to do is enter IP address. You have to click save first. A lot of people forget to do that. And once it's saved and highlighted in blue like I've got here, then you can click connect, and that's it. You'll get right into your K4. So what's also new is KF50 here yet? Mike, where are you? Well, I wanted to give him a standing ovation for this great software that he's developed. So anybody with a laptop anywhere, as long as you've set up your K4 server and you know the password, you can connect to your K4 server and operate it, at least on phone, pretty easily with nothing more than a Mac or a Windows laptop or even a Raspberry Pi. And people have recompiled it and made it work on Linux as well. There's the link for downloading it. He's got binaries built. And you simply unzip it and run the QK4.exe program. And when you get a new version, because he's had new versions almost every other week as he continues to update it, you just unzip it right on top of the old location. Don't worry about having different versions around. You don't need it. And he's got the source code available if you want to build your own Linux version. And it will use either the Elecraft style security port 9204 or the one that Marcus's Mac software used, 9205. You tell it which one you want to use. And of course, that port number, if you're outside your house, could be different completely because your router is going to take care of forwarding to the right K4 inside your house. And you can even take a USB cable from a K-Pod and plug it into your Mac or your Windows PC. And now you've got a nice tuning knob, and all the macro buttons are programmable in QK4. Remember, macros are not stored in the K-Pod. They're stored in whatever device the K-Pod's connected to, including your PC. He even added DX cluster support and putting the call signs in the spectrum, something the K4 may never do. And he even added displaying the status of a 1500 amp. If it's on your local LAN, at least, you can see the status. It won't work when you're outside because of the way security works on the 1500. So this is what his program looks like. I know it's pretty tiny and you can't see it from back there, but it gives you a full spectrum. When you first start it up, it just comes up like this, all blank. Just like on a K40, you click on this globe icon in the lower left corner. A lot of people say, where's the connect? You just hit the globe icon and it pops up a screen. Just like on the K4, you put in your password and you put in the name of the server. You don't, just so it's labeled down here, and you put in the IP address, or if it's got a host name. In this case, I'm connecting locally to a local one on my LAN, so I can put in that name instead of its IP address. And I always use this use TLS box, and that is a more secure way to connect. Enter a password, and then you click save and connect, just like on the other one. And now you can connect. And yes, KH6YY is here, and he does have that many K4s. And I can connect to them all, but he has to turn them on. I can't do that. What about 1500? How do I make that work? And this is really only useful on your local LAN. You can't make this really work outside your house, but maybe you can get to your PC desktop and get to your local LAN that way. You just click the Tools Settings menu in the QK4 program, and then you click the KPA 1500 button, and it prompts you to enter the IP address. It won't find it automatically. You have to then, you can see the IP address of the 1500. It's got to be on Ethernet, obviously, by going to Menu, Net IP address. You won't see that menu until you turn on tech mode, by the way. So turn on tech mode in the 1500 menu first. Menu tech mode, enable, menu net IP address. There's the IP address of the amplifier. Put that in here. The default port is 1500. That's the only one it listens to as far as I know. And then you just click that Enable 1500 box and then the Connect button, and it will show up on your screen, and you're now connected to a K4. And right there on the right-hand side is a little mini display. I know it's too hard to read back there, but it shows the forward power of the amplifier, SWR, the temperature, and there's buttons for switching the mode from operate to standby, or switching antennas, or doing a tune cycle, the stuff you would normally want to do while operating. So QK4 is really handy if you want to run your station from another room in your house. You don't have to do any port forwarding or any of that stuff. You're on the local LAN, and of course it works almost exactly the same except for the 1500 stuff when you are offsite, as long as you've set up your K4 as a server. Macro programming in the QK4 is kind of just like you do it in the K4 and others. I have a bunch of slides about that I'll skip, but you just click the function key at the bottom. And the one trick you need to learn about in QK4 is that when you see a yellow function, like you see that button, just like the K4 has a label in yellow called macros. Normally on the K4 you'd hold down that button for 2 seconds to pop up that menu. In QK4 it's much easier. You just right click. You don't hold down the mouse. You just right click and it instantly opens the yellow function of a button. And let me back up a little bit here and say, how do I adjust the words per minute or the power? How do I do that with QK4? Well, you just put the mouse pointer over the button, okay? I can't demo it here, it's not live. Ooh, you put the mouse pointer over this button and start rolling the mouse wheel, and those numbers will go up and down. Hover the mouse pointer over this and it'll roll those numbers up and down. And you can just drag or use the mouse wheel to fine tune the VFOs. Right click moves VFO-B, left click moves VFO-A. And you know, you can't see it, but all the call signs from the DX cluster are being filled in for all these CW spots. So it's a really outstanding program. Mike has made it free for all of us, and you're still not here, are you, Mike? KF, I don't know what happened to him. I saw him back at the hotel. Okay, I'm going to kind of skip over FT8 stuff. Most people struggle with it. It's a lot to explain in these slides, and I want to give Dave time to talk about how you do remote when you need more than just simple port forwarding to make it work. But the main thing you want to realize is every time you move your USB cable or plug it in, or maybe a Windows update happens, Windows is going to think you've installed a brand new sound card, and it's going to make the K4 your default sound card. And on your FT8 stuff's going to be all screwed up. So you don't want to see these little green marks on the FT8, the K4 USB audio codec. You always want to set Windows, those green marks mean Windows is going to use it for its deep beeps and dings and stuff like that. And voice Skype calls they don't do anymore, things like that. So if you see this, you see the K4 USB audio codec, and it's connected and it's highlighted in green on this screen. Click your speakers. I got it disabled in this graphic, but if you normally won't be. And then you click the set default button here at the bottom, and it'll move all the green marks, meaning all the Windows default sound cards are now off of the radio, and now WSJT won't fight with Windows over the sound card. There's a great tool for testing your macros before you try to program them into the radio. It's very simple, and he's added some new features, so you can just hit the up and down arrow on your keyboard to retrieve commands if you struggle to get them to work. Don't be afraid of, it's called macro, it's kind of a weird word. It just means radio command. That's all it is. And the whole series of radio commands published in the programming manual. Just about every button on the radio you can access, every function. Some things you can't, like memories. There's no memory editor possible until we get new commands for that. And you don't have to put in the IP address of your K4. If you're on the local LAN, you just put in the serial number of your K4. Your IP address may change, the serial number won't. You can just put in the serial number and it figures out how to find your K4. And then you hit connect and then you can send commands. Again, to program the K40 macro buttons, it's the same way. Now notice what I've done here. I've programmed my K40 for a lot of useful functions. I've got, I didn't want to hold down the NR adjust button, so I made a single tap button that lets me get to the NR adjust menu. And I can put connect command, so I have two K4s, so I can automatically connect to one or the other with a single tap instead of having to go through the globe and pick a server and connect. And I've also added a disconnect button, so I just hold down that button when I want to disconnect, and then when I want to turn the K4 off, I can just do this remote off button here. So what are the commands that I put in those buttons? Again, these slides will be available so you can copy some of this stuff. I probably should have put it in text so you could copy and paste. Well, you can't really paste into the K4 anyway. But here's some of those buttons. And here's the thing, how do I update my remote K4? Do I have to go visit the house and do function update? And how do I switch to beta? How do I do all this stuff? Well, take a close look at this macro at the top here. RS2 means it's a new command. It means just send this command to the server only. RLB means switch to beta. Like if you're running production now, you want to switch the server to beta mode, you send an RLB command. Then you'd have to send this RS0 to say reset. Now these commands are going locally to my own box here, my own K40 or K4 client. DE50 means just wait 500 milliseconds for all of that to finish. And then this is the magic command. PS89 means update the server I'm currently connected to the current release. If you're already in beta, you don't have to switch to beta. You just send PS89. That's good enough. There's no way to bring up the NR adjust menu except for holding down this menu. But here's how I turn off only the server and not turn off my connected client. Used to do RS1 PS0 to power off the remote server. Now you can do RS2 PS0, which means just turn off the server. Don't turn off my client K4 or my client K40. You want to have that RS0 command that says stop sending commands to the server at this point. RRN means disconnect. Just, all right, it's updating, or I powered it off, I want to disconnect now. And RR0 means, and don't show me the disconnect dialog, just close everything. And if you just want to turn the local client off, it's just a straight PS0. That's what I've got down there. And on the next screen, I have the automatic connect command. This is like every time I boot up, I want to automatically connect. The RRT command is the thing that automatically connects. So you can put in the IP address and the question mark and the password, and that command will, just one tap, will go ahead and automatically connect to that server, and you can put that in the startup macro. And I'll skip over the rest of these. Disconnect, again, is RRN command, and then I don't want to see the dialog, so I close the dialog that pops up when you disconnect. And here's the startup macro that I like to use on my K4. I just put a TS1 command in there, which means always boot in test mode. That way, if it comes up and the cat or somebody hits the paddles or somebody starts screaming and the Vox is on, my radio is not going to transmit any RF. So I kind of like booting my K4 always in test mode, especially if I have a way of automatically turning it on. And then for the K40 startup macro is a little trick here. You can't, while the K40 is coming up, takes it a while to get an IP address over Wi-Fi or Ethernet. So you want to put in a delay command here. I've got this DE800. That means wait 800 milliseconds. Sorry, yeah, 800 milliseconds. No, 8 full seconds. These are intense. So wait 8 seconds for it to get an IP address, then attempt to do the connect with this password. And it will, that way you can turn on your K40 and it will automatically connect to your K4, assuming your K4 is already on. All right. Same thing for programming macros. Is you just function, hold down macros, and you put in your macro string, and you get the pop-up editor. Again, you can put a real USB keyboard in to type these things. Let's see. I'm going to skip part of that. If you do have a KPA 1500 amplifier connected, you want to be able to set this per band power option to yes. Then the radio will detect when the amp is switched from standby to operate, off to on, and it'll reset the power. The trick is you need to put the amp in operate mode first, then set the drive power the amp needs. A lot of people make the mistake of, well, let me back off the power to 20 watts, and now I'll turn on my amplifier. The K4 has remembered 20 watts for amplifier off, okay? You want to have amp in on and in operate mode, then set the drive power, and do that on every band, and then it'll remember whenever the amp is in operate, use this drive power. Otherwise, use the other one. If you're a QSK guy like me, you may be hearing these loud pops in transition. When you go back to receive, you can make those go away. And somebody said that happens more when SSNR is on and you have QSK. I haven't played with this unkey to receive and transmitting QSK when SSNR is on. I have a feeling we may need to increase the unkey to receive delay so that it mutes the receiver and you don't hear those big pops. Okay, so here's a summary of all the tips I've had, kind of an index. at the back of my presentation. Again, this presentation will be online in QRZ, my N6 TV QRZ page. And here's one bonus tip, and that is if you have a KPA 1500, then you can use the KPA 1500 band buttons to actually change bands on the radio with a single tap instead of 2 taps like it is on the K4. And you can use, if you use the tuner in the 1500, you can go ahead and set the low power tune menu of the K4 to 20 watts. And then every time you tap the ATU tune button on the amplifier, it goes ahead and automatically keys the radio with 20 watts and does a tune cycle and bypasses itself. So if you're doing it the old way, well, I'll start ATU tune, then I'll go to ready mode and I'll go into XMIT to make a carrier. You don't have to do any of that. Just one tap of the KPA 1500 once these menus are set, and you'll get your carrier. Again, my QRZ page is going to have a copy of this with all the links that you can click on. And Dave, if you want to come up and talk about how to do remoting when you need fancier port forwarding or a VPN. While he's doing that, if we have any questions, where did N6UOP go? He has the microphone. He's in the back. Please raise your hand if you have a question you want me to answer before Dave begins. Anybody? No questions? Got to be something. You had a question for Eric. Go ahead in the back there. Wait for the mic.
My question is it getting any easier to record live on the air and play it back? It seems like there's 47 easy steps to do that.
The AF record button that records live in the last 90 seconds reel, that doesn't work real well, especially if you try to keep it recording. They haven't fixed that yet. So AF record and playback, just use a sound card and a program like Audacity to record over the USB cable. That's probably the best way for now until they get around to fixing that. So you've got a thumb drive here. Okay, I've never seen a thumb drive with a little antenna, have you?
It's actually a little radio. You gotta find the port.
All right, let's close this one. This is Dave, K4 Sugar Victor, who's got a lot of experience setting up EVNs. Okay, it heard the sound.
There's only one file.
All right, we'll go ahead and open that. Starlink remoting.
Awesome.
Thank
You're
you.
the man. All right. Hey, everybody. I'm Dave, K4 Sugar Victor. They've asked me to do an hour presentation, and now I have 12 minutes. So what we're going to do is we're going to stop time for a minute, and we're going to go through this. How many of you guys actually run remote now? Oh, quite a few of you. That's great. So I'm a DXer. I'm retired. I have a place in Wyoming. I have a place in North Carolina, and I actually have a house in Nashville. So I can be anywhere. I go and travel a lot. So I had developed a remote station concept where it allows me to have a full operating station in North Carolina and its twin in Wyoming. I can operate it from Wyoming, from North Carolina, from my phone, anywhere, and I can operate either one of these stations. So let me just kind of show you. What I did here is I usually give presentations. I try to do some kind of background. The basic remoting of a K4 is really easy when you have a landline. You can do cable, fiber, or DSL. And we'll show you a little bit about that. You may be doing that currently, I don't know. The two things you have to do when you have a landline, as you know, you must have port steering at the radio side, not the control side. Control side is all you need is port 80. If you know anything about internet, port 80 is when you access the internet, it allows you to access internet on an outbound basis. But if you're controlling anything, you sometimes need to have port steering to control individual devices on the IP addresses that are local to that remote site. And that requires port steering. Now, to get to that remote site, you're going to need to know its IP address. Most of the home and non-commercial type of connections by ISP is what's called a dynamic address. This is assigned when you fire up your radio or your, in this case, computer. It gets an address assigned to it by the local router, and it's leased. That lease may be a day, a week, a month, forever, but that IP address is only loaned to that device. The downside is on a remote system, you don't know what its IP address is unless you have what's called a static IP. A static IP is what it means. You are assigned an IP address and that's it. That's always there. But don't usually have the luxury to have a static IP, as the need for them in version 4 IP is great. So you have to find a way of sharing that. And one way of doing it is there's an application called Dynamic DNS, and there's 4 or 5 other ones. But what it does is it checks its local IP every 5 minutes, and then it sends that IP to a server. When you fire up your device, it just goes to the server and says, hey, what's the current IP address? And then from there, it accesses your remote K4. And that's what allows you to do that. And that's with a landline or a cable or a DSL. But, and it looks very much like this, right? You have your remote router at the location, and you being accessing your port 80 with your controller, maybe a K4 or a K40, you're able to control it, right? So it's simple. Once you get out of your house or wherever you are at your control station, it jumps on the internet, and the internet goes to your IP address that you have with your DNS, and you just access your K4 and you can operate your system. Works pretty good. The problem comes is when you want to or have to have an internet connection on Starlink. Starlink is a wonderful tool. It is a port 80 device. What that means, when you get there, you get your phone out, your computer out, and you access the local Wi-Fi from their router, and you have access to the internet. But it's a wholesale transport system. There is no port forwarding. You can send messages to that IP address on your Starlink, and it arrives at the Starlink location, and it works okay. But there's no form of control. You can't talk to a computer, you can't talk to a radio, you can't talk to anything, because when data arrives back at the Starlink, it just pops out. There's no direction to control your device. So what do? You have to do what's called a VPN. It stands for Virtual Private Network. The VPN essentially allows you to assign the Starlink location a subnet of where you are. Okay, so if you know about IP, there's the IP address, and there's 4 sections of that IP address. The third section will set up the subnet, and what that means is you can segregate a section within your network. Now, this is very complex, and most people don't even understand it. But I will tell you that once you set up a VPN, the remote Starlink location is just the same as your local network. So if you have a house in North Carolina and you have a local IP address there and you're talking to all your devices, when you set up a VPN, it sends up an extension of your existing network in your house at the Starlink location. And that allows you then to do port forwarding to there. But you do port forwarding from the VPN side. So it's kind of strange. Now, can the average person set up a VPN? Probably not. Can a kind of a smart guy? Yeah, you can work your way through it. Our particular network is very complex. We have a dual VPN. We have a location in Missouri, and I have an IT guy who is an expert at setting up IT stuff that set up our network. How our network works is our home network is in Missouri, and we have 2 VPN connections to my 2 Starlink connections. Yes, I have Starlink in North Carolina because I live out in the boonies. My place in Wyoming is in the boonies. So the network in both of those locations show up in Missouri. I have an IP address, so I can access it right on my phone. I can bring up the network, and I can access computers and all that stuff in either location. But when I do it from my phone, it goes through my IP address that I have in Missouri, and then goes from there to the Starlink network, and then in turn finds its way to the remote location. And it all is one gigantic network. It's even configured such that I have, well, it's like our IP address in North Carolina is 10.56, I don't know, 56.2 dot whatever. And the one in Wyoming is 3. So it's just another section of the same network. And it allows me to intercommunicate between the 2 K4s as if one is upstairs and I have one downstairs. So it's transparent. But the mechanism in the IP address in the switches is where the magic happens. Most people can't even do that. I can't even hardly do that. I have an IT guy to do that. And you say, well, I want that too. Well, you're going to need to find an IT guy to make that happen. It's easy to do. The equipment's cheap. The equipment was bought from Amazon. We use micro tick switches that $200. You can buy them right on Amazon, and you have to program them. Can I tell you how to program them? No. You're going to have to define your network and then get an IT guy to sit down and configure the system. So that's the extent of it. Am I out of time? I got 3 minutes. Anyway, other than that, I can't tell you to go buy a said product. Now, if you want to talk about how we do our remote system and the mechanism, how we make all that work, I'll be happy to do that sometime. Today's probably not a good day, but I'll be out in the flea market for the next 2 days. If you want to stop by 9701, my Cybertruck's out there, I'll be happy to tell you about stuff, what I know. But we are very effective. We've got a bunch of members. I can access the network right now on my phone. I use a program called Real VNC. It's a commercial virtual networks program, and that allows me to access either one of the sites. But I'm about out of time. I'm going to get the hook. No, that's it. No, I had a short time. So anyway, any quick questions? Oh, good. Hey, there's one over there. What's that? Oh, once again? My site. Oh, 9701. You can't miss it. It's a giant Cybertruck out there. You haven't seen one? It's a giant stainless steel truck. Anybody else? Sir. What do I do about lightning with station? So I'm a communications guy. I owned a communications company for 30 years. So what do you do? That's a whole nother hour, right? But I will tell you that it's completely protected against lightning using commercial lightning protectors. I use polyphasers for all the coaxial stuff. I use other polyphaser stuff for the wire connections that go to the field. And you must have good grounding. One little ground with a number 5 wire or something going out there is not a ground. That's an inductor to something. Sir.
Yes, I need to address multiple K4Ds behind the same firewall.
Okay. Well, how we do it, since we're all on the same network, my North Carolina one is the stock 9204. Okay. And the one in Wyoming is 9205. It's fine. It's port steering. Remember, I can port steer now that I have the VPN. So I can port steer to 25 of them if I want. That's the answer. Each port is an IP address on the network.
So those ports are what the K4s are all listening on. But each K4 has a unique IP address, okay?
Right.
So if you're using Comcast router, it's a little difficult, so they only let you forward 9204 to 9204. But if you've got your own router, you can say, I want to port 8204 to 9204 of this IP address. And
Any address.
so you can use any external IP address you want. That's an individual's radios. The outside world sees 8204, but internally your router says that's going to 9204 of that K4, not this K4.
Right, it's the actual IP address of the device. Your amplifier, your K4, and so on, all can be a port. Any other quick questions? All right, sir. I'm sorry?
Latency on CW for DX chasing.
Again.
What's the latency on CW for DX chasing?
Oh, it's pretty good. You can't use a dial-up line. You got to have a decent internet connection. My CW is almost 100%. Yeah. All right.
Nope.
Wrong one. Yeah, I got the radio. It's a Motorola radio.
What is it? Is it
Just
for a
radio.
clicker?
Yeah, no, it's just a promotional thing.
Thank you.
Sure. Oh, then what?
Hi, I'll come back down. What's your call? Oh, okay, good. Let me come down. Let's get this. I have to fix this touch phone. Oh.
well, we do, I mean, yeah, we're here. Is this is I think they got this one in, so it would be a matter of larger check 1 2 check. Mic check 1 2. Everybody hear me out there? Mic check. Mic check. Mic check 1 2. Mic check 1 2 on the hand mic 1 2. How's it going?
Thanks again for the membership.
Oh, certainly, certainly. Come out and see some nice neighborhoods, get some more close by.
See you again.
Are you coming? Hey, at 12 noon, we're gonna have real tests for the Viavi guys. We're gonna play with the CX300s. Same place. Try it.
Great. Let's just go ahead and get started. One minute.
Good morning, everyone. My name is Alan Spindell. I'm the president of the Radio Club of America. And this morning's presentation at the Dayton Hamvention is RCA's engineering arc. We're going to present some historical information on Major Armstrong, Hazeltine, Ballantyne, and Beveridge. And these are 4 architectural ideas that shaped a century of radio. And we're going to talk a little bit about the superheterodyne circuit, the neutrodyne circuit, negative feedback, and Dr. Harold Beveridge and the wave antenna. We'd like to tell you a little bit about the Club of America, Radio Club of America. RCA is the world's oldest wireless society. It was founded in 1909. In 1910, RCA President W.E.B. Du Bois went to Congress. He was 14 years old. He was the youngest person ever to testify in front of Congress at the time. They went to committee to kill the Depew Act, and the Depew Act would have taken all the spectrum and given it to the military. In 1911, they came back and passed the Communications Act, which established the modern FCC, and had carve-outs for broadcasting, marine, public safety, and of course amateur radio. So we probably wouldn't have amateur radio today if it weren't for the work of the RCA. Please come by and see us at RCA booth 1811. We're right here in the corner of Building 1. We've got a great deal on memberships for $40, which is more than half off of a membership here at Hamvention. Amy Beckham, our executive director here, will take care of you. And we'd love to have you as a member. Give just a minute for my co-presenter here, Dave Bart, to come up, and we'll get started. So we're going to talk a little bit about these 4 inventor entrepreneurs and that were RCA fellows like myself and Dave here. And if you would, I'll mute your cell phones, please. Basically, we're going to talk a little bit about the problems that were solved by these circuits and Hazeltine's neutrodyne circuit, the heterodyne principle, direct conversion versus a superheterodyne receiver, and how just not changing the circuitry per se, but the architecture, the block diagram of the circuit itself actually solved the problem. Ballantyne was a quiet inventor. He really wasn't much into self-promotion, which is why people don't know much about him today, but he did invent the negative feedback principle. And every single amplifier that's here in the flea market and in all of the vendors' booths, they rely on the negative feedback principle which is the principle of all modern amplification. And it completes the superheterodyne story because without negative feedback, even if we were able to receive an RF signal properly, we wouldn't really be able to amplify the audio correctly without negative feedback, and the transmitter just wouldn't work very well either. We're also going to talk about the contribution of Harold Beveridge and the wave antenna and how wave tilt and traveling wave physics make that work. And it still is very, very, very relevant today, even though most people don't have the 9-mile traveling wave antenna that I think it was AT&T, right, Dave, built in Maine. When it in Maine? Amateur radio operators still use Beveridge antennas on LF and 160 meters regularly today. There's some plenty for sale here in the various buildings. So we're going to see how that arcs all the way forward to the modern era. We're going to talk about how RCA fosters a culture of wireless innovation through its collegial atmosphere and networking events. And we're going to talk a little bit about how this leads into Dr. Marty Cooper and the invention of the Motorola portable cell phone. And we're also going to talk about RCA fellow Ted Rappaport, the inventor of 5G, who I think is here this weekend, and how that led also to the Nobel Prize winners, Arno Penzias and Robert Wilson, who we recently honored, RCA fellows, and how they discovered the cosmic background radiation and proved the existence of the Big Bang. I'd like to welcome President Emeritus Dave Bart to the stage. He's my fellow RCA fellow.
Thank you very much, and great opportunity to share some time with my good friend Alan Spindell and to talk about some important historical figures. We're going to kind of share the microphones and punt back and forth a little bit, but we kind of want to set the stage with a little bit of background information. Where did these early circuits come from? And, it all kind of started with Reginald Fessenden, a Canadian-American engineer back in 1901 and 1902, who came up with the heterodyning principle, the feedback loop of mixing frequencies, to produce a lower audible tone. So, World War I comes along, and Edwin Armstrong, serving in the Signal Corps, comes up with the super heterodyne concept, significantly improved circuit. And by chance, Lucien Levy in France also comes up with a super heterodyne circuit. But Armstrong's is the one that you commonly think of today. And you can see it's an international effort to come up with these circuits. You have a Canadian, an American, a Frenchman, but it all kind of happens at the same time. So, the paradigm was ripe, the circuits were there to be discovered. So how do we go back and forth here? So a couple definitions. And Alan, of course, we'll talk more about the details of the circuits as we get going here. But the key thing to remember is that the TRF, the tuned radio frequency receiver, amplifies the signal directly, whereas the heterodyne converts the radio signal to IF. Now, you guys are hams, and you probably know this. And then there's the super heterodyne. But this was a new world in 1920.
So everyone's seen these pictures of antique radios, and they've got all these knobs and buttons and switches and levers and dials. And that's because they were TRF radios. So you had to have all of these separate amplification stages and all of these separate filter stages to cover the different bands and things that the radio covered. And each one of those stages had multiple tuning elements in inductive and capacitive elements. And each one of those things got a knob or a switch or a rotary switch or something. And, the instruction manuals on these things were like a phone book. It really took a lot of knowledge and practice to be able to even tune in a simple broadcast signal on one of these radios. And so, like everything else, the people that use these radios were early adopters. And so this wasn't something that people normally had in their living rooms. They would have been the folks like are here at Dayton, technically minded people that were willing to overcome the learning curve to use one of these complicated radios. So the thing that we find in a TRF radio is 2 to 3 cascaded triode RF amplifier stages. And each one has a tune tank circuit, usually with a separate knob for the L and the C. And it's almost like tuning up, a ham rig. You've got to walk it slowly with one knob and the other until you get that station tuned in. So the big problem with these is they have their own internal RF feedback path inside the tube. That's the grid to plate capacitance. And those of you who are more familiar with transistors, we call this junction capacitance. And it can be actually an important lumped element in the circuit. In this case, even the 5 to 8 puffs that are there in the CGP is a swamping element. That's actually enough capacitance to become a significant element in the circuit, and it has to be taken into account in the equivalent circuit of the tube. The other problem is the Miller effect, and that has to do with the tube's transconductance being nonlinear. And so basically you had 2 or 3 circuits just in the RF amplifier stage, each one capable of going into oscillation at any time. And y'all all know that's just not a good thing. So to get the gain that you needed to receive a weak signal on a TRF receiver, you would probably have put it into oscillation 2 or 3 times and then had to quench that. So as I mentioned before, some of these early transceivers, this is a 1920 style broadcast receiver. It's the Federal Model 61 from 1924. It was known as the tabletop monster. And it's probably one of the really nicest examples of these things. If you look carefully up at the top there, you can definitely see there's a complicated set of instructions there for the user, and that's just a quick reference. It came with a lengthy instruction manual, And you can see how difficult it could be to learn how to operate this. It had 6 tubes inside, 5 O1As and 1 double-aught A detector tube. It was good for 220 to 550 meters. It had 16 dials and knobs. And if you put me in front of one of these today that was working, well, I'll pretty much challenge anyone in the room to try to pull in a station on it. Let's talk a little bit about Louis Hazeltine.
So Louis Hazeltine was an American engineer. He spent most of his professional life at the Stevens Institute. And he came up with this concept of the Nutridyne in 1923. So we're still pretty early, 1923. And this idea was that he would neutralize the interference in the circuit. And he would simplify the big box of knobs down to 3 knobs that were sequenced. And this made radio accessible to the general public. Now, Hazeltine's circuit is so important that the IEEE honored it in 2024 with an IEEE milestone. And there was a big ceremony at Stevens Institute, and a number of people from Radio Club of America were involved in that effort to memorialize this circuit and then commemorate it. You want to talk a little bit about the circuit itself?
So we talked about the problem of self-oscillation due to the grid-to-plate capacitance and the Miller effect inside the tube. So what he did was neutralize that, and that's why he calls it the Nutridyne circuit. There were a lot of other problems with TRF radios, but first we had to solve the problem of the self-oscillation. So what he did was, instead of trying to eliminate the oscillation, because there's no way to crawl inside the tube and change that inherent capacitance that's in the equivalent circuit, he found a way to cancel it out. So what he did is inject an out-of-phase feedback current that was equal to the grid-to-plate capacitance. So what he did was he figured out a way to do that using the interstage transformer, which was already there in the circuit, by rewinding the core ever so slightly, and that produces 180 degrees inverted plate replica. It's kind of a thing really similar to a hybrid coil that creates a differential pair circuit, which allows noise to cancel out on a 1.2 kilometer long landline. So then what he did is he added another capacitor in there, a DC blocking capacitor, because you still got to have the grid bias in there for the tube to work correctly. So he added a neutralizing capacitor in there in order to couple this inverted phase signal onto the grid. And then at the factory, they were able to add or take away just a little bit of capacitance there using a trimmer capacitor, which we're all familiar with even today. And that was done on the factory assembly line, and that would calibrate the radio. So the thing is, though, and if you look at the equation that we have here, he balanced the two effects. He took the internal, what we would call the junction capacitance that was causing oscillations. He added an out-of-phase signal into it to cancel that out when one started to occur, and then he made it unconditionally stable. However, the Nutridyne just patched the symptom of self-oscillation. It still kept the TRF architecture and all of its other underlying problems. These are the things that weren't fixed that really were left to other inventors. So it gets to be this problem of, you know, for a broadcast band receiver from 550 to 1500 kilohertz, that's a 2.7 to 1 span. So you would actually have to have gang capacitors and some kind of a rotary switch to switch between them. Each one of them would have to have multiple trimmer capacitors to get this thing to have a flat response over its little section of the passband. The other thing is the Q of all of these different stages in the L parts of this were all different. And so you had some very high Q filters that you needed, But the drift just killed that. It took you on and off the carrier frequency as the temperature in the room changed or whatever else. Somebody walked by, their body capacitance. And then the other thing is this, is that there was terrible image rejection. So even the harmonics from adjacent channel stations that were well within specification were still picked up by this thing because it had terrible selectivity. If we were talking about a receiver today, we would say it's wide as a barn door and it's picking up all kinds of adjacent channel interference. And so, and actually, to use its modern term, image rejection really isn't a good term because its selectivity was so wide, it was more like image collection. At any rate, we mentioned these adjustments and tuning capacitors, trimmer capacitors that have to be in there. It was just a nightmare on the assembly line. You really had to have a skilled worker who really knew what they were doing to get one of these things all lined up and ready to ship. So we're going to talk a little bit about how they solved all of these problems using the heterodyne principle. And so this is the heterodyne equation. And basically it says that the resultant waveform, and that's a sine wave or cosine wave, is equal to half times the product of the sum of these two frequencies. So those of you whose mathematic education may have been slightly nipped in the bud, that's called a mixer. And that's basically the mathematical description of what we would call a mixer in the intermediate frequency chain of a modern receiver. So what happens is when we mix these two frequencies together, we get a sum and a difference. And the way I've explained this to people many times is we've all heard about imaginary numbers, and your teacher says, well, that's the number on the other side of the zero axis. Well, this is a case where we're creating a similar situation here, except that we've moved this in frequency up to the right of that zero axis. And so you're actually seeing that imaginary part there, but it's in the real world because we're doing this at a frequency that's not right in DC on the zero axis. So this is the thing, is you've got to find some weird nonlinear element, and a light bulb is a good example of one, but it burns out. And this is kind of what led DeForest to the development of the vacuum tube. You need a diode, some kind of a biased triode with a grid or a pentagrid converter. But if you can get these two injected signals, a local oscillator frequency signal that it's at a fixed frequency, because it's really easy to make an accurate oscillator at a fixed frequency, even for these guys back then with their crude equipment, and then have your receive frequency come into this mixer, which was the new thing that was invented. You're able to keep all of your filters with a very narrow Q all at the same frequency around in the passband around the local oscillator frequency and its product frequency. So Fessenden used this for direct CW reception. He got it really close, really close. He didn't get the full heterodyne, but he managed to make what we would call now a beat frequency receiver. And he was able to inject, I think it was a 50 hertz carrier multiplied, and if you look at the math here, against a 51 kilohertz local oscillator, and that gave him a beat frequency of 1 kilohertz, and he received CW that way without all of the 16 knobs. Let's talk a little bit about the autodyne,
So as Alan was just saying, Fessenden's heterodyne used a separate oscillator to generate the signal and then mixed it, okay? But we have another guy come on the scene. His name is Captain H.J. Round. He was the chief engineer for the Marconi companies in England. And he's the originator of the so-called round soft vacuum tube. And he comes up with the regenerative self-heterodyning circuit. Now, Round's circuit is also very important, and Round was also involved with the Radio Club of America. So he would come back and forth over the ocean to work with the Marconi companies here And those Marconi companies eventually, after World War I, become the core of the Radio Corporation of America. So the war comes along, the United States government wants to own the patents, they want to own the technology, they create a consortium, and that consortium is Radio Corporation of America, and Radio Corporation of America buys all the Marconi patents and their installations and everything else, and this was all originally designed by Captain Round. So Round spent a lot of time here, and he was an active member of Radio Club of America, and his idea was to have the autodyne. So he wants to use the same tube for both the detection and the local oscillation, and it creates a simpler, more compact receiver by basically doubling the function of one element of the circuit.
So this is what happens in a direct conversion receiver, you know, a TRF receiver that's been modified slightly to have a local oscillator. And this was the intermediate step between a modern transceiver and a TRF receiver. And so if you take a look at the direct conversion block diagram, you see that we have an antenna and an RF amp, but now we've added this mixer, what I spoke about earlier. And that's your nonlinear element that's going to take these two signals, one that's incoming, the broadcast signal you're trying to receive, the other is the signal you generate internally in the local oscillator. And we're going to, quote, mix those two together, which is a fancy word for multiply. And the problem with the autodyne circuit was this, without real true IQ down conversion, the two sidebands fold together at baseband. And then you're back with an interference, intermodulation, and distortion problem. You know, the other problem is actually, it's not really shown in the equation that I showed you before, but there are DC offsets that come out of this self-mixing and what's known as the 1/F noise. And this falls right into the pass band of the audio band, just like this guy generated the 1 kilohertz beat frequency. These are essentially spurious beat frequencies that come out of this mixing. And then the worst problem is there's really nothing to stop this local oscillating signal from going back out the antenna the wrong way. And that's the kind of thing that has FCC inspectors knocking at your door with lots of paperwork. And we try to avoid that. So it turns out, though, that technology is always coming back around on itself. So in the 1990s, when software-defined radios were developed, it turns out that you can counter all of these problems when you're doing all this in digital signal processing. And so direct conversion has come back all the way around and can be done very efficiently and easily in software. So these principles are still being used today. Now, what Major Edwin Armstrong did was take that, and we learn, of course, when we study the nature of entrepreneurship and inventors, that people build upon the inventions that already exist and improve them in an iterative way. So if we take a look at this, what Armstrong did was he put another circuit in there, which is an RF pre-selector. So he wanted to eliminate as much of the adjacent channel and out-of-band interference as possible. But the main thing that did was prevent this problem with the autodyne circuit of the local oscillator radiating back out the antenna. Now, they still do that a little bit, and the Nielsen company used to have these vans that would prowl suburban neighborhoods, and they could tell in the days of old leaky vacuum tube TVs with a big antenna on top of the van what TV channel you were watching because of the local oscillator leakage. Now, a lot of that wasn't necessarily coming out of the antenna, it was just leaking out of the set itself. But, you know, once all of that improved and sets didn't leak as much, then they had to go to a questionnaire method that they mailed out and offer people financial incentives to find out what TV channel they were watching. But at any rate, this is the whole point of the super heterodyne circuit. We no longer have to have multi-stage RF amplifiers. We no longer have to have all these weird tuned circuits and knobs and ganged variable capacitors and variometers and rotary switches to switch them in and out for the different parts of the receiver's RF passband. We can make everything in the intermediate frequency amplifier chain work at one frequency, and that's going to be the product of the local oscillator frequency and the incoming frequency that we're trying to receive. Then we go to our detector tube and an audio amplifier, and suddenly all these problems, since we've converted every received signal to one fixed intermediate frequency, we've solved all of these problems that I just mentioned, including the calibration nightmare on the assembly line, because we have only one amplifier chain to calibrate. Now, we do all of this selectivity, all these problems I was mentioning before about spurious products appearing in the audio passband, they're gone away. So we're just working at that one fixed IF, and we know every design parameter of that narrow passband. The thing is this, is that we only really need one variable frequency part, and that's a single gang variable capacitor, and we can tune this whole radio across the entire AM broadcast band with that one variable capacitor and a trimmer capacitor for calibration on the assembly line. Everything that we need to do that was such a difficult effort with all those knobs and rotary switches and variometers and multi-gang variable capacitors and their trimmers have now been eliminated, because all of that happens at one fixed frequency, and that's the local oscillator IF frequency. So the thing is that, well, what frequency do we pick then for our local oscillator frequency? And originally, like everything else in electronics, there was chaos. But then everyone pretty much decided that for the best thing and to work with standard value components, 455 kilohertz pretty much worked out the best for AM, required the minimum calibration on the assembly line. And then 10.7 megahertz is pretty much the standard for FM broadcast. So if you look at direct conversion, here's some comparisons about it. For time's sake, I'm not going to go through them in detail. But if you take a look at the slide, you'll see where all of those things that I just mentioned that were so complicated under direct conversion are now vastly simplified using the super heterodyne circuit. But once again, he didn't develop any new component. He didn't develop any new chemical process or thing that made some coating on the grid that eliminated the capacitance. He changed the architecture of the circuit to solve the problem. So once again, this is also what I just mentioned about the simplification of between a variable frequency capacitor and the fixed frequency IF step. And these are, once again, all of these problems that were solved by Armstrong's architectural change in the block diagram of a simple broadcast band receiver. So he didn't actually build a better triode. He didn't develop some process for manufacturing one. He didn't develop a new type of tube or some exotic metal. He just found a better place to put the triode in the circuit. So every radio ever built since then is a descendant of that particular architecture, except for a few modern DSP radios these days. And even them have most of these components, IF strips, DSP and SDR software radios. They're all based upon this original architecture. The modern SDR is the same thing. It digitizes at a fixed rate. It processes in a frequency agnostic domain. Once again, eliminating the problem to a narrow passband where we know all the parameters, and we can simplify that circuit. By the mid-1930s, nearly every commercial AM receiver in the world was a super heterodyne, and it's still the default architecture a century later.
So how did the nature of the innovation come to be? So it's important at a Hamvention, especially with young folks, to understand that the Radio Club of America was founded by teenage boys. You know, these were kids who were interested in technologies, and they originally started out as an airplane club. And they were tutored and mentored by a woman named E. Lillian Todd, who lived in New York City, and she was a designer of airplanes. She's very famous. You know, there's in the history of airplane flight, because she was a woman at a time of male dominance. She was trying to get coverage for her cause, and she came up with some unique designs. And there's a picture of her, and you can see her. I mean, she almost looks like, you know, the Wicked Witch of the West there, sitting on her little airplane. And she was tutoring these teenage boys, and they got interested in wireless. So she changes gears with them. And Frank King, you can see on the left there, at 17, was one of the founders of the Radio Club of America. And lo and behold, who did they get to be their consulting engineer? Reginald Fessenden. I mean, of all the mentors you would want, you know, a female inventor and a radio genius. And he takes these teenage boys and really launches their curiosity. And they were given space at the Hotel Ansonia in New York to have a radio station. By 1911, they had changed from the Junior Aero Club to the Junior Wireless Club, and finally the Radio Club of America. So what happens? World War I comes along, and all of the guys in this club serve. And in the period of that service, they start to network with other wireless people. And by the time the war ends, of course, you know, they're all older. They're all centered in New York. And lo and behold, Armstrong ends up at Columbia University, and his mentor is Michael Pupin, the famous physicist. And this club starts to grow, and they network with each other, and New York is a real hub for the development of radio. So the circuits that we've been talking about, Hazeltine and the Nucleodyne circuit, and Ballantine and the negative feedback, what's the missing component? The wave antenna. You want me to give I guess we'll split this. So who was Ballantine? Well, Ballantine ends up with 30 patents. He's eventually the president of the Institute of Radio Engineers, which is a forerunner of the IEEE that you know today. So the IRE, Institute of Radio Engineers, merged with the American Institute of Electrical Engineers, AIEE, and they formed the IEEE in a merger in 1960. But Ballantine was a Harvard graduate, and he has a math background. And he founds his own laboratory, and he focuses on the principle of negative feedback, which Alan has mentioned, and we'll talk a little more. And as with our earlier discussion, lots of people are working on the same problems. So there's another guy, Harold Black, who comes up with something similar. But Ballantine, the quiet inventor, is the one that you associate with this discovery.
So I learned this very early in my first circuits class. If you have an amplifier without negative feedback, it has tremendous gain. Even a simple JFET amplifier can have a gain of 200, 300, 400, or even 1,000. And that's the big capital letter A, which is one of the most important letters in all of electrical engineering, or parameters. And so we give it an important letter, A, capital A, the amount of gain. And that's how much that an amplifier circuit amplifies your signal. Now, the problem when you have an amplifier circuit, you're trying to hook up your Walkman, and you've got a speaker, and the Walkman puts out at a fixed volume, and you put a potentiometer there in series between your Walkman and the amplifier, and you have a gain of 1,000. You just take that and you start turning that potentiometer, and it's really quiet. Then it gets really, really, really loud and starts to distort really badly, very quickly. So you've got to have some way to control that gain, and that's what negative feedback does. If we take a signal from the output of the amplifier and invert it and put it back into the input of the amplifier, all of a sudden everything's different. It's no longer like a car engine. How can you drive a car when the engine is running on the red line RPMs wide open all the time? You'd start the car and you'd take off out of your driveway at 100 miles an hour and smash into your neighbor across the street. But when you can throttle that and control it and control the amount of feedback through the feedback resistor. And that's the loop gain there. That's the beta minus A. Then all of a sudden, this amplifier just starts to behave itself. You get a gain of 3, 5, or 12, and you can deal with that. If you need more gain, you can add another stage that has a gain of 2 or 3 and handles a lot of power and a lot of current with big power transistors. And that's what's making my voice heard in this room without feedback and squealing and distortion, because these amplifiers and these speakers have negative feedback. That's why my voice sounds so good. Now, what does that get you? Your distortion is massively reduced by the loop gain, because you're no longer running this engine as fast as it can go. This also makes the big trade-off. It's what we call the figure of merit in amplifiers, or the gain bandwidth product. All of a sudden, because the amplifier is just not screaming, trying to amplify sound, we get all kinds of helpful things from that. We're able to use more of the bandwidth of the amplifier because its gain isn't maxed out. This does the greatest thing possible, because in an amplifier, we want a low output impedance and a high input impedance so it doesn't swamp out and drag down the source. And that's exactly what happens with negative feedback. Also, this stabilizes the gain. When you've got a gain of 1,000, and you know, what's 1,000? What's 990 or 1,100 when you're at 1,000 at that order of magnitude? When your gain is 3 or 4, it pretty much stays there very stable, because you do have that to work with as part of your equation in the feedback loop. If the gain changes from 990 to 1,100, your open loop gain, your closed loop gain might only change from 3.1 to 3.2. And that's going on right now inside these speakers. But you don't notice my voice going up and down, because you've got that headroom to work with in your closed loop gain structure. So this whole thing is set by the gain, the feedback resistor in the feedback loop. And that's a fixed parameter. And if I buy 100 transistors off the assembly line, the beta, or the amount of amplification that that transistor gives you, is going to vary widely from transistor to transistor. So if that is the factor that's affecting our gain, every amplifier that comes off the assembly line is going to have a different gain. But if I throttle that with a feedback resistor and negative feedback, then I can literally have, no matter what the gain is of the transistor that I'm using, or tube, or amplifying element, you know, it really doesn't matter, because the gain is going to come out about the same every time. Why does this matter in early radio architectures? Well, before negative feedback, they had that exact same problem. You know, you've got drift. You come in one day and the temperature's one thing and the radio's really loud. The next day it's distorting, it's even louder, and then the next day you can't hear it. You know, so you need consistent performance from your audio and your RF amplifiers. The nice thing about, so the superheterodyne principle solved all these problems of self-oscillation, Miller effect, all of that, but they really didn't have a good, reliable amplifier. And amplifiers are so important. They're all the block diagram elements of a radio practically, except for the mixer. You've got RF amplifiers, IF amplifiers, and audio amplifiers. That is a block diagram of a radio. So unless you've got a decent amplifier, you're not going to have a decent radio. So here's basically the way the arc went from Ballantyne to Black to Nyquist to Bodie, and that gave us fixed IF plus feedback, gave us a predictable, repeatable performance.
But it all depends on the antenna. And Harold Beveridge comes along, another member of the radio club, and another person who is both professional and amateur. He has that independence of spirit, that entrepreneurial view of trying to find something new. And he spent 40 years working at General Electric, and he built a new antenna 9 miles long in Riverhead, New York, up on Long Island. He was also part of the transatlantic test, to get, his antenna was used to get the first low-power signals across the Atlantic. Remember, at the time, you had gigantic stations, Alexander-type transmitters, huge crashing circuits to try to blast the signal across. He comes up with an antenna. You know, if you can't force the power across, maybe you can detect the power with a novel type of receiver. What an interesting innovation. It's the same thing that made the transatlantic telegraph work. They couldn't blast the signal under the sea. What they did is they came up with a very sensitive mirror galvanometer. That's one of the reasons why Sir William Thomson became Lord Kelvin. He came up with that innovation. You have the same thing here. The Beveridge antenna is a highly sensitive way to receive. He eventually gets the Medal of Honor. He gets the Armstrong Medal. You want to talk a little bit about the antenna itself? How does the Beveridge's wave antenna really work?
Most of the antennas that we use in amateur radio are tuned antennas. They're designed to receive at a specific range of frequencies, and they work in a very different way from a Beveridge antenna or a traveling wave antenna. And so those of us who may have had some electromagnetic theory, maybe high school physics, remember the right-hand rule. And that is, in terms of a receiving antenna, for example, if it occurs an electromagnetic wave occurring in this direction, that's going to induce a current going in that direction. And the same thing for an electric motor. If you have a current going in that direction, it's going to create rotation in an electromagnetic wave in that direction. Now, the reason that this is different is that we try in amateur radio to have as short of an antenna as possible, because we're going to have a fraction of the wavelength trying to jump off of that antenna into the ether. The traveling wave antenna is the exact opposite principle, and that was the whole innovation of Harold Beveridge. Is he took a contrarian view of antenna design and said, instead of trying to make the antenna as short as possible, let's make it as long as possible and pick up as many wavelengths as we can along that antenna. And we're just going to let them travel down that antenna, and we're going to pick it up at the end. Now, I tried to get this into the slide, but it wasn't quite time. That should be a squiggly line right there, like a resistor. And it's very important to have the terminating resistor properly at the end of a Beveridge antenna. And some innovative ham came up with the idea that if you put a switch and a resistor at either end and ran two wires, then you can change the direction of the Beveridge antenna. And I think they got one over here at a certain DX Engineering. You can buy a little box that does just that. The Beveridge antenna is very directional because, like I said, we're trying to induce a traveling wave along a very long wire and then pick that up at the other end. So the thing is this, is that we've already spoken about using cancellation, wave cancellation, to neutralize oscillations inside an amplifier tube. But it's very important that you have no reflections on that wire, because that'll cancel out the very, very, very low magnitude signal we're trying to receive. So it's really important that we have terminations at either end of this properly, so that there's no other reflected waves traveling up and down our traveling wave antenna that's going to cause cancellations. Now, we still use these kind of antennas. So the thing is this, we know that there's noise coming from every possible direction. If we can get an extremely directed antenna, and I see lots of parabolic dishes and Yagis and log periodics out here at Hamvention, and that's the whole idea, is to create directional gain and eliminate external sources of noise. So what we want to do is trade that efficiency for directivity, and that's the principle of the Beveridge antenna. So in the 1920s, up to World War II, every American commercial transoceanic receiving site used Beveridges. And in 1927, AT&T had four-phase beverages that were 5 kilometers long, and this was the American end of the transatlantic telephone system. 2026, today and onward, LF, MFDXers, shortwave listeners, and top band users, they still string up the basic geometry because that has not changed. And as Dave will tell you, this conceptual ancestor of beamforming, phased arrays, adaptive knowing, and multiple in, multiple out spatial diversity is what drives all of our modern devices and phones and public safety communications that we use today. So we'll let Dave talk here about a little bit about the club itself and how it fosters wireless innovation.
So remember those teenage boys experimenting? Remember their mentors who taught them about the idea of independent thinking, contrary viewpoints, out of the box thinking, all the stuff we try to encourage our youth today to develop. That early formation of Radio Club of America held true into the 1920s when those boys grew up, and then they attracted the professional class of the inventors we've just been talking about. And the club defined itself differently than a professional business association. The IRE was a professional association, okay? The club was specifically designed to be a place where people could just freely share their ideas. Everyone was welcome. The professional, the amateur, the garage innovator, company leaders, and you had this fostering of the club in the 1920s, which really defined its next century of operation. And the focus of the club today is very much the same. It's about building bridges, not barriers. That RCA ARC that Alan's been talking about, Armstrong, Hazeltine, Ballantine, Black, Beveridge, they didn't build a better element, they built a better architecture. And I think that's the other key theme of the Radio Club of America, by networking and talking to each other, by sharing ideas, by getting out of your comfort zone and talking to someone in a different professional field. Today we would say there's vertical channels of developing radios and selling them. We want to cut across those vertical concepts and have people feed off of each other's ideas in an open conversation that stimulates thought. So by 1935, the club wanted to honor Edwin Armstrong. He had been a major contributor to the club. The club was hosted at Columbia University. Many of the new circuits were featured there. The club honored Armstrong with a diploma-type document, a certificate, in 1935, and that became the basis for issuing the Armstrong Medal. Now, this is a world-famous medal for innovation. As you heard about today, Hazeltine, Beveridge, Ballantine, and Round would all receive this medal. But the medal was also given to Harry Houck, Armstrong's longtime collaborator who worked with him on circuit development. Houck saved a lot of Armstrong's original experimental equipment, and that equipment was all donated to the Antique Wireless Association. So they have Armstrong's original FM receiver. They have the patent models from the DeForest Armstrong litigation over the design of the early circuits and the use of the triode. So what you see is that the networking and the collaboration, the search for innovation does get recognized. And it's recognized more broadly than just members of the club. There's a famous book called Radio's 100 Men of Science. So Orrin Dunlop was a scientifically trained editor of the New York Times. And he was also on the executive staff of Radio Corporation of America. And he started informally polling the leaders in the radio industry. And he wanted to know, where did it all come from? Who played the most important roles? Who really affected and radically changed radio? And as Alan has just told you, it's about the architecture as much as the design of an individual element of the radio. What were some of the key mileposts? And he compiled this book called Radio's 100 Men of Science. And this is like a defining book of the major contributors. And incredibly, 15 of the people in the book are RCA members. And they were either members, award recipients, or fellows. And that's another program that we have that recognizes innovation and contributors to the science of wireless. And it's an astounding legacy of these people. People who know the history of radio would recognize all of these names, and you can see that Michael Pupin, Fessenden, Armstrong, Beveridge, Ellen B. Dumont of the Dumont Television, John Stone, early wireless. You know, all of these guys were members of the club. But why did they come? And why do they come today? Because they continue a tradition of openly sharing ideas. They put down their competition. You know, a lot of these guys had companies that competed with one another. But they came to the club and put those identities aside for the sake of just talking and sharing an open conversation, new ideas. Well, that's continuing today. And there's a bunch of names on here that visitors to Hamvention would recognize. Ted Rappaport, who's not able to attend this year, the developer of millimeter waves, 5 and 6G. He's created multiple laboratories from Virginia to the University of Texas to NYU. We honored Robert Wilson for his astronomical research 2 years ago. He received the Nobel Prize for discovering cosmic background radiation that proves the Big Bang. Arno Penzias from Bell Labs. Ulrich Rohde, who many of you may know from his digital radio background. Steve Floyd from designs and manages the HARP antenna research facility up in Alaska. Joe Taylor, of course, is well known for moon bounce and was one of the originators of FT8, I think, right? And Chip Cohen is sitting right there.
Normally, it's me that gets embarrassed, and I rarely have the chance to embarrass someone else. But the arc of the RCA extends right into this room right here. RCA Director and fellow Dr. Nathan Chip Cohen, the developer of the fractal antenna, the one that's in all of our cell phones, and the Cohen equation, among other things. Chip, congratulations.
Keep on going. You know, and the cell phone itself, Marty Cooper from Motorola. Now, remember, Marty Cooper did not invent the cell phone, okay? But he invented the Motorola cell phone. And you know, he was on our board for a long time, and he came up with Cooper's Law on the ability to double the capacity and utilization of the phone's bandwidth. You look like you want to say something.
He also made the first portable cell phone call outside his office in New York City, and he called his competitor at AT&T.
But we want to give you a little bit of sense about why. You know, Radio Club of America never sought to have thousands of members. We were a small, intimate group, and here you can see our age range. You know, the young people that come and participate with us are invited on stage to present their ideas. It's a mentoring environment. And yet, you have, I mean, you can see in the bottom right there, which one's the button for this? There we go. Or is it right down there? There's Tim Duffy, who most of you know, and Ted Rappaport, and the Bell Labs folks were here from these presentations. This is an open, inviting atmosphere, and we have our annual technical symposium, but we're also very active at industry events besides Hamvention. We run technical programs at IWCE, APCO. We've gotten back involved in the NAB, thanks to Alan and his connections, and you know, and we publish twice a year a pretty important magazine. It runs 120 pages twice a year with leading scientific articles, as well as, of course, pictures of all of us having fun. But the idea is to not only just hand out awards and recognize people, the awards and the fellows, but this is a place, as I said, from the 1920s where the industry leaders come and they let their hair down and they just have fun together. I remember sitting at a table where the designer of the space shuttle's communications was all intrigued with, my wife who had background in autism, and the idea is how does the signal, right? How does the brain work? And they're thinking about it from two different worlds, and that inspiration can lead to a new concept for architecture design. So it's this idea of cross-pollinating. But we also celebrate places. We go on tours. We've been to a number of historically important places and laboratories, and every year at our major banquet, we do try to go to the local places of interest. We've been to NYU laboratories, Georgia Tech's laboratories, InfoAge, the old Marconi sites. We've toured Bell Labs, AT&T's labs. So there's quite a bit of WWB and the NIST laboratories. So we want to encourage you to think about participating because we want your ideas. Here at Hamvention, we're very involved, not just in the technical forums, but as many of you know, we ran the youth forum and continue to run the youth forum, and we're involved in the leadership team here. But a lot of the booths and the exhibits you see, those companies are led by our members. So this is a snapshot of our website, and the idea is find your people. Let your hair down. Talk about what you're interested in. Our booth is located over in Building 1, booth 1811. And we want to thank everyone and ask for any questions you may have. Chip?
RCA is a great mutual admiration society, and everyone enjoys each other's company, and all the barriers are down between professionals and academics and amateurs and those who have a bent for innovation in electronics and radio. So we want you to participate. If you're interested and have a knack or even just historical interest in radio and wireless, join us. We'd love to have you.
Great. Thanks, Chip. On behalf of the club, I'd like to thank everyone for attending our presentation. I'd like to remind you, we'll be back in room 3 with the Viavi guys, and I believe it's a $40,000 service monitor to test some amateur radio equipment and demonstrate amateur radio performance evaluation techniques. See us tomorrow morning. I think it's 9:30 here again in Building 3 for the Youth Forum. There are door prizes. If this is your first year to attend, you must be in the door by 9:45 to receive a ticket, by the way. So come and see some amazing presentations. Last year, the 9-year-old girl who was into SHF contesting just stole everyone's heart. And I've already met some of the presenters this year, and it's going to be a fantastic forum. Like I said, come join the RCA and find your people. Come see us at booth 1811, and Amy Beckham here will get you signed up. We've got a special on membership. We try to keep it like AAA or AARP or something like that. It's inexpensive, and we'll even offer you a free complimentary 1-year membership if you'd like to just try it and get started, or at least get your name on our mailing list. Everybody, thanks so much for attending.
Thank you very much, and go out and celebrate innovation.
Yeah, hold it.
Hold it. All right.
$12 Yeah, it's.
So you know the drill, you're all set.
Yeah, no, except that we've got some equipment. We may need to do something, because we got a piece of equipment we want to try to project up there, and it's on its own laptop.
Okay, so
I'm not sure exactly, and these are the guys.
what I told him to give this to you and tell you. Oh no, he's CW. He won't talk to me. That's great.
Okay.
No, I'm working on it.
So this is Don, Steve. Okay. And he's the AV guy.
No,
He plays one
I'm the DE for him,
Yeah,
yeah.
he plays one on TV.
But I found out with salty dog spawn, you can, it's in my notes, it's in my notes. You can use your own laptop. I gave you bad info before. No. So we should be able to, so you should be able to just plug, if you got HDMI on, plug that in.
Okay, well, yeah, we'll figure it out.
Okay,
Yeah.
like the AV guy should be over there.
Yeah.
All right. I'll be on. I got a couple of things. Come on. Look, it's a great one and slow down. We're so much fun. Myself. I decided I'm working on this. Right. That's what so it's every year. So I got our awards. Every year I got unsung heroes and wireless. And get awards. We gotta get this all. Notes that if something that we don't have, take it. You know, I never tried to pass it on. Slide there with well, let me introduce you. What's the beach? I understand. I mean, I'll be honest with you. I can't think of it's only gonna go. So they got a squeeze paddle on the street. And if midnight, the rubber hits the none of my radios. You form tomorrow. If you're new to Ohio, that's it. It's that a lot of things like we're doing. This is not a whole presentation because I'm not and that's why it's slowly going. It's just so like, you know, like I think it's around 25 words, but I want to think it out just like that. I want to listen to the sound of one. We're the sound of one. I don't want to graduate. I don't know. I mean, if I can get sure. So Mike, the game was actually when I made it time back yes. You don't get running 20 minutes with the microphone my help bugs. He's like and he's like this is Logan, he's an actual talking to him. But anyways, I'm sure it's oh, so we have actually a projector array. No? I said, we need to bring it on with you. My grandson sent my grandson. We're in building one. No. Where are you at? Oregon. Hello. Oh. I don't think the word nerd was actually in my vocabulary when I was in high school. Oh, I gotcha. We were having trouble connecting. Yeah, 3 miles radius, like Stevens Valley. Turns out that hello, 1 2 1 2 test. Okay. You can extrapolate that. We really have these filters that are easy to Steven? Oh, you're Steven too? Jeez. We were trying to set up a direct. Yeah, you want to come out of RCA. Was it from Alan? Was the email from Alan?
You need the presentation? It's
Yeah.
right here on this drive. Just use the drive.
2 different static things. So I put them in antenna. I'm CompTIA. I understand that. But this thing, his laptop, is covered by it. So in fact, if we got enough material, we can't do it all in an hour.
I got another laptop. I don't know. You guys have brought the expensive piece of test equipment. It needs to be.
If you can, it's static IT working on that laptop, so that we can run the cable. Okay, I need that back caption. That would be fabulous. Yeah, I know. I didn't want to.
Do you need internet connectivity? Because once we do this, you'll lose it.
No, we do not need internet. We're
No.
So you just want to run it. You just want an Ethernet directly from here to there. Okay.
And you've got a cable somewhere.
What are the network settings on that?
Well, I can make them whatever the hell we want. Right now, I'm at 192.168.1.1. You don't have the interface in that, but I will fix that for you in a moment.
Okay.
I couldn't even get his laptop to give me anything on iPhone. He would show me everything.
Yeah, there's not a NIC connected to it, so you usually won't see it.
No, it's got a USB. No.
Yeah, but that's why you wouldn't have seen it.
There you go. It's got an Ethernet jack on it. It's set to 192.168.1.5. Standard process. You have a cable, you have an extension you get from there.
Ah, there it is.
And right now, this is your internet. Seems to work. You can make this work, I'd be very happy. I want to see what you did. So I'm 192.168, 1.1. My gateway is 1.2 is 1.2. My gateway is 1.1. This is 1.5.
So
What's the problem?
1.1. So the only thing I think we need to do is turn off your Wi-Fi.
Okay.
Because the order of priority is probably because this doesn't have internet. Windows is telling it that, hey, don't pay attention to that because it doesn't have internet.
Okay.
And then you'll probably need to maybe not a reboot, but at least close all browsers because they tend to be in control of catching that kind of stuff. So now see if you have.
Steven? Try running Tiny VNC.
Let's see if we can ping.
192.168. 1.2. We have success. It was turn off the Wi-Fi. Who knew?
Yeah, it does a priority thing.
Okay, you're a prince. Thank you so much. Yeah, I'm gonna do that in a second. Are you running the server? All right, hold on. Connecting. Oh, look, it's there.
I don't know what nerdiness I just helped with, but I like.
What you did was you told us to turn off the freaking Wi-Fi.
I don't always know the answer.
So, Steven, Steven. Oh. Are you called Steven or Steve? Oh, so he's the same way. He's like. Yeah, you didn't want to be called a dick either. Oh, no. 8 years old? Yeah, 8 years old. That was his attitude about being called a dick. All right, so I'm looking at the screen on this thing. So are we showing the screen? No. All right. This? Huzzah. Ta-da. Yay.
I don't know if we can win.
Yeah, really.
All right, I can go have lunch. Oh, no, I can't. I don't have time.
I'm going to move this chair forward because when I push the chair back, I'm not going to fall off. Break my ass.
Yeah, they had a guy.
Stephen, do me a favor. Copy that onto my.
Is that the presentation?
Yeah. Copy it onto my documents directory. It's got a new. Yeah. Well, no. Yeah.
All right, so Gordon, this is.
And then your wireless
All right, this is interesting. How did you get this in?
I'm trying to figure out how to sit down.
Go ahead. You need help?
Yeah. Sit down.
Okay, hold on.
And I need my body to sit down. Grab me those cards. All righty. That's fine. It's fine right there.
No.
Why?
Track.
Oh.
So how did you guys, all right, VNC, I've got to, okay, hold on. Control Alt,
Why you need two
delete.
monitors.
Task Manager.
Well, you know what we may have to do is let me just go through the whole presentation,
Yeah,
Yeah,
and then I'll just walk off the stage and let you guys do it.
to be honest, I'll let Steven do it.
I said you guys.
Yeah.
I didn't say Gordo.
and Gordon, or Alan, between you and me, we could do this without even having this test set.
Yeah, or the script.
Yeah, I know.
Make sure
Listen.
you get PowerPoint up. You
I'm
got-
trying to get there.
You got 5 minutes.
Yeah.
5
Hey
minutes.
guys, this isn't like school where you have to sit in the back. You can come forward. It's okay.
No, 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 no. He nibbles, but he doesn't bite.
I don't nibble anybody except my wife. Sorry. There's only one person in the world I'm nibbling on. Thank you.
He's had rabies, tetanus, and diphtheria. He's safe.
Yeah, he needs a muzzle.
I just drive the truck.
So my father said at Georgetown when they took the plaque off the front of the Russian embassy during the Korean War. A crowbar. A crowbar. You know the big plaque that had CCCP and a hammer and sickle? Big brass thing they put on embassies? Well, some Georgetown boys actually made off with it. They're all dead now, so I can talk about it. But yeah, you can look it up in the old Washington newspapers. My father
right.
said he just drove the truck. Or the getaway car, as the case may be. Alrighty.
I don't know how you launch the VNC, guys, but it's like,
I launched VNC.
no, 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 but you've got it in full screen captive mode where I can't get to any of the windows.
It escaped.
I did, and it won't do it.
Huh. I don't know. Alt Control Delete and then switch tasks.
It's what I'm trying to get to.
Hi there. Oh, you want to take a picture of our little toy?
Is that who I
Like
think
my
it
business
is?
card
Oh,
to go
hi,
with it?
Chip.
Here you go.
I've seen Chip on video calls, but I've never met Chip. Hello. No, but we'll be there in a minute. All right, so we are on this thumb drive, right?
Hey guys, while we're waiting, we just learned something we can share with you about wireless. If anyone thinks that wireless doesn't rule the world, it even rules the Microsoft world. And what do I mean by that? If you set up an IP address for your Ethernet and you leave your Wi-Fi on, it'll still try to connect on your Wi-Fi and say, no, you don't have an interface, even if you've got something connected on your Ethernet. So the object is that even in Microsoft's world, Wi-Fi rules the communications world. So thereby extension, wireless rules the communications world. Who knew? So you have to turn off your Wi-Fi if you want your Ethernet to work. You have to actively turn it off. And thanks, Stephen, for that little bit of insight.
Not me, the other Stephen.
The other Stephen. This Stephen. So kudos to him, but you know, who knew?
Anything else, but the universe knew, I guess.
Across the universe.
I'm trying to get to it because this laptop has an attitude. Hold on.
Anybody figure out what that song was that I was just made a one-line reference to? Man, I'm old. You must be older.
Okay, there you go.
Okay, Gordon, we're in the entertainment business. We're not the entertainment.
Thank you.
That microphone's hot.
I know.
I was just using it to give a 1 hour long forum.
You're welcome.
I'm gonna turn this off. Okay, you have to hold it down, turn it off, and press it once to turn it on. That'll be in your part of the presentation.
Splendid.
Hello, everyone. My name is Alan Spindell, and I'm the president of the Radio Club of America. I'd like to welcome everyone to today's presentation of measurement techniques for amateur radio transceivers, featuring Gordon here from Viavi Solutions. He's their chief scientist. Today, we're going to have two parts to the presentation. We're going to do some two-tone IMD testing of a single sideband transceiver, and then we're going to look at some 2-meter amateur transceivers using the Viavi CX300 service monitor. Like I said, my name is Alan Spindell. I'm a fellow of the Radio Club of America and a senior member of the Institute for Electronics and Electrical Engineers. Gordon Beatty Jr. is with the Office of the CTO. He's their senior RF engineering scientist. Steve Jeffries is here. He's an RCA director and senior test equipment engineer with Tentec Alpha. So a little bit about the club. The Radio Club of America was founded in 1909. It's the world's oldest wireless society. In 1910, W.E.D. Stokes, the president, went before Congress and testified against the Depew Act, which would have taken all of the spectrum and given that to the military. In 1911, they came back and passed the Communications Act, which established the FCC and had carve-outs for marine, broadcast, public safety, and of course amateur radio. So if it weren't for the early efforts of the Radio Club of America, we would not have amateur radio today. Stop by and see us in booth 1811 and learn more about the history of RCA. So first thing we're going to do is talk about how to perform a two-tone single sideband intermodulation distortion test. And we're going to talk about the purpose and theory of intermodulation distortion, the equipment requirements and the kind of test setup that you need to do this, and the step-by-step measurement procedure, interpreting results and how you can use that to diagnose a failure inside a single sideband transceiver. Now, the thing is here is that we have this really, really fancy, thanks to Viavi, super expensive service monitor. And it can do all of those things. But the idea here is to show you how to do this with any kind of surplus equipment that may already be in your shack, at least you can find out here at the flea market. You don't have to have this fancy stuff to do some of these simple tests. Now, later on, we're going to use this really fancy monitor here, and we're going to look at a VHF HT. Somebody has something that's making some kind of electronic noise. Yes, thank you. So a little bit later, we're going to take a look and we're going to evaluate a VHF handheld transceiver, and we're going to use the CX300. We're going to test this thing and look at its frequency, power, its deviation, tone squelch capabilities, and the harmonics that it's generating on this scope. We're going to check its synad and squelch hysteresis and total harmonic distortion of its audio. And once again, we're going to be able to tell from those things how to diagnose problems with your transceiver in the field. So first, let's talk about the two-tone test procedure. And the main thing that does is gives you some idea of the linearity of an amplifier. Now, we've all heard of a linear amplifier. Well, why is that a linear amplifier? Because we want it to not distort the signal. We want it to amplify our signal in a linear fashion. A nonlinear amplifier would introduce more intermodulation distortion. So that's the kind of thing that we're going to look for in these tests. Now, according to FCC Part 97, spurious emissions must be attenuated greater than or equal to 43 decibels below the peak envelope power output. Now, we were going to actually try to perform some of these tests here for you in this forum. However, when we were setting up this morning, we came to the realization there's so much background RF going on here at Hamvention that it's pretty much impossible to get a decent reading. And since we do actually have a Faraday cage we could bring over here from the Tintec plant, it would be a little bit much work. But that's the reason, for example, that we do have a copper shield Lundgren cage, for example, at the Tintec plant, where they calibrate all of the receivers and everything there inside an RF quiet environment. And it just shows that even here at Hamvention or even just someplace else, it would be very difficult to do that just out in the wild, so to speak. So why do we use two tones? So if you just put one tone in a transceiver, you know, it's kind of like that small town with just one lawyer. You really need two. And so if you only put one tone into an amplifier, you're never going to create any intermodulation products that you can go and use to measure the harmonic spectral output of the amplifier. So we're going to look at the odd order spurious products, which is what the regulation tells us to go by, and we're going to look at the third, fifth, and seventh order harmonic products. We're also going to measure the peak envelope power and show you how to get the true peak envelope power under realistic drive conditions. If you just put one tone into it, that doesn't really emulate what's happening when you're amplifying speech or data. And then the other thing is this, is that it's really hard to activate the ALC and to get way out on the DC load line of the amplifier and create that compression that we're trying to see that's going to cause clipping or flat topping that you'll see on the oscilloscope by just driving it with one tone. It's a lot easier to get there with two tones. And the same thing is, there's another type of distortion where you start getting phase modulation and thermal memory effects. And so it's almost impossible to diagnose that with just a single tone. And the same thing as I mentioned before, if we're really going to get this thing and overdrive it and find out where it clips, it's a lot easier to do that with two tones. So, you know, how do we decide, you know, what tones we're going to use? And here's an important thing. You know, TVs sound a lot bigger when their size is expressed diagonally, even though they all have the same aspect ratio. And so years ago, manufacturers used to talk about carrier suppression and peak envelope power. Well, that makes all your results appear about 6 dB better. So in the modern era, if some guy's trying to sell you an amplifier, make sure that the results of harmonic suppression are expressed in dBc relative to a single carrier tone. Now, here's what you need to conduct some of these tests. And you can find all this stuff out there on the flea market, and there's people here will say a nice brand new one too. You really need a way to generate two independent audio tones. That's why they call it the two-tone test. And they don't have to be an integrated unit like this one that can do that. All you need is two separate audio oscillators, and there's a ton of them for sale out there at the racetrack. You can use a commercial unit, a PC sound card. Personally, I love Spectrum Lab. It's free and actually has a button that you can push to create sideband two-tone test. Or, you know, you can have two nice big all separate tube type Hewlett-Packard audio generators. Now, the other thing is that you got to be really, really, really careful, because your audio generators can go into the input stage of your transceiver and create mixer products there and come back into the generators, and that's going to cause an IMD of its own and distort your test results. So you need some way to isolate your audio generators from the transceiver. Now, the best way to do that is using a transformer system, but, you know, we're hams. Hey, man, we're cheap. And you can also accomplish this same thing just by putting some resistance there in series between the two block diagram blocks. And a L pad or an H pad will serve the same thing, just not quite as well. You know, and then it really, really helps to have a spectrum analyzer. But, you know, we've all got RTLs and things like that. It says here you need a calibrated one, but just to see harmonic products and things like that and not measure them accurately, you know, even the cheapest like a RTL SDR will work. And the main thing that's really important is to have a calibrated attenuator if you're using a spectrum analyzer. And I was going to bring one, but we had one with the switches, but I think it got lost in the shuffle. Yeah, anyway. So you want to get one of these attenuators that you can change the settings on to make sure you're not overdriving your spectrum analyzer. Because if you do that, you're going to create mixer products in its front end, and that's going to distort your measurements. Also, if you want to measure peak envelope power, you're going to need a calibrated watt meter and a directional coupler to be able to insert that in the line. So always use a dummy load. So you don't have those guys from the FCC or your ham neighbor knocking on your door with lots of paperwork to fill out and questions you'll have to answer. And of course, if we're going to look at the envelope and see if the amplifier is clipping or flat topping, you'll need an oscilloscope also to do that. So here's a typical test setup. Once again, here are the audio generators that I spoke of that create the two tones. There's your isolating combiner right there, which can be a simple resistor network. And then, of course, this is a device under test. And then if you want to measure peak envelope power, you'll need a watt meter there. And then here's a directional coupler or a T-slot line or something like that that you can use, that variable attenuator that I mentioned, and of course, a spectrum analyzer or an SDR. And then, of course, most importantly, you want to have a nice dummy load there. Now, it doesn't have to be a big fancy dummy load, especially if we're just testing a transceiver, because we're going to only have it on for short periods of time, and we're going to start at very low power to start with. Now, before you do that, before you get started, you know, it's kind of like with a strange antenna you've never used before, with a tuner that you don't know where the settings are or whatever. You want to start out with very low power first and see what you got so you don't blow anything up. So one thing you want to do is measure the input level at your spectrum analyzer. Now, it's got so bad down at Public Coast Station WLO while I was chief engineer, the owner got a little Hammond box and he put two BNC connectors on it, and he put a push button switch. And so if you wanted to take a reading on the spectrum analyzer, you had to set everything up and then push the push button switch before it would actually send signal into the analyzer, because so many times people had blown up the front end, not realizing, you know, the transceiver they were testing was at high power, or, you know, the attenuator wasn't in line. So somebody did that anyway and pushed the button and blew up the front end of the analyzer, and so they just gave up on that. So you want to configure your spectrum analyzer, and then really, really important is that you match the output level of the generators, because we're going to look very carefully, and you'll see some more slides about this, about the symmetry of the spurious harmonics. And if your generators aren't at the same audio level, you're going to create all kinds of wacky intermodulation products at different levels, and you're not going to see that symmetry that we're trying to observe in the spectrum analyzer output of the odd order harmonics. And once again, as I mentioned before, here's the caution: an overdriven spectrum analyzer will have its own products mixing in its front end, and that will invalidate your measurement essentially. And so that input attenuation level is very, very important going into your spectrum analyzer. So the first thing we're going to do, and I mentioned, you know, it doesn't tell us a whole lot by just putting a single tone into the transceiver and measuring it. However, it's always good to start off slow. So first thing you want to do is just put a single tone in. Put in 700 hertz. Make sure that, look at the output on the spectrum analyzer. Make sure that everything makes sense. It's a good common sense test. It verifies your test setup is working correctly, and make sure that, you know, you've got carrier suppression and opposite sideband. Then you want to turn both generators on. See that you're generating 2 RF carriers. And, you know, I mean, the book says then to drive to a 50% level, but I mean, I'd start out at like 1% and then drive to maybe 5% and make sure that you're not generating any smoke. And if you're smoke free at that point, you know, it's probably good. You can go ahead and start to turn up the drive level into a more serious thing, because also these phase modulation, saturation, and clipping effects don't occur at very low power levels. So at some point, we're going to have to run this thing wide open to get an accurate test. So the next thing we're going to do is take a look at these odd order harmonics, the 3rd, 5th, and 7th, and measure them. But you know, not everybody has a calibrated spectrum analyzer and a $30,000 service monitor that does that for you automatically. But if you can just observe that the harmonics are symmetrical, you know that there's no evil intermodulation going in there caused by a bad bias level, a bad capacitor, or some other lump circuit component. And then the next thing is, and this is the easiest thing for all of us to do because we all pretty much have an oscilloscope. You can get one out there for $15, some really nice ones, and on eBay. You just want to put both. If somebody's got something that's playing a song, thank you. Let's use that and test the transceiver with it. Sir, come forward. Okay, so when we look at this on an oscilloscope, you should see a clean amplitude modulated envelope. And you'll see the 1200 hertz beat frequency from the 700 hertz carrier, and you should see no flat topping or clipping. It should look pretty on the oscilloscope screen. And that can just be done with test equipment that we all have. And then, of course, the next thing is we want to make sure that the watt meter in the transceiver is not lying to us about how much power it's putting out, you know, like the salesman did. And so we're going to do that using a watt meter. Now, this gets back to the spectrum symmetry that I was talking about a little bit earlier. And so the shaded part here is the passband, and that's the part that we want other people to hear. Now, the part that we don't want the FCC inspector or the volunteer observer who's going to call the FCC inspector are these parts here. And they must be below a certain level about there so that they don't get outside of our yard. And that's the whole point of this test. But if you take a careful look at them, if there's none of these problems inside the amplifier, then that should be a nice, easy, slow curve down, and it should perfectly match the same one on this side. So this red dot here should be at the exact same height at this red dot here. If this blue dot is higher than the red dot, that's trouble. So now, if we do have a calibrated analyzer, you know, if you're down below minus 40 dBc, I mean, you've met the requirement and you've got plenty of room for error. If you're getting into 35 to 40, well, pretty much any transceiver that you find here, you're going to find it in that range. Now, if you're getting into the red range here, you need to start looking for some problem. There's something wrong with the calibration of your automatic level control circuit. The PA bias could be off, causing clipping. And so you need to really take the lid off and see what's going on in there. And first do some DC checks and then maybe get some measurements with the amplifier operating. And then if it's worse than that, you're going to see major problems going on. You need to switch it off and start looking at some component values with your own meter, with the capacitor, the LRC meter, or some things, and take a hard look at the tube socket or whatever else is going on inside the transceiver, because if you keep operating that, you're going to damage the PA. And the other thing to mention is make sure that when you are, cranking it up wide open and looking at peak envelope power on the oscilloscope or whatever, that you do turn off the automatic level control, because if you see it starting to compress at the top of the gain curve, then you're actually seeing the distortion from inside the automatic level control loop and not the actual PA. If there's some way to back off on its threshold or defeat it for the test, that's actually what they do at the factory. So that concludes our two-tone test. We really would have liked to perform it to you today, but that's about as good as it gets. We do have a practical demonstration for you there, and that's with the Viavi CX300 Com Expert. Thanks to Viavi, they've got one of them here, and like I said, Gordon is the chief scientist there. Steve?
Not the chief scientist.
Well, I'm giving you a compliment. You're supposed to just
I have a
smile.
colleague who has that title.
Well, you're the big wig. How about
Okay,
that?
I'm happy to be here.
Okay. Yeah, Steve Jeffries, who is an expert also on this. So we're going to talk about 6 different kinds of tests. We're going to, on the transmitter, 3 on the receiver, and we're going to do this using a completely self-contained instrument. So these are the really cool things that this thing can do. Steve, you want to talk a little bit about that?
Sure. Okay, good morning. Thank you, everyone. So when you look at this, when you go into the world of frequency modulation, and we will talk about why this also affects your digital radios, but we're not going to get there yet. If you look at the beginning, you have your frequency stability. Okay, you need to actually know where you're at, and you need to know that your carrier is not dancing around. You also need to look at your RF power. Is your power what they said? If you bought a radio off of Amazon and they said it's 12 watts on VHF on a portable, I wouldn't want to use it personally. But is it really 12 watts? 12 watts on whose standard? So you need to measure it. You also need to measure if it's holding up, because something may be compromised and maybe your radio is not putting out 12 watts anymore. And then in the frequency demodulation, you've got to look at the peak and the RMS, and you can look at the distortion. Here in a 1-hour forum, we can't get you on the bench and do all of this stuff at the nth level because A, we're in a 1-hour forum, and B, we're at Dayton Hamvention. In this RF environment, you're lucky anything works, including your cell phone and your Instagram. But anyways, then you got to look at SINAD, which is signal plus noise and distortion. This is the quality of the signal. How well is your receiver actually functioning? Then, of course, tones, whether it's analog or digital tones, CTCSS and DCS. What you're looking there is the deviation. These are audio tones that are at a sub-audible frequency and level. And if you have too much tone on CTCSS, you'll hear a buzz, and you'll think somebody's got bees in their microphone. And if you have ever been on a repeater and somebody says, you're dropping out periodically, it's not because your thumb is tired and you're not holding the PTT. It may be because your CTCSS deviation level is right on the edge of what the repeater is looking for. And when it dips down, the repeater may mute. And then when you come back up, it opens back up again. And then you're going to look at the spectrum to see for the harmonics. As Alan talked about the harmonics in the two-tone, you also need to be, depending on what band you're at, but 2 meter FM, you need to be 40 dB below carrier peak on your spurs or more. I would suggest more, because the lower you are, the cleaner your signal is, the better you are for the environment. And it's not just that your radio is working right, but it's the guy on the next frequency down who's, if your radio is not working right, you're going to be screwing with him or her. And then look at your generator and that kind of stuff. You want to talk about the parameters, Alan, that we're talking about here on the right?
Yeah, sure thing. Thanks, Stephen. So, yeah, basically, like I said, we're going to look at carrier frequency error. That talks about how good your reference oscillator is going. Your RF power talks about the quality of your PA, and Stephen mentioned also about sag that can occur over time caused by drift and component problems. Your FM deviation isn't right, means your modulator's out of alignment. If the deviation limiter is coming on too early, that's going to clip the signal and cause distortion at the other end and can chunk your repeater. And that's the same thing with the CTCSS. If it's not aligned up properly and its deviation is not set right, that's just going to continually chunk the repeater as you're talking, which is bad for the repeater and even worse for the person that has to listen on the other end. And then once again, if you don't want that guy from the FCC knocking on your door with lots of questions to answer and lots of paperwork to fill out, the last one being a check, we want to take a really hard look at the harmonics and spurious output. That talks about whether the low pass filter, the tank circuit as we call it in the amplifier world, on the output of your power amplifier is working properly, and that your PA is operating in a linear fashion, which if there's a bias problem or something, that could cause you to wander off the DC load line and create spurs. So then once again on the receiver side, we're going to look at not just the noise and not just the signal, or not just a distortion. We're going to add all of those three together. And the little box that everyone used to have to do this, you probably find some out there on the flea market, was called a sign adder with the ADDR in lowercase, and their logo was a little snake. Anyway, we're also going to look at squelch threshold because squelch has a hysteresis. And y'all are all probably familiar with this. Listen to the squelch tail and messing with the squelch knob. When you break squelch, it's a little bit different level when you break squelch, it's a little bit different level when the audio level comes down and you make squelch. And so that's something that's in alignment. It's a trim pod or a setting inside the radio. And we're going to look at audio distortion, which can occur in the IF section. It can also occur in the audio amplifier, especially now with some of these wacky Class D amplifiers and things that are in modern radios. If they're not set up just properly, correctly, and drift in their external components, they all have a big capacitor on their output. And when that thing gets soft or whatever, you'll pick up THD. So the first test we're going to do is carrier frequency accuracy. You guys want to take it away?
Yeah, actually, before we started that, just wanted to add something to what Alan said earlier. We've all had, watt meters of various types, and gosh, they're not the right scale. Something like, all of a sudden you need something that'll measure, 500 watts and you got a 50 watt slug in a bird watt meter, or your watt meter is only rated to 100 watts. So what do? And one of the things I do on my bench, which is god-awful simple, is I take a directional coupler. You can buy them on eBay for chump change, like 20, 30 bucks. And what you do is you put your transmitter on one side, you put dummy load on the other, but the tap port, sometimes it'll have one port, sometimes it'll have bidirectional. It'll give an RF sample that'll be 10, 20, 30 dB down. So what does that do? That means if it's 100 watts and it's 10 dB down, it's going to be a 10 watt signal. So something that's more manageable. Number one, it'll protect your watt meter or your instrument if you're using an instrument. But it's an inexpensive way on your ham bench to scale to higher power with equipment you already have. It's also a great way to protect things like your nano VNA from being bitten by your HT. It's good to have attenuators, but maybe you don't have something that'll burn that power off. So instead, just sample at a calibrated level. Just make sure that the directional coupler you buy online is rated for the frequency range you're talking about. So that's just one way to extend your ham shack with something that's a $20 or $30 eBay item that you can find. Stephen?
Thank you. So he brought the Nano VNA up. I also want to say, Alan talked about you can go out to the flea market, you can go to Facebook Marketplace. You could also use a Teeny SA spectrum analyzer. I mean, they're what, 50, 60 bucks for a good one? But what I would tell you is, if you buy some of this modern teeny nano stuff, understand it's good, but it's not laboratory grade. So what it will tell you is, I'm working correctly, I'm good. But It will also tell you if you got a problem and you need to seek further help to fix it. But what you need to understand is some of these devices, they don't have the dynamic range as a military or commercial piece of test equipment that runs between $30,000 and $100,000. So you may not be able to get the dynamic resolution of your results, but you can tell, I'm good, I don't have a problem, or I've got a problem and I need to get more help. And the other thing is, you're going to see me when I step down around the front. I've got a portable radio that I'm going to key directly into this test set. This test set has a duplexer built into it and has a directional coupler that will tolerate 50 watts of RF, 100% duty cycle from 9 kilohertz to 6 gigahertz. So I'm going to say, do as I say, not as I do, because I'm going to key directly in. But if you've got a Nano VNA, you've got a Teeny SA, or you've got a Wriggle, or you buy something that's older than your wife out in the Hamfest flea market and it works, don't key directly into it or you're going to let the magic smoke out of it.
My wife's 21. She's been that way for 43 years, but 44 or 5 years.
So now, the other thing I want to talk about is everything we're going to talk about today is analog, and everything Alan talked about with sideband is analog. But the vast majority of the people here are playing in the digital realm. They're using DMR. They're using NXDN. They're using Fusion. They're using P25, or they're using D-Star. All of the ones I just mentioned, except D-Star, are 4-level FSK-based digital modulation. This is not about digital, so I'm not going to get into the math or the physics of that. But what I will tell you is, whether it's P25 with L3 Harris, P25 with Tate, P25 with Motorola, it's Fusion with Yaesu, it's anybody's DMR in the world, or you're doing NXDN with Kenwood or ICOM, that 4-level FSK radio, whether you're doing it manually with a bunch of several different pieces of equipment, or whether you're using a state-of-the-art space shuttle type piece of equipment like Viavi has provided us today, that radio is calibrated in an analog profile format frequency modulation. So if you've got a DMR radio and you've got a Motorola or you've got a Tate or you've got a Kenwood, their factory specs are this radio is calibrated in analog. Then you can do, to quote Ronald Reagan, trust but verify. Then you can do your assessment in digital to make sure it's where you want. But if your analog is wrong, your digital will be even more wrong. And that affects audio quality significantly when you get into 2-to-1 time slicing of all of that. So now if you look at this, this is really the kitchen sink of test equipment. It's got a generator, a receiver, and it's got, oh, thank you. So you can see here, we've got a generator, we've got defined as 146.52. We've got a receiver at 146.52. We've got 3 function generators. So we can turn on 3 different sine waves and we can adjust them anywhere we want and adjust their deviation. And then over here, we can read the power meter. It's going to tell us how much power we've got. We happen to have a sweep meter also. And then RF frequency error. We're not going to have sine add. It's just going to be random numbers because we're not hooked to the receiver. And it will show your deviation. And you will see when I talk, I'm on a 25 kilohertz channel. You'll see the deviation. And then it'll count the audio. When I was younger, I could whistle a perfect 1K tone. I don't think I can do that anymore. Over here is a channel analyzer. It's a highly focused spectrum analyzer that looks at a much narrower slice than a big benchtop spectrum analyzer. And here, this will be power over time. So as they talked, you may see a spike at the beginning. And if our PA or PA bias is failing, you will see a roll-off and the power will go away. And if you want more details, you can come to the Viavi booth. And Gordon will have this in, or not the Viavi, the Radio Club of America booth. And Gordon's got a little corner that's Viavi. And you can even bring your radio and test your power and your frequency. So I'm using, for those of you that care about the details, it's an ICOM ID50A. I'm on 146.52. and I'm running at low 2, which is just under a watt. So when I key up, you're going to see what my carrier looks like. Now, I'm looking at only 20 kilohertz wide, and as I talk, it's being modulated. So that looks very good. You can see that I'm putting out 29 dBm of power, and my frequency error is running between 40 and 41.5 hertz. So it's very stable. And this is a 25 kilohertz channel, so I should have up to 5K of deviation. You can see there, the way this radio is set up, I'm getting about 4.5 kilohertz of deviation, which is actually typically very good. If we were on simplex or on a repeater, you'd tell me I sounded very nice. The other thing you can look at there is you can see the power in the middle there. You can see that I'm at measuring just about 30 dBm now. Now I've gone to higher power, so you can see that now that I'm at full power, I've come up from just under 30 dBm to just under 37 dBm. And you see a little ripple there, but it's fairly stable. And then if I turn the generator on, I'm just making sure everything came up correctly. And I don't have enough signal. Try to open the squelch. All right. Being on stage in front of you, it doesn't always, oh, the generator.
Squelch is open.
So now I went to neg 130. You can see that it actually muted my squelch. That's a very strong signal. But so if you can hear the frying bacon on there, I'm at a signal level of minus 124 dBm. That's pretty good. If you were on the bench, you could then play with and see where your squelch opens and see if you need to adjust your squelch, if you want it tighter or looser.
Hey, Steve.
Yeah.
Let's go through the test according to the slides one at a time instead of just playing around.
Okay, so.
It's okay. So let's get back to our actual, that was just kind of showing you the capabilities of the test equipment. And now we're going to get back here.
Control Alt Delete.
Yeah.
Task Manager and then Tab. It's fighting me. I had this problem.
Yeah. No. Yeah. Wake up.
That one right there.
Yeah, okay. Okay, so the first thing that we're going to test rigorously is carrier frequency accuracy. And once again, Steve's going to show you where to look for that on the monitor screen, and then he's going to perform a carrier accuracy test. And the main thing here, once again, like power is, we're going to run it for a little while and make sure that that doesn't drift or move around.
Here's the pointer. to show them where it is on the screen.
So as he keys up, we're going to see if there's any drift, and Stephen will point on the screen where that is. But we'll see if as it heats up, whether or not the frequency accuracy of the radio is maintained. It's pretty accurate as it is. I mean, it's an ICOM ID 52, for God's sake. But part of the value of these test sets is the precision nature of their devices. The other thing is that it speeds up the efficiency for a technician. If they want to auto test and auto align a lot of many of the popular radios, they can just plug a cable in here to control it and one to the antenna port. And this whole thing, in a matter of about 10 or 15 minutes, will auto calibrate or auto test and auto align the radio, which is a big time saver.
Yeah, and one thing that you can see, because this unit is set up to auto test some other radio, is you see that fail flag there, and that's showing you that whatever it was set up to test is not putting out sufficient power, and obviously it was not a 5-watt ICOM radio.
Right, so you can see right now that the go, no-go testing would be wanting to see 1 watt or 1,000 milliwatts. If you look at the frequency, the RF error line, can you point at the RF error?
Well, we're going to move on to the next test.
Now you can do all tab.
So, and I think we kind of saw both of those there as we were mentioning RF output power, so we probably need to move on. But we had it keyed up for a long time there, and RF output power was down 2 orders of magnitude when it was drifting around. So that shows you that the battery's charged up really nice. There's nothing wrong with the power supply on the radio, and there's nothing really wrong with the PA section of the radio. It's just maintaining good, stable power for quite some time. Next, we're going to measure the deviation. And then we're going to put in a 1kc reference tone and see what happens there when the limiter kicks in on the deviation. You can tell how old I am because I say kilocycles, not kilohertz.
If you noticed in Alan's slide, it talked about parts per million, and we're looking at hertz. It's all math. In the amateur radio world, people want to know how many hertz am I off. But in high-end public safety and in high-end military communications, sometimes they want to document parts per million. It's just like whether I'm going to read my power in dBm or watts. It's the same measurement, it's just how do you want to represent it. So from a deviation point of view, when I'm not talking, you can see the frequency deviation, the third one down on the left, shows, less than a kilocycle. And then when I start talking, depending on how loud I talk and what I say, you can see it varying between 4 and 4.7. Alan talked about clipping on the sideband. If you were hitting over 5 kilohertz of deviation on an FM radio, you would be clipping, and the guy on the other end might say, hey, you're splattering. You sound like you're spitting at the microphone and that kind of stuff. So there's where you measure the deviation. Now, if you get something from the flea market, your deviation meter, like if you get an older IFR or a Cushman, your deviation meter may be a needle, and you're looking at a needle instead of a decimal readout. So now, to do the tone, Alan, you want to go back to the slide, please?
So we're going to inject a 1 kilohertz sine at a calibrated level into the mic input, and we're going to adjust it to get a standard deviation out of it. And we're going to slowly step up the drive, and we're going to see where the deviation limiter kicks in.
So unfortunately, we're not going to do all of that because the connector on the side of the ICOM uses a narrow 2.5 millimeter, and the standard wouldn't fit in it, so I couldn't inject it. It's like I inserted colorful adjectives when I was trying to set this test up, but I'm not going to use them here in public. So, but you heard me do this. Gordon, your test equipment has copped an attitude, and people are getting to see what happens with man-made software-driven equipment. It won't let me change the tone.
I'm not sure why, as I'm not in front of it, but okay.
Yeah.
That's okay, Steve. We got 15 minutes.
Yeah, so what you're doing is when you inject a tone, you're listening to the quality of the 1K tone. And yes, unlike the sideband test, we're only doing one tone. And you're looking for the quality, and you heard that frying bacon when I was going. Alan talked about the sine adder. If you had a sine adder hooked to this when you injected the tone, then you could actually measure what the sine add is, and radio specs are different. I think we need to move on, Alan, or we're going to run out of time.
Mm-hmm. So the next thing we're going to do is test signal plus noise and distortion, or sine add. And we're going to use the service monitor to actually generate a signal, and just like it's another transceiver, and that'll let us test the receiver that's there on the HT transceiver. So if you look, there's the sine add level that we're going to be trying to keep an eye on right there.
That's just a carrier with no tone. That's the 1K tone with, that's the 1K tone with some frying, and that's a good signal at minus 120 dBm. So if we go down 3 dB on our RF signal, you hear more bacon on the carrier. There's another, so that's now 6 dB down. That's 9 dB. You can hear the 1K tone in there, but the frying bacon is taking over. And then when we go down 10 dB, it's trying to mute. This is on the squelch side. All right.
So the tone that you heard in there, that's the signal. And the sound of rushing wind, that's the noise. And the bacon frying that you hear, that's the distortion. So that's signal plus noise and distortion.
And that signal plus noise and distortion is really an industry standard for measuring how good your receiver is. Windows 11 is fighting us, so please bear with us, folks, and pray for us.
So, yeah, so Steve did a little bit of work earlier demonstrating the monitor by checking the squelch threshold. So let's do that again. We've got about 10 more minutes. That'll give you a chance to do that. And we can test total harmonic distortion, and that should just about wrap this up.
So if you hear on this radio right now at minus 127, you can hear my signal to noise plus distortion. And you could understand what they're saying. If this was an emergency, you would get the communication. But as I take this down, I would say on this radio, my squelch threshold is somewhere between 129 dBm and 130 dBm. Because when I go to 130, every once in a while it'll pop in. And if I go to 131, it's mute, we're done. And this may be beneficial if you live in an area with a lot of RF interference. You may want to adjust your squelch to a tighter setting and know what it is. Because maybe if you live in a large city that's an RF nightmare, you may want to set your squelch at minus 125 so that you're not hearing dysfunctional garbage on the speaker all the time.
Okay, so the next thing we're going to talk about is total harmonic distortion, and that measures the quality of the audio amplifier that's there on the receiver, and it could be also amplifying spurious products that are coming out of the receiver caused by distortion in the receiver due to components and things like that that have a problem. So if you've got high THD at normal volume and an otherwise good receiver, that indicates some kind of a failure, a soft capacitor, a problem with the IC, but pretty much all the time you can find out it's an electrolytic capacitor that's starting to dry out, especially in the older surplus equipment that you'll find here in the flea market. And that's pretty much the most common failure mode in radios that are greater than 5 years old. There's a famous case of a lot of capacitors that were made in Asia. So this one company in the late 90s, early 2000s, or mid 90s came up with an amazing new formula for the dielectric of an electrolytic capacitor. Due to corporate espionage, it was stolen by their 3 competitors. But what they didn't realize was that it went bad after about 6 years. And so a lot of these capacitors that were installed in equipment in the early and mid 2000s are now starting to fail in droves. And so this test right here would show you about the health of the final amplifier stages of your receiver section.
And in, looking at the audio distortion, that could be a whole 10-hour webinar that they're not giving us time to do. And in this RF environment, we'd all pull our hair out.
6 more minutes, Steve. Better pick it up.
So, yeah, Gordon, you have a question?
Well, no.
No.
We have one more slide.
Okay.
Just relax.
So so I can't demonstrate total harmonic distortion in this environment here today, so we're talking in theory. Most of the modern radios, if there's a harmonic distortion, you're going to hear it because of the the offshore electrolytics. We'll leave it at that.
So we're going to talk a little bit about how you can actually get practical information out of these tests that we're doing. We'll use that to diagnose problems that you see, that you have in your radio. Sorry, somebody call Bill Gates. We need him.
What do you want me to call him?
So let's talk about some of these common failure modes and how that relates to practical repair of a radio. So if we see high frequency error, but with no drift, we know that there's something going wrong with our frequency standard, that the temperature compensated crystal oscillator is aging or shifting in some way, or there's some issue with its heating element or thermostat. And then you need to either realign or replace the TCXO, and these days it's probably just replacing, there's no realigning. But if the frequency drifts during key up, that indicates that there's some kind of thermal instability, and a lot of times also that can just be caused by a cold solder joint in the radio. And so you need to take a look at the oscillator solid solder joints, and this also can be caused by power supply ripple. You might have a soft electrolytic capacitor in your power supply. But if you've got low TX power with a good battery, then something is going on with your power amplifier. And you may have a problem with your PA transistor. And due to electromigration and other aging effects inside the case of the transistor itself, you definitely see them age over time and will eventually cause power to drop off. And this is really bad with some of the early MOSFETs that are in a lot of these transceivers.
Can I talk about, you made the comment of battery. In the commercial and public safety LMR world, it is a sin to test a portable radio with a battery because you don't know what the battery's dissipation curve is or how old it is. So in a professional shop, whether it's Bearcom, Mobilecom America, Eastern Communications, Raycom, or mom and pop two-way, they test portable radios with constant battery eliminators, and they test the battery separately. So always be careful that you're not putting faith in the battery and it's the one letting you down.
Okay, thanks, Steve. And then wrapping up here real quick, if you've got low TX power and your battery is questionable, by the way, Eastern Communications Vice President and Radio Club America Executive Vice President Nick Pennance right here, folks. Tell you all about P25 stacks and testing radios. Anyway, you know, you need to look at the battery really carefully. Batteries develop memory, and you get aging in lithium-ion cells. You need to load test that battery and replace it if its capacity is less than 80%. You're better off just to replace it. And there's some great vendors here that pretty much have batteries for every single radio ever made. It's amazing. I don't know how they do it. And then if you're over deviating, then you got some problem with the front end of your modulator section. And that means that your mic gain has drifted, or your audio compressor is somehow misaligned and it's pumping up the volume too much. And you need to get in there and realign that. And also, once again, you might have a bad decoupling capacitor in the radio. It's dragging down the rail voltage in your audio processor section. If you've got a problem with it dropping out and continuously kerchunking the repeater, then you need to take a look at the injection level of your tone squelch. And that maybe they usually have some kind of a pot in there to adjust that level. A lot of them are digital now. But you want to make sure that that hasn't drifted, and you need to adjust it, or you may have a problem with the part in there that generates that signal. That's the codec. Now, if you're looking at the harmonics on the spectrum analyzer screen and you see them out of spec, well, you've got a damaged low pass filter probably on the output tank circuit of your power amplifier. And a lot of times we'll see in there, if you took a lightning hit through the antenna or something, there'll be a shorted out chip capacitor surface mount device capacitor in there, and those things just give up the ghost all the time, and they don't even let out any magic smoke. They don't even have any of them in there. So you want to go in there and look at that filter section that's on the output of your PA that's keeping those harmonics in check, and you can actually, you don't even need a microscope, just a really good magnifying glass, put a little alcohol on the end of a Q-tip and clean off the top of that capacitor really thoroughly. Make sure there's no residue, flux remover residue or flux residue from manufacturing. Take a close look at it under a strong magnifier. They've got some amazing things for less than $20 on Amazon. It's a little camera and it shows up on USB on your laptop, and it really helps with my failing eyesight. And you can examine that closely for a crack. And then it's really easy. You don't need to be a surface mount expert to replace one small capacitor or an electrolytic capacitor. You just need 2 soldering irons, and just touch it, and a lot of times that'll just pop right off of there, and you can use that same technique to put it back on. I recommend using a lot of flux. And then the last thing is here is port synad. And as you can see, it's very, very, very low on a modern receiver. If that creeps up even in the slightest bit, you know you've got something going on there. And so something has happened on the output section of the low noise amplifier that's the front end to the radio. And high RF fields can do this. You have to be really, really, really careful if you transmit with no antenna. Even a really quick bump of the PTT switch can overdrive the gallium arsenide FET that's in there on the input section. And also pin diodes are getting really, 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 really hard to find these days. Manufacturers are using other more reliable methods for TR switching, but if you've got a pin diode in there that's damaged due to lightning or being overdriven by adjacent RF, like in a contesting situation, you'll see that poor synad number. And you need to follow the antenna path very carefully with your ohm meter set on its lowest setting, or use an oscilloscope with a known injection level, and then you'll see it drop dramatically, and then you'll know where your problem is. If you've got high harmonic distortion, then you know you've got some issue in the last stage of the receiver's audio amp, and you got a problem with an IC in there that's been damaged, or once again, one of these dried up electrolytic capacitors. So you need to replace that amp or recap the audio output stage. And there's pretty much any radio that you've got that's over 10, 15, 20 years old, it's a really good candidate for recapping. And once again, if something has happened with your squelch there, then you know that somehow, if it's an analog squelch, once again, capacitors, or for some reason it's drifted off frequency, off of threshold level, and in which case you need to go in there and replace the audio amp circuit or recap the audio output stage. If you got no squelch at all, these days it's usually a chip. You'll need to take a look at replacing that, realign it, and once again, check and make sure that that chip has got power and its decoupling capacitor hasn't given up the ghost. So here's the takeaways from this. We're over time. Once again, in the two-tone testing, the ALC must not be engaged during the test, and on your spectrum analyzer, be sure you don't blow up that front end like we were just talking about. Always start with a very low power and bring it up and make sure everything's okay. You're not getting any mixing products on its input. We were just talking about static damage to that gallium arsenide FET. That's that first thing in your preamplifier stage. And then once again, you want to take a look and make sure you're not over deviating. Well, I'd like to thank everybody for coming and checking us out today. Come and see us at 1811 at the Radio Club of America booth. We'll talk about a complimentary membership. And thanks again to Gordon from Viavi and Stephen Jeffries from Tentec. Y'all have a great day.
Yeah, when you bring your HTs by, and we'll test your frequency accuracy and your power and your modulation. 146.52, have your radio set for that frequency. Thank you.
Thanks, guys. That was really interesting information. Now we're going to start the System Fusion Forum. Feel free to stay if you, and welcome to all the new folks. We got a lot of people here today. That's great. While John gets set up here, I'll just talk for a couple minutes. We've been doing the Fusion Forum since 2015. A couple of years after Fusion, I'll take a little questionnaire here. What month and year was System Fusion introduced to the world? Does anybody know? Month and year. Month and year. No, you get accolades from everybody here in the room. It was in September of 2013 at the Digital Communication Conference at Seattle, and Dennis, K7VV, was the EVP of sales at that time, did a sort of no one knew at the time he was going to come out and introduce Fusion, and he did. And that was when Fusion first came about. There's been a lot that's gone on since then. That's when they introduced the DR1 repeater, the beta program. In the booth now, we've got the DR3 repeater. And so there's been a lot that's gone. There's been a number of radios that come out over the years. The topic of this year's forum is going to be the history of Wires X, which is the networking system that Yaesu uses, and also the new Wires X 2.0 software. I moderate the largest System Fusion group on the internet. It's a groups.io group called System Fusion, all one word, concatenated. And we got about 3,000 members. So there's a lot of knowledge in that group, and a lot of people post on their questions and comments and so forth. There is no political discourse. There's no, we keep it, it's a fully moderated group, so it stays right on technology, and that's all we do in that group. So if you haven't joined the group, System Fusion, go ahead and do that. John is on the group, and he regularly responds, so that's good. It's not affiliated with Yaesu in any way, but it's a good resource. And we've obviously got the booth across the way in the other building. We've got a brand new DR3 repeater there, and there have been some big advancements to Wires X with the 2.0. There's been some confusion, I think, and I think one of the things John's going to do today is try to clear up that confusion, to answer any questions you might have about Wires X. So when he's ready, we'll turn it over to him.
Just about.
Just about, okay. Anybody buy a new Yaesu radio today? Wow, fantastic. How many people here, I've asked this poll once before. So I got involved in digital radio with D-Star 20 years ago. It's exactly 20 years ago. Did a whole bunch of forums about D-Star, and then I got interested in System Fusion. How many people here own a D-Star radio? How many people here own a DMR radio?
Oh, that's right.
How many people here own a Fusion radio? Wow. So Fusion's got the edge slightly over DMR. Okay. Well, 20 years ago, I was an evangelist in the wilderness, and everybody told me back then that digital's not going to work, and it can't work as well as analog FM. Well, the rest is history 20 years later. So there's been a lot going on in the Yaesu world. And of course, when the Yaesu repeaters came out, they became quite big sellers because you could do analog FM and C4 FM digital on the same repeater, which was not heard of at that time. And so the rest is history. John's got a brand new radio there we introduced last year, the FT1X, I believe, which if you haven't seen that last year, it's a QRP radio. It could also come as an Optima version with a 100-watt amp. And here he is holding the QRP radio right in his hand, trying to be a replacement for the 817. Got C4 FM digital voice on it, color screen. It's pretty cool. Anybody have one of these FT1Xs? There's a market opportunity. Come by the booth. We introduced it last year. There's several on display. We've got brochures. So if you haven't seen the FT1X, certainly come by the booth and see it. And get a free hat. The hats are gray this year. So if you go, they'll punch your badge. They'll give you a hat. And hats are quite popular. So I think last year we ran out for the first time, but they're very popular. How many people have been at the forum before, prior years? Oh, a few. Okay, most of you. Okay, great. Well, thank you for coming again. So this is like I said, the first one was in 2015. I got when I first started the Fusion Forum, I reached out a little too late, and they said, well, we can get you in on a Sunday morning. And I said, well, who's going to show up on a Sunday morning? 150 people showed up on a Sunday morning. I said, wow, I think we're on to something here. There's really interest. So since then, we've typically done this on Fridays or Saturdays in the afternoon, and this year they put us in midday. So probably a good time because we got good turnout.
All right.
Anyway, so John's getting started.
Just about
here.
ready here.
Just about ready. So John started in Yates with 2017?
2017.
And you know, he's got a title as sales manager, but that really discredits what he does. He does every responsibility sales. He's really very technically adroit, does a lot of things both inside and outside of Yates in terms of two-way communications, and he's extremely knowledgeable. So I think you'll learn a lot today. And I know I learn a lot every time. But you probably, if you're on my System Fusion group, you'd notice that when they do introductions of products, they have a YouTube. Yaesu has a YouTube channel. John has done a large number of videos about all facets of Yaesu technology, including System Fusion, new radios, and so forth. Yesterday, we had, for the first time at the Hamvention, John had done this at the Hamcation back in February. He had a System Fusion training class we did over at the Marriott Hotel, and that was well attended. So we'll probably do that again in the future. That was separate from this forum, obviously. So we're glad. And that was went on for 4 hours, I think. It was very comprehensive.
It's 4 hours, yeah. Went through the history of it. And how many people were at it yesterday? I know I've seen a few people here. So a few people in there.
Okay.
You came back today, so obviously I didn't upset you or whatever. All right, I'm just finishing. Sorry, I had to take a moment to get set up here. So we're going to talk a little bit about kind of the whole aspect of Wires X today. And the reason being is that, well, I'll start out with a good question that was asked to me today. And that question was saying, John, what is the difference between C4FM? What is the difference between Yaesu System Fusion? What is the difference between Wires X? And that's kind of what we led with today for this topic. As Mark said, Fusion's been out there 2013. Does anybody know history real quick? Does anybody know when the actual concept of Fusion was put on a piece of paper? When? 2013. Wrong. That's when that was published. Does anybody know? 2010. Have you been in my class before? Oh, okay. Yeah, you have. You don't answer. So, does anybody here work for Motorola? Okay, good. So, here's why. So, we used to be, anybody remember a little company called Yaesu Vertex Standard? Yeah. So, that was our LMR commercial division, right? And we had some really, really great sales staff back in like 2009, 2010. And they went into this small little city on the East Coast. It's called New York. Probably never heard of it. But they went into the New York Port Authority and they sold a whole bunch of Vertex radios. That upset a company that begins with M and ends in Motorola. Okay? We didn't say their name. So their theory and philosophy is if you can't beat them, buy them. So what happened is, everybody remember what happened in 2010? Is that any? What happened? Motorola bought us. They bought Vertex Standard Yaesu. So what ended up happening was about 2012 rolls around, and sorry, Motorola, you don't care about amateur, you don't care about marine, you don't care about aviation. Guess what we did? We bought ourselves back. But guess what happened during those 2 years? We couldn't do any forward progression on any of our digital voice products, because what also uses C4FM and FDMA? P25. And what does Motorola sell? P25. So with that happening, Fusion actually got tabled for 2 years. It still stayed on the napkin, as we joked around, and it's there. But once we bought ourselves back in 2012, we then kicked it into full gear. And then that's when we actually introduced Yaesu System Fusion, like Mark said, at the Tapper conference. Now, the reason I bring this up is because Fusion was a concept, and you've heard me say it numerous times. It has three main important concepts and functions. And what are they? Selling radios? Close. No, what the concept of Fusion is, at first it had to be high-quality digital voice, okay? Had to be ease of use of operation, and it had to be versatile and flexible. That was the three main core principles that Fusion always had to do with and dealt with. What ended up happening in that case is time went on and we proceeded through it. We found out that it was great. It met all those qualities and characteristics, but here it is. But one of the things is that it needed to evolve. And if you don't have something that evolves, it's not going to do well. It's going to stay there. So we introduced Yaesu System Fusion, kind of a set of easy concepts on there. Started out with the FTM 100, FTM 400, the FT1, and then the HRI 200. We then quickly soon came out with the DR1. Now, the DR1 was a beta test. We gave it out to clubs. Hey, test it, da-da-da-da-da. Clubs took part of it. They did all this great things with it and everything. And they said, hey, we got some great ideas. Those clubs that were able to participate wrote back. We came out with the DR1X. That was generation 1. We had DSQ back then, which was a type of signaling. It worked. There was some refinements. So 2017, technically end of 2017 came, and we introduced Yaesu System Fusion 2. Now, System Fusion 2 was a second generation, but everybody was freaked. They thought, oh my goodness, the old radios aren't going to go ahead and be compatible anymore, this and this and this and this. We said, no. The second generation just changes some things for better operation. We came out with the DR2X repeater. We came out with some improvements to Wires X, and we came out with improvements to the radio and some signaling processes on there. Everything was backwards compatible. So now here we are, 2026, and we've been releasing a suite of products on there that are doing what we're now moving into, as you see on the screen here, of Yaesu System Fusion 3, the third generation of it. And the third generation is focusing heavily on infrastructure and connectivity and networking, okay? So it started out, believe it or not, with our FTX1. And we're going to cover a little bit about what I mean by that in a minute here, but we're going to kind of go through the slides here a little bit and kind of talk a little bit about helping you understand what Wires X is before you see how it ties into System Fusion Generation 3. So the question is how many people actually use Wires X? Okay, perfect. All right, good. So that question that we kind of said in there, what is C4FM, what is Fusion, what is Wires X? Well, C4FM is the digital voice protocol that we use, right? System Fusion is the name we give to our technology because it fuses together analog and digital. Now, you don't have to raise your hand, or if the person is in here, which you think of it right now, you don't have to point them out. But how many people have Fusion repeaters in their clubs, and when the idea of digital voice was brought up, it was like Walter from Jeff Dunham and digital was the devil. Okay, don't point out the people here, folks. Let's keep it civil. Let's keep it civil. All right, so what we realized that, right? And you've heard me talk about this before, and this is why I liked Fusion even before I started with Yaesu, because I've been playing with Fusion since it first got introduced, it gives a cool concept, what I like to call no ham left behind. So if you don't have people who like digital, can the system still operate in analog? Yes. If you don't like people that like analog, can the system be operated in digital? Yes. And can it be operated in AMS? Yes. That was a key part, and that's why we call it Yaesu System Fusion. But the aspect of Wires X is a means to link. And this was an important thing. And the reason it was an important thing is because, and you've heard me tell this story numerous times, I checked it again today, the amount of repeaters in Japan that are Yaesu System Fusion are 0, okay? Because there's a certain organization out there, we won't say names, but they kind of have like an R and an L in it, and then a J and an A, and they voted to say they don't allow, because the JARL is sort of like the ARRL and the FCC like had a baby, okay? That's the best way to describe it. And they said, nope, Fusion cannot be allowed as a digital voice mode. Well, this is a problem, right? Because Simplex works great, but it only goes so far. So we came up with Wires X. And does anybody know what the X in Wires X actually means? The reason it's called Wires X is because it stands for cross modulation. Wires X is the only type of digital voice technology out there that is automatically built in, that you can have a user go in on digital and you can have a user go in on analog, and the network will cross for you. You don't have to do any sort of things with your radio, and it gives that theory of fusing the two different voice technologies together. But Wires X was born out of Wires 2. Anybody ever hear wires 2? Okay. How many people have ever used wires 2? Okay. We're a dying breed, brother. All right. So reason being, and what the whole point of wires 2 was, it was a concept of saying, we're going to go and have a system set up where we have the ability to talk a radio to radio. So we put a radio in a house and we put another radio in a house and you can talk together. Or we have the ability to take and put this device connected to a repeater and that can connect to another repeater. And we're so clever on the naming, guess what we called this device that connected to the nodes and radios? The HRI 100. Oh, that's why we call it the 200. So what happened as part of this also too is we then allowed you to create sister radio groups. So a sister radio group, as you see on there, is that your wires 2 node was connected, and by simply doing an easy command on your radio, you could connect to a sister group of radios. Now, we call it the wires button. For those that don't know what it is, if you have an older radio, it is now what, as I pointed out in class yesterday, it is now what I've heard referred to as the Big Bang Theory logo, which is a little kind of like atom symbol. It was an atom symbol, but it's the Big Bang Theory logo now, I guess, from the Utes. And then if you had your sister groups, you had your friend group. Well, the way you did it was you programmed in that number into that wires X button, or not wires X, excuse me, wires button, and you push it, and then you key up, and then it delays it for a second or two, sends the DTMF tones, and then it opens up the voice. How many people have pushed that on their radios and they got really upset? If you've had it, you've done it, you're like, why is this radio beeping? We get calls all the time on older radios for it. But that's what the concept was. It was like sister groups and friend groups and stuff. And when we were going from wires 2, which by the way was created in our office in California, we said, we got to change that up if we're doing wires X. So what we did is, instead of having sister groups, we created a node-to-node concept. So node-to-node is simply, hey, I'm talking on one wires X node, and it's directly connected to another wires X node. And then we created, instead of friends groups, sister groups, those kind of things, we created rooms. Now with that, with rooms, we went along, and now you could do a couple things, which you see on the picture here. Not only can you have multiple people together, and if I talk into that room, it goes out to everybody, but you can also, as you see on the display here, you can go in analog, you could talk to digital users. Or you can go in digital and talk to analog users. Or you can go in digital to digital or analog to analog. The network cross-modulates it for you. That was a key concept, because now places that don't have repeaters, places that want people to connect to one another and use digital voice, it allows that. So who does not have a Yaesu System Fusion radio in here? Does anybody have one? Okay. After today, we'll get you one. Okay. You're gonna have to buy it, but we'll make you drink the Kool-Aid. Grape or orange? Okay. All right. So here, so can I pick on you for a second? Okay. So I got a digital radio. You have an analog radio. We want to talk together. Will that work? No. So who moves? Do you buy a digital radio to talk to me in digital, or do I have to put my digital radio in analog? That's the question. And that's what Wires X solved. Now, it was great. It was going good. How many people were here in 2018? We were in the old building, or the other building back then. Was anybody here for 2018? Okay, does anybody remember what we talked about in 2018? No? We talked about this. Because before, Wires X needed an HRI 200, it needed to have a mobile radio, and it needed to be connected to a PC, and you had to have ports open, you had to have this and this and this and this. Okay, that doesn't work. Okay, it really doesn't work, because now you can't take it portable. Like, I'm gonna go to the hotel and, well, it's Hamvention, so they know radio stuff at the hotel. But your normal hotel, you're going to get put on a list, folks. If you come walking in there with a mobile radio, a power supply, a computer, an HRI 200, and you call down to the front desk, hi, how you doing? I'm Mr. Crook in room 203. I need UDP ports 46100 through 46122 open, and I need a static global non-NATed IP address. You're going to get a knock on your door, okay? You're going to. So what we talked about at 2018 is what happens on the left side of that screen, where we said, hey, HRI 200, I say nay, nay. Let's go ahead and have it so you can directly connect your radio to a PC with just one cable, and you could talk on Wires X. Well, that's pretty cool. And we talked about it, how he said, okay, you're gonna have a radio to talk to a radio, and you're gonna do that like on that picture there. Well, many of you afterwards who were there came up to me and said, John, great idea. Yeah, thanks. It's an idiot job. What now? So they said, why do I have to use a radio? Why can't I just use a microphone and a speaker on the radio? Oh, okay, that's cool. All right, I don't want to just talk to digital stations. What about the analog users? Can you do that? And we're like, oh, okay. And then, hey, what if we made it so you could use it in direct mode now as we know it? And what if we use it in access point now mode and we just switch by hitting a button? Okay, great idea. So then we took back to the drawing board, and then we went along and said, hey, here's a great idea. Japan, do this. And then in the end of 2018, Yaesu System Fusion 2 Wires X, in essence, version came out, and you now had PDN operation. Now, what are the things about Wires X? We keep it as a closed network. I'm not going to hide or deny that at all. It's a closed proprietary network. And the reason we have to do that is we want to keep it an amateur radio network. If we had an open network like this, we could all, I think, safely agree, can go in our minds and think of how someone could turn it into a free business network or use it to like link GMRS repeaters or link commercial repeaters, stuff like that. So we do have steps you have to go through for Wires X registration. Now, the biggest thing I want to start out with Wires X registration is two concepts I want you to walk out of here with today. If you remember nothing else, just these two. One, you do have to register for a Wires X node, okay? That registration is tied specifically to that node and radio, meaning my registration for Wires X is my ID is tied to that radio, and if I ever sell that radio, in essence, I need to deactivate it, okay? Number two, you do not have to register radios to use Wires X if you are a user, okay? How many people are familiar with D-Star and DMR in here? And P25 and all those, right? What's one thing you have to do for DMR P25 next gen? What do you got to do? Get a radio ID, right? What about D-Star? Register with the trust server, right? You don't do that with Fusion. The only radio you need to register for Wires X is the radio that's going to be physically connected to the computer, okay? And if you have two radios you might have on at one time, I have 7 Wires X nodes running at my house at any one time, all right? It's because of testing and stuff. I'm not that important of a guy that I got to hop between 7 different rooms and stuff like that on there. I like to think that I am, but I'm not. But we test things out. We talk to the office. I know I've seen a few people here where you guys were having Wires X trouble. I said, come to this room, test it with me real quick. We can do some of that testing remotely on there, but you don't have to do it. So if you have 4 handhelds and 5 mobiles, you do not need to register all of them. You need to register the one device that is going to be connected to your computer. And we stress that a lot because people think that I need to register with every radio. But then what's worst part about it is they forget that each registration is per radio. So what people will do is they'll register one radio, then they log back into their account, and then they try to register another radio. You don't create a second registry. What's happening is you're replacing the first registry because each registration is associated to one specific DTMF ID, which is associated to one specific radio on there. Member registration is pretty simple and pretty easy, okay? You go through there, you fill out a form. Once you fill out the form, you're gonna get this form back here and it's gonna say, yeah, this is your information and here's your DTMF node and ID. Then you're gonna go ahead and plug it into the system. The first time you connect your radio to the Wires X software, you wanna make sure that little DPID or serial number, the HRI 200 shows up. And then what you're gonna do is you're gonna put in your DTMF node and your DTMF room ID on there. Now, one of the things that a lot of people have questions about is what are the official types of Wires X setup? We get a lot of questions on there these days, especially where there's multi-mode rooms that take place, multi-mode rooms that connect. So what ends up happening is people think I can get on hotspots, I can get on this. Well, you're not actually accessing the Wires X network. You're accessing their radio that accesses the Wires X network. So some of the setups are the HRI 200. Now, the HRI 200 currently is needed for interfacing to a DR1X or DR2X repeater. It is also needed if you plan to host a room. It is also needed if you plan to use analog on the WiresX network. And it's also needed if you plan to do any sort of like text messaging uploads, video uploads, picture uploads, those kind of things like that on there. You need the HRI 200 for that. The next setup is our mobiles. Now, our mobiles utilize the SCU cabling kit. And our mobiles that are capable of doing it are as follows. The FTM 100, the FTM 200, the FTM 300, the FTM 310, the FTM 400X, the FTM 400XD, or excuse me, D and XD, the FTM 500, and the FTM 510. So pretty much every digital radio we've had on the market that has a 10-pin mini DIN connector on there can be used with the PDN operation with the current firmware. Finally, we have our handhelds on there. Now, the handhelds are different in regards to it because the handhelds, they're more limited, and we have the FT2, the FT3, and the FT5. Now, people said, why can't I do it with the 1? Why can't I do it with the 70 on there? Well, the unique thing about the 2, the 3, and the 5 is you actually have 2 fusion vocoders in there. And you need the dual vocoders in there. So that's why the 70 can't do PDN, and that's why the FT1 can't do PDN. Because remember, the FT1 only had 1 fusion vocoder in there. You can only do fusion on the top band, not the bottom band. So as I said with the HRI 200, we have it that you have some specific things. Now, connection to the DR2X, connection to the DR1X we talked about. The room thing, I'm going to put it this way, is today you need it for a room. Okay? I'm going to show you why in a minute. When you use an HRI 200, you have to put the radio into WiresX mode, and that basically turns off the internal brains of it. So like if you connect it to a DR1X or DR2X, what's going to happen is that the internal controller disables, and it looks to the frequencies and everything in the WiresX software. Okay. It does require UDP ports to be open if you are running version 1.57 or older. Okay, we're going to cover that 2.0 in a minute. Does require Windows computer. I can't go into specifications, we'll put it that way, because I like to keep my job. But you can, we will run it in Windows. There are things in Windows that are safeguards that we have to have it run in Windows. That's all I can say on it. I know people ask, can we run it in Linux? Can we run it in Mac? Some people run it in Parallels. Some people run it in, what do they call, Windows for Linux or something like that. They've had some success and others have had no success, but the ultimate way to make sure your WiresX software node runs is with a Windows computer. Now let's talk about PDN operation on there. So that's going to be our mobiles and portables again. Does not require the HRI for HRI 200 for operation, requires the cabling kit. There's 2 different modes. There's PDN, personal digital node, where you can only talk to other digital nodes, and then there's HRI mode. HRI allows you to talk to digital or analog modes. Does anybody know what HRI actually was designed for? Why it was called the HRI 1, and now it's the HRI 200? Does anybody know what it means? Were you at my class yesterday? There you go. See, he remembered, folks. All right. Human radio interface. Human radio. Close. And that concept came because you are your user accessing it, and it's the radio interface on there. So it was kind of cool how why HRI come up, but it doesn't require the HRI 200. However, one of the drawbacks to PDN operation or HRI operation in this case is if you do the RF link, so I take my handheld, talk to my PDN mode and access point, it only does digital. It doesn't do analog. You can go into the WiresX network on digital and talk to analog users, but it won't let you do analog over the air for it. So when you're talking about PDNs, you'll hear us, if you ever call in, we're going to ask you what mode of operation you're in. Are you in PDN or are you in HRI? Now, to confuse you even more, because that's what we like to do, we decided to say, hey, not only modes of operation, let's have it as types of operation. And the types of operation are direct, which you're using the speaker and the microphone for on the radio, or access point. Now, access point is like an access point, like a Wi-Fi access point, right? You use your radio, you talk to it via RF and digital voice mode, then your node hears it, sends it on down the network. Direct means direct. You're not using a radio, you're going to be using the microphone and the speaker of the radio to talk into the WiresX network. So your radio, like your $600 FTM 500 or 510 turns into a glorified speaker microphone. It's true. So those are the 2 different types of modes on there. Now, looking to the future, System Fusion 3, the third generation, as I said, focuses on infrastructure and networking as a main key thing. What we had heard from a lot of people is we get this thing of saying, I don't want to have so much equipment hanging off. I don't want to have to carry an HRI 200. I don't want to have to, the cables and this and a 10-pin mini DIN cable, and John Yezu's stupid because it's like a proprietary 10-pin, da-da-da-da. So we heard it. We heard you. And what we did is we said, okay, let's make the change. And the change that we're moving to is how the FTX1 and Wires X are going to operate. And I got to boot up my other computer here real quick. But while that, does anybody have any questions? Mark, do you want to, if you run around, if anybody has a question, what we talked so far, I'm going to hook up my other computer, and then we're going to look at Wires X version 2.0, and then we're going to look at the FTX with it.
Anyone have any questions? Okay.
I have a 991A, and I have to use a Pi, little Pi computer to interface to Wires X. I guess, because I can't do, there's no repeater in my range. So is that the preferred way to do it, or is it going to change with this FTX one?
No, so good question. So how can you access Wires X if you have an FT991? So the FT991, when it came out, it had the ability to transmit on Fusion, but the audio circuitry that we use for, in essence, PDN now was used as part of the sound card. You have to remember the FT991 came out in 2014. So right after Fusion came out, it replaced the 897. So it wasn't there then. Now, could you hook an HRI 200 up to your FT991 to use it analog then to go into the network? Yes, you can. But if you want to do digital voice with your FT991, you would either have to have like a handheld or something to access the Wires X network that way. If that makes sense. Okay.
Any other questions? Okay, let's go to the back and then I'll catch over here.
Windows in order to do whatever it was.
Correct. Wires X.
You had to have Windows running on a computer attached to the repeater, or Windows attached to your radio as a client.
Correct. So you have to have it. So you have to have Windows running the Wires X software, which then either connects with the SCU cables to the radio, or the HRI 200 connected to the radio. No, the repeater itself doesn't need Windows, but the HRI 200 connected to it does.
I'm probably a little different on some of this because I'm a field network engineer. I do tier 3 work, which means I travel state to state to state, and I have a FT 510. And one of the things I run into all the time is that the repeater guides and stuff will tell you where the Fusion repeaters are, but not what the settings you got to do. And I'll start using my radio on a Fusion repeater, and I'll get off our repeater because you're messing it all up. You're talking over in Florida and not where we're at. And get off of it now because you got to use these settings and these settings and these settings. Is there a way to find the right settings?
Sadly, to be honest with you, that comes to marketing and how people present their repeaters, right? It's kind of on that due diligence. I won't get into like on a personal platform and stuff, but I can go ahead and tell you right now off the top of my head, I can go to 3 different resources for everywhere in the United States, and it will give you 3 different sources of information on what the repeater does or doesn't. It's open. Fusion was designed to be open. So if a person wants to have it only connected to one specific repeater or one Wires X node or IMRS or something like that, that's their prerogative. We do have suggestions of what people could do, what people should do. But you lead a horse to water, can't make them drink necessarily, right?
Any other questions? Wow, we've answered all of them.
All right. So kind of talking about Yaesu System Fusion 3 here. I'm going to make sure I get booted up here. But one of the concepts we changed to, and you can relate to this here, the quagmire of IPv4 versus IPv6. So WiresX used to need a global non-NATed IP network address, and that network address needed to see and have UDP ports open. The problem is that as we start to move to different types of technology, IPv4 is slowly going away, right? And with IPv4 going away, IPv6 is replacing it. Well, WiresX didn't work with IPv6, so we came out with version 2.0. Now you got to remember, when we're doing the software for a global standard, right? IPv6 is a standard, IPv4 is a standard. However, we got to do things different in America. What we did is we found out that there are some places which are IPv6, like your T-Mobile hotspots and your Verizon hotspots and AT&T hotspots, and even some home services. And then there are some that are just still IPv4. And then there's some that are IPv4 and IPv6 stacked. And then there's some that were IPv6 to 4. So meaning it looks like IPv6 within their network, but then it goes out on IPv4. That was problematic. One of the reasons and why we went to version 2.0, hang on a second. Tell him I'm in the shower. One of the things we went to, and the reason we went to 2.0, is 2.0 does not care if you're IPv4 or IPv6. It really doesn't. But for those instances where we had issues of some of those cellular providers or internet providers doing this IPv4, IPv6 thing, it was quite problematic. So what ended up happening is we had this issue, and when this issue arose, we said, okay, some people had issues connecting, there was some issues doing it, but more importantly, when we release a new version of WiresX, the reason we're releasing this new version of WiresX is because there's an update to it for radio support or some other changes. People are like, well, if it ain't broke, don't fix it. Well, but it's not. It's broke in a way, right? So we went along and we did that aspect of it. And there were some people that gave us good comments and feedback and everything like that. And then when they gave us good comments and feedback, then when it came and gave us good comments and feedback, then what ended up happening is we were able to get everything kind of going, and we knew IPv6 was going to be the way to go here. Now, part of it also went along and boiled down into it of saying, hey, here's the deal. Whoop. Part of it also boiled down to in saying, hey, here's the deal. We need it to be able to find the network sooner. We need to be able to find the network faster here. And sorry about this. It's hard to do it this way. And in that case, and in that scenario and situation, that's what 2.01 did. Now, part of the things about 2.01 versus 1.57, 1.57 is not compatible forwards with 2.01 unless you have backwards compatibility turned on. If you don't have backwards compatibility turned on, then it's not going to work for you. So with that being said, it's important for people to upgrade to 2.01. If you have 1.57, you are not going to allow users of the FTX1 to go ahead and operate on there. I'm not sure why it's not seeing that real quick. Let me close it here real quick. And then furthermore, when you have the situation also pop up, if you don't have that backwards compatibility, you're not going to allow new users to talk with their radios that they want to, and then you're not going to have old users talk with the radios that they want to on there. Hang on. Computer cord's flying out. So, 2.01. plug the plug-in. All right. So 2.01 is going to be the new standard of things. And when we have 2.01 to start to take place on there, you're going to see a change of things happen. And the biggest thing that's going to start to happen is you're doing the ecosystem. One of the ways that System Fusion 3.0 took place and everything on there is, by the way, I'm just connected on this phone here. Look at how fast it already keyed up. So we wanted to make WiresX more usable and accessible. Part of that also too is you see this is the FTX1. Our thought process is now moving to flexibility and versatility heavily. Starting with the FTX1 and stuff you're going to see progress out there. The FTX1 can operate in direct mode, meaning you can use your microphone and the speaker on the radio and be able to communicate. It's going to be able to be operating in what they call AP mode, which is going to be your digital usage mode. So in essence, PDN. It's going to allow you to operate in AP PC mode, which is going to allow you to operate as a analog node. But also too is we want to take it forward. And right now with the WiresX software and the FTX, this is all you need right now to host a room. So the HRI 200 is not needed for it. But if you take a look at how the ecosystem is with WiresX now, you'll see in the bottom there, it's taking a few moments to connect because I just turned it on after I booted off, so it's reestablishing the network. This is all version 2.01. There's not really a change for anybody to see on there. How many are using still version 1.57? Do you see a change on there? No, you don't, because there's no change operationally. The changes, some of the features we added on there, so are behind the scenes. So for an example, right now, if you go in the upper left corner, or upper right corner here, you can actually tag that. OneDrive, they don't like it. But you can toggle off your node. So you can put your node in now to receive only mode. So it's not going to transmit out. So if you want to sit and monitor WiresX, you can do that. Biggest thing that's coming on here, and this is even show you the proof of the point that this is room capable. Look at what we have here, the IP specs. So you have the ability to select WiresX now if you want to run IPv4 or IPv6. How many people know if they have IPv4 and IPv6? Exactly. If you don't worry. WiresX will figure it out for you. All righty. It will determine what is the best for you. You may be able to click on, if you say, hey, I know I have IPv6, I want to use IPv6, great. There we go. It just connected, and it just connected to my room automatically. So with that being said, you have that ability now that the system will help determine what you want to do. And actually, this is a room that people are playing with over at the booth there. But what happens then is, in this case and scenario, it will start doing the work for you. And when it starts doing the work for you, it alleviates things. But in this case, what you can do here is if you take a look and you want to connect to your own room, or actually we'll start out over here. Let's go back to file here. If you want to make it so people can connect to your own room here, do you see this where it says new version only or old version compatible? So new version only means anybody who's using 2.0. Only 2.0 users can see your room. Alrighty? If you select to old version compatible, it's going to give you this alarming thing. Hey, you're changing things. Okay, cool. We're fine. Let's reboot. And then when it reboots, it will go back into old version compatible room. Now remember how we said we had to have UDP ports open? Well, guess what? If you're still using version 1.57, you are going to have UDP ports open. This is why we're telling people, if you want to not have to worry about ports anymore, you should go to WiresX version 2.01. Okay, this is the thing, because how many people have heard the rumor that if you put old version compatible, 2.0 can go back to 1.57? If you've heard that, that is wrong. Old version compatible basically means your room to be able to go back to there. Now notice if it's old version compatible, my IP spec is going to be 4. Watch what happens if I try to go to 6. It's going to go ahead and error out. It's going to say, hey, you're changing me to look for IPv6. Okay, fine, not a problem. It will exit the software, and then it will come back in. If I reopen up the software, you'll see something interesting change with that. And in this case, my room compatible still says old version compatible on there, but look at it. Because I have old version compatible selected, I can't go to 6. So in order to do 6, you'd have to go new version. It's going to yell at you. And it's telling you, because it's changing networks, it's changing the way that you can connect people or have people connect to you. And then if we go back into it, now you will see with Wires X on it, on how you can now, since we have new room compatible, now look what happened. I'm on IPv6. Does that make sense for everybody? And that's the thing. And here's the personal preference. And personal preference really is what it is. Do I stay on IPv6 or IPv4? Well, if you're on 6, you only get new users, right? The new version users. If you're on IPv4, you can have old version compatible, which means people can connect back into you, but you're going to have to open those UDP ports. This concept with the FTX1 is the start. That's all I'm going to say on there. It's the start. But now it's going to allow you to do what I'm doing here. Have access to the internet, have a PC, and have that radio there. And now I can host a room. I can connect to rooms. I can do whatever I need to. So, question in the back there. Nope. That's the best part. No ports, no more static IP addressing, nothing. As long as you get an internet connection with version 2.0 and you don't want to have backwards compatibility, you're good to go. Not only for this, but if you're using an HRI 200 on IPv6 also. So it really kind of eliminated that hassle that so many people have, or starting to have more and more each day. Actually, we've had people that have said now with version 2.0 and IPv6, Starlink works. Yeah, and if you're on 2.0, that's why. That's why, because 1.57, you need that. It's IPv4, need ports, need a static IP. Not a static IP, but a global-facing IP. That's a better way to say it. Any other questions? I know I kind of hurried this because they ran over on the other time here. Yes, sir. No, it does not. No, it does not. The way the DR2X for sure, the DR1X, the DR2X did better timing, but it treats the signals as the same. So it's going to be first signal to the machine and valid mode. So it's like if it hears an analog signal and a digital signal, but the analog signal doesn't have the right PL tone, but the digital signal meets the requirements, it will go to digital. I'm sorry, say again? No, it will go to, if you have it in AMS mode, it will vote. It will vote which one to do, analog or digital. It can't do both at the same time. No, it cannot. Yep. No, so YSF is basically a reverse engineering of our Yaesu System Fusion over the air protocol, which we call CAI, Common Air Interface. They reverse engineered it to see how the protocol works and put it on those devices. So they are on their own network, and being on their own network, they're not Yaesu devices. They don't have DPIDs. They don't have, they basically just are tunnels. There's no way to find out who is using it. They're not going to connect to our network. Okay. Any other questions? Yes, sir, way in the back. Okay. No, it's still going to require like a whitelist. It's still going to require the setup the way that it is and stuff like that on there. Group mode is designed and thought of in the Wires X concept of being sort of an open but closed repeater is really what it is, or Wires X node, I should say. Meaning you beacon out, when you beacon out with the group mode on your Wires X node to radios that are on that whitelist and they beacon back, that's like the access. That's like the handshake, the secret squirrel, symbols and everything. It's still going to operate in that same manner. Yep. That's really what the upgrade feature is. And I kind of joke about that because there's people who are saying, like, okay, it goes back to that adage. If one person says one bad thing, 3 people will hear it. Those 3 people tell 3 people, right? That kind of thing. People were saying 2.0 were broken. It wasn't. What we designed it was because it was working around the world. It's just some internet service providers had it. What we told people is that, and we have 1.57 on there. Take your time, upgrade, and call us. Endolf, if anybody knows Endolf Buckley, myself, Edwin Lopez, we take calls all the time on it, and we educate people. I mean, I've had people that were like against it, like they were in the room and they started out. I'm going to start out on the Zoom meeting by telling you Wires X is stupid for going to 2.0. I'm like, cool, let's do it. All right, let's go through it. And then by the time you show them the features of how to mute someone in the room, how to kick someone out of your room, to do these things, and I said, look how fast it connects, look how easy it connects, then they're like, oh, I guess the hype was bad. So you can't be afraid, right? We're amateurs. We experiment. We blow up who has not blown up a couple capacitors in their life building kits? Or, well, I can't talk about that. Still statute of limitations. Yeah. It was not my fault, okay? And an acquittal is not a conviction. All right. Any other questions? Yes, sir. No, so remember the concept of IMRS? Good question. IMRS was designed to not require the internet, but to require a IP connection. And right now, still internally, I know we're slowly migrating to IPv6 on internal connections. If you get some routers, you can select IPv6 now. But in all intents and purposes, it's still remaining in that IPv4 net addressing on there, because that's where the majority of things reside in it right now. Networking right now, from what we did from our collection data, and private networks or home networks, I think really there's only like 13% that are utilizing IPv6 in these networks. So at this point in time, no, it's not going to. But good question. Any others? All right. If you haven't, stop by the Yaesu booth. We'll have a demonstration on here. We also have the DR3X, which we announced here. No pricing, no availability yet. We anticipate it by July, August is when we'll have it out for sale on there. We have some features on it now. I can tell you there's more features coming, but we wanted to introduce people to it today and start to let people understand what it is, because there's some features on it that are beyond what people thought a repeater could do or should be able to do. So I thank you, everyone, for going in and doing it. And as I always tell everybody, I never know when my last day is ever going to be on this earth or with this job. So thank you for listening to me. And I know I have a face for radio and a voice for newsprint. Yeah, so what we're telling people is what we tell people is put in if they want to be also has No, I hear that same thing from students. That it's so sad because it really comes down to the different services and stuff, and just people not updating the well, but then I go back to well, he went. Right. No, but I wish I had that's the best solution we can do as a guest on you. But I've had it come through. Oh no! This is we're using this repeater for this and stuff. And it's like, okay, the Wires X system has announcement features in there. The DR2X with the IMRS board has announcement features in there. I was using the Wires X in analog back when it first came out for our weather nets. Because you could set a message to play emergency message. It plays every 10 minutes for 1 hour. So it's great. When there wasn't talking, guess what was happening? That message where I play, Skywarn Net is activated. Please keep traffic related to Skywarn activities. It was great. The net controller, when I was in net control, I don't have to talk. But I do hear you good. Good things are coming. Good things are coming.
So what I'm thinking is, it's
good things are coming. Okay. That's what I said. I said we're not going to release it until July. I think by far, nothing my I have my now instructional test. Right. What we will split repeater. So we'll start to start main repeater and smaller and think of it this way, I have this at home to my repeater, which is I go out of my car, my hand, I have to touch, but now I stick my hand over my feet. And now I'm going up to I think it's an LP. Looking down the line at LTE, I can go and go for the Philippines. So the thought is, I'm going down. What's inside? Engineer. Yeah. Right? If you want to go down here, I can't leave them all together. My hand should be because you guys have already put the receiver up in your sockets. Yeah, then you can do that with your DR2X. I talked about it in class. Yeah, I talked about it in class. Obviously, they improved. They use inside IMRS. They have 5 repeaters, 4 of them use the A-sided 4 separate repeaters. So this repeater,
everything goes into the local repeater, they're on the inside, that drives to the B. That's it. No, I get that. Why would you get it from the top? It is like being with the top.
No, I'm not telling you that, but do we have to go up there or can we speak from down here? So if we can stand anywhere we want. Cool. I'll never get up and down. Yeah, I know that feeling. But we make sure we put all of our inputs on the same one so we don't fiddling around with it. Yeah, I mean,
Hey, not my problem. Yeah.
Want to plug it in? Let's see if it works. Yeah, I think I want to be able to look at my track.
You want to use yours?
Huh?
You want to use yours?
No. I'm just mine quote because I want to be on the right track.
Okay.
These are monitored. One second. Yeah, the microphone works. The young man dropped it. It made a big boom. So, yeah.
Or maybe this side.
Okay.
Who wants to go first?
I'm generally your specific he's getting a building permit. Why don't we permit? Then zoning general and zoning specific. You go first.
Oh, no. Oh, I see there. I'm about to find out.
Yes. So again, the logic is this testing. Permit, zoning, specific. Or do you want me to go? Look, I'll do it, but I'm just looking at this. It says. I think it's a good point. I'm thinking this when you sold it. Is this a touchscreen or do we have a mouse? It's okay if it's not. I just need to.
The answer is
I want to get to slideshow. That'll do it. Yeah. Oh, no. Okay. Well, I want to get to presentation. This is. I want to get to that. I want to go. All right. I'm going to hold you to that. Yeah. Here we go. How do I transition to the right on the drop down? I want to get to slideshow. Oh, I think you just. No, that's not doing it. Too much technology.
Maybe you have to use the mouse pad.
I'm looking for the mouse pad will work,
Yeah.
but it's not. Oh, there it is. I see. There, I found it. I found it. That's what. Okay. Been there, done that, and I have the T-shirt to prove it. We'll give it a couple minutes. Now that's a lawsuit waiting to happen, so be careful.
Yeah, 24.
Yeah, we'll start in a couple minutes.
Okay, we're going to start at 30, which means that you've got about 4 minutes if you want to ask a question, and you don't want the rest of the people who are going to arrive late to hear it. Anybody looking for free legal advice? Everything you're going to pay is what we will accept. Please. I wish you hadn't asked that question. First of all, they wrote it without consulting with N5AUS or with me, and we are the two co-authors of the homeowner law that's been presented to Congress and now has 38 co-sponsors, has been reported out of the subcommittee of jurisdiction to the full committee of jurisdiction in the House, where the chairman of the full committee in the House is a co-sponsor. So we're sort of passingly knowledgeable about this topic, we think, and they went ahead and did it without us. They also took a very broad brush to the subject, and but they got it through. They got it through. We could never get it through the Congress, the U.S. Congress. Frankly, that's the second time I've been asked that question in the last 10 minutes. Front row got me first. And I really haven't got a clue as to what's going to happen. I suspect that some of the language is vague enough that it's going to virtually require litigation, and that means it depends on how well represented the first radio ham test case is and what the courts decide to do with the statute. You know, they just call the balls and strikes. You may have heard that. You guys know anything else about the Indiana? Nah, they did it without us, so we're not knowledgeable about what's going on in Indiana. Maybe they are, to use the Latin term, sui generis. unique unto themselves. Any other question? Okay.
While we're waiting for others to come in, we got a couple minutes. On that state bill we just spoke about, one of the concerns that we have about having different state bills, I mean, it seems like a good idea, right? Why not? But if you get enough of those, well, they're all different, that may not necessarily be a problem. But the the opponents of our federal bill have said this is a state. We don't need a federal bill because they don't want anything. And that stands to reason. I don't really know what the best answer is, but if you have a whole lot of state bills, the opponents will have an argument that we don't need a federal bill, and people that don't have protection will be left out. Also, some state bills were awful. One, anybody here from Maryland? You have a state bill? Okay, it's the worst bill I've ever seen. It talks about, doesn't mention ham radio, it just says radio enthusiasts, which cover people 11 meters using 5 kilowatts. Anyway.
Just one thing to show you what the federal bill looks like. I just happen to have a copy or two. If anyone wants a copy of it, just raise your hand. I'll come deliver a copy of the federal bill to you.
One thing about, you'll notice, if you've been a fan of these bills and been watching our league trying to produce something, I encourage you to look at the old bill, which I was an opponent of, by the way, and I practice law for a living. I do a lot of antenna work. The old bill we had was horrible. This new bill that was worked on for years, I encourage you all that are interested, put the old bill on one screen, put the new bill on another, and you tell us why ours is, the new one that Fred wrote, is much, much better and is more difficult for our opponents to oppose. And better yet, the old bill, in my considered opinion, would have made things worse. We oppose that internally, not because it was a compromise and we needed more, but because it actually was going backwards. We kind of snookered, in my own personal opinion. That's why it was dropped. Some of you have asked that over the last several years. Why did you not pass the Parity Act? You remember that? This bill is not only more reasonable, but it's hard to oppose. And you'll see why when you compare the two. We'll get started here in 1 minute. He had just explained that, and I'll have him explain that again. This bill has got a lot of sponsors. It's been slowed down because of what's going on in Washington, but the gentleman here is the expert on the status of the bill, which he explained a few minutes ago.
Glad you asked the question. The federal bill, which is in this Congress, S459 and HR 1094, has been favorably passed unanimously out of the subcommittee of jurisdiction, and it has been moved on to the committee of jurisdiction. Were you just waving, or did you want a bill? Okay. It's been passed on to the full committee of jurisdiction in the House, and the chairman of the full committee is a co-sponsor of the bill, so we're hoping for favorable consideration there. On the Senate side, one of the co-sponsors left the Senate Committee on Commerce to become the chairman of the Armed Services Committee, which means that he has big swag in the Senate, because armed services is a very big deal. He's the senior senator from Mississippi, and we haven't got much in the way of indications on that side. I will tell you that the bill is pretty much evenly bipartisan in terms of Democratic and Republican co-sponsors. But the heart of the next question you would want to ask is progress of the bill, and that is that basically the Congress is locked up tight at the moment. Nothing much is moving. There's no vehicle to attach it to, and we can only hope that something will unlock, or maybe somebody will just decide in the dead of the night that this is non-controversial, and it should be non-controversial except for the homeowners associations, and favor us, because our pitch is basically when we're on the Hill, no antennas, no ham radio.
Yeah. And no ham radio, no emergency communications, which is still the reason amateur radio exists. A lot of our members and hams don't agree with that.
You should see the reception we get in the offices of the senators from Alaska, where they think ham radio is really important.
And that's our bargaining chip. That's why we can ask for spectrum in which they now measure megahertz in billions of dollars. You all know that. You watch the news. It's getting worse.
Okay, we're ready to begin. It's 32 after the hour. I'm Fred Hopengarten, K1VR. I live in Lincoln, Massachusetts. I'm accompanied by Bob Familio of the Philadelphia area. He is K3RF. And sitting down is Dale Clift, NA1L, as in you've been nailed. And we are all three licensed attorneys. We have all handled antenna cases. In my case, it's pretty much what I do for a living. I wrote the ARRL book, Antenna Zoning for the Radio Amateur, and I happen to have like 12 copies available for sale for $40 at the end. Unnecessary commercial plug. And if you're nice to me, I'll even autograph it. They're $49.95 at the ARRL and DX Engineering plus tax plus shipping. It's $40 cash only right here. Now, Bob is going to begin, and he's going to talk about the building permit process. Then I'll talk about zoning laws, in particular those that have a firm fixed maximum height, like no higher than 35 feet. And Dale will give you an example of a case from his home state of Connecticut following exactly what happened in that particular case. We have agreed, and I hope we'll live up to our agreement, that each of us will speak for only 7 minutes, which should leave you about 20 minutes for questions. And then we can also just go out in the pouring rain and answer more questions.
You know how painful it is for a lawyer to be told that he or she can only speak for 7 minutes? Yeah, well, you know, we charge by the hour, so I'm going to go broke. But of course, my name is Bob Familio. My call sign's K3 Romeo Foxtrot, or K3 radio frequency. And I have been on a volunteer council list since 1985. Been licensed since January 67, and had no idea when I was licensed I'd end up a lawyer. I'm a double E. It had, I stood in the wrong line. I became a lawyer. A long story. But I'm going to talk to you about permits, building permits. And the reason for that is that a lot of the calls I got this year was about the problem with the building permit, not so much the zoning. And it is, how many people here have applied for a building permit for their tower? How many people here had a problem or some difficulties doing that? There seems to be a misunderstanding, and what I want to talk to you about today for 7 minutes or less is the difference. A lot of people are confused, and a lot of the calls I get as volunteer counsel. In fact, I was chairman of the Legal Defense Committee for several years until I was suggested I should leave with ARRL. Some of you know that story. It is different. There's a zoning code that tells you about where and how high you can build. And then you have to know how to build it. It is possible to have zoning in your favor and mess up with a building permit. I've got a lot of calls and a lot of horror stories we're not going to have time for today. But you need to have a building permit in most jurisdictions. Real estate and zoning is very state-specific, and in many states it's even town-specific. So what we're going to be talking about is just general principles. Your jurisdiction may be different. I'm licensed to practice in 5 different jurisdictions, but there are 50 or more that you need to worry about. They're all philosophically similar, however. Pardon me. So building permits are for safety and structural integrity. You could be legal to build zoning-wise to build to 60 feet, but you still need to have a permit. And a lot of people do that. They know, they look at the code, the building inspector or the zoning guy says, yeah, you're allowed to have up to 60 feet. You're a ham, and yeah, we understand. A lot of state laws allow that as well, forgetting PRB 1 for the moment. And they put the tower up. without realizing that they also have to have a separate building permit. Sometimes those procedures are combined. When you apply for a building permit, they will check the zoning once they see what it is you want to build. So building codes, they're pretty standard across the country, mostly BOCA codes or the International Building Code. Many of you may be familiar with that because it's the same as whether you got to build a deck for your house or a swimming pool or put a new roof on, or electrical permits if you're changing your panel out. And ham radio antennas, even though they're accessory uses under the law, are no different. This is probably an eye test here. I'm sorry that it's so small. I should have made that larger. But most of your towers that you buy, you're not building your own most likely, but you buy have available manufacturer specs about whether they meet minimum standards, what codes they comply with, and some states typically will, or some manufacturers will have what we call dry stamps on their plans that a local municipality will look at and say, if you build to this, and we inspect it and it's built to the manufacturer plans, stamped with a professional engineer, but not a wet stamp as we call it. It's just a pre-printed thing. We'll allow it. Many states are good about that. Some are not. Some will want wet stamps, meaning that you have to get a professional engineer. It's going to cost, unless you have a buddy, it's going to cost thousands of dollars to review it, be liable for it meeting code. And he or she will probably be able to do that quickly if they look at the manufacturer specs. And they'll put a wet seal on it, professional engineer. Some jurisdictions, a lot of large towns want that kind of thing. That's just something that you have to deal with. A lot of people don't want to do building permits because of that. It costs sometimes more than a small tower that they are buying. Now, here's the thing I want you to remember, if you take nothing else away today. I've dealt a lot with a lot of these cases. In some states, in many states, when you get a building permit issued, meaning that you've done everything right, you've followed advice and you've got a permit for that tower, you got to put up a sign saying, permit issued, and the neighbors get to see that and complain if they want. That happens in most jurisdictions. Do not build your tower until the appeal period, usually 30 days, not always, until that expires. I've got some sad stories. People just want to get it up because once it's up, it's up. It's too late for people to appeal because I already have it up. Answer, wrong. And see me later. I've got some wonderful horror stories for you, but people put up big towers and they did it within 5 or 10 days because they were in a hurry. They put the orange placard, the thing, the stake you put by the mailbox. Don't take it down and put it up by the house. I had a case like that because that starts the appeal period over or makes it invalid. And don't rush to put your tower up. Wait until it expires, because if somebody's going to appeal, they're going to appeal within that period. You can still fight it. You may have a right to that permit. You probably do if it was issued. But you don't have to go take your tower down. Been there, done that, seen that. So don't do that. Don't exceed the permit limits. It's a combined zoning and permit issue, but I've had clients, amateurs, and I'm a volunteer at this, and occasionally have taken a case that was substantial. I had to charge something. But do not decide that when you apply for a 60-foot tower, how high can your highest element or antenna on the top be? 60 feet. People don't realize that. So I just applied for the tower. The rest of them are appurtenances or just, those, they don't have to be on the permit, do they? Yeah, they do in many jurisdictions. It's a pain in the butt. But if you put up a 50-foot tower and you've got 15 feet of mast on top of that, plus a 15-foot vertical at the very top for 2 meters, 450, whatever, you exceed the height. You got to either make the tower lower or take your antennas off the top. Minute and a half. Okay, well, that's good. I'm getting through it. What not to do? Do not build until the period runs. We told that. Build only to the permit. Talked about that. Do not interpret your permit liberally. Stick to the limits. Stick to what it says. If you want something more, apply for that, but make sure that you be eligible for it. Accessories, guy wires, and everything have to be shown on the permit and have to be within the zoning limits if you have a setback. Avoid this. Here's what I want you to take away, if you know nothing else. Failure to post required permits. Don't do that, because I had people that take that down or put it somewhere else because I don't want the neighbors to complain, accepting the jurisdictional officer's verbal comments. I just had one of these a month or two ago. From another state was referred to headquarters than anybody else that could answer out there in California. But do not do anything by saying, the guy said it was all right. Even if they're not going to write you anything, you write them a letter. An email is okay. I prefer letters. And say, I understand that I don't need a permit. I understand that you've accepted this. Maybe they won't answer, but you need to have that even 10 years later. Got some more stories about that. It's ugly. We've already talked about building before appeal period ends, assuming approved height is only the tower itself. That's common. Don't do that. If you say 60, 65 feet, that has to be the very tip of anything. Don't forget to include mast and backstage. Now, I know I raced through this, but I will be around to answer questions. And if we run out of question time in here, I'll be outside if it's not raining. I'll answer all your questions, and I'll stay till you answer everybody's questions. Thank you.
Thank you, Bob. Just one comment. When you apply for something, if you're looking for a way to describe the antenna plus the tower plus the mast and any side-mounted things, use the phrase station antenna structure, because the PRB1 uses the phrases amateur radio station antenna structure. And several state laws use amateur radio station antenna structure. So those are magic words. What I'm going to talk about, and I'm Fred Hopengarten, K1VR, is antenna height restrictions that appear in statutes or maybe a state statute, but mostly in zoning ordinances. So what I was going to say is that, and here's the whole talk, federal and state courts routinely invalidate firm, fixed, unvariable or invariable, depending on your taste, maximum height limits. So if your town has a limit that says 35 feet or 50 feet or 70 feet, or if it has a setback regulation, which effectively has a maximum height limit, then you'll be looking at the kind of law and cases I'm talking about today. What I mean by a setback thing is, let's say you live on a small lot, and it's 50 feet wide, and there's a 25-foot setback, then the maximum height for your station antenna structure is 0 feet. Everybody with me on the math? If the setback is 25, you'd have to put, and your lot is 50 feet wide, you'd have to put your antenna in the middle of the lot. And as a consequence of that, you couldn't go more than 0 feet tall because you have to have a setback equal to the maximum height. I see the confusion. I'm sorry I introduced the confusion. In any event, these all conflict with PRB1 and the 27 or so states that have a state law that mimics PRB1. Now, even if your local ordinance has a variance procedure, and somebody says to you, well, it may be a maximum height, but you can get a variance, that fails the reasonable accommodation test of PRB1 because the conditions to get a variance are not the same as getting a building permit, and there's a lot of judgment involved, and you could be turned down. And as a result, a variance procedure will not salvage an otherwise firm, fixed, and unvarying maximum height. Now, here's a couple of cases just to show you. These are federal circuit court decisions. This is high-powered law from the Ninth Circuit in California, from the 10th Circuit in Colorado, and from the 8th Circuit in Minnesota. And those involved, well, I forget the actual maximum in the Howard case, but it was 35 feet in Colorado and 25 feet in Minnesota. Then there were some U.S. District Court cases, one of them involving Andy Bodoni, K2 Lima Echo. And if you were on this past fall, I was operating his station, which is now his vacation station, now located in Vermont, where a 25-foot height limit was voided. Again, the district court version of the Evans case in Colorado, as well as a district court case in Ohio in Rocky River. Don't they have great names in Ohio? Which was a 30-foot limit. There's a New York case involving a 20-foot limit, a Florida case involving a 70-foot limit, a Texas case where the limit was 35 feet and the variance procedure wouldn't save it, and the HAM was granted eventually a permit for 114 feet on a relatively small lot. Now, there's a man with cojones. A case I handled in Massachusetts involved a 35-foot limit, and a tower for microwave communications was put up at 140 feet. Relatively rural area, but the neighbors had complained. The Williams case in South Carolina may, in the eyes of the lawyer you retain or after you've read it yourself, make you think that life is bad, but it was subsequently effectively overturned by another ruling and order from the Federal Communications Commission. It had relied on a balancing test, balancing the needs of the community with the needs of the radio amateur. And the FCC basically, and courts have adopted this as well, says that the FCC did the balancing and the local community is not to do the balancing. Their obligation is to reasonably accommodate. A special note, by the way, I am of the view that the reason Williams lost is that he showed up with no indications, no scientific evidence, no HFTA, no propagation maps, no showing of need for the height he was applying for. He was opposed by a renegade electrical engineering professor from the University of South Carolina who said that 17 feet was plenty for your dipole. So this, to me, stands for the proposition that you should go in prepared with a showing of need. A little bit of clarification by the FCC. The FCC's PRB1 has a couple of parts to it. You can think of them as 3 parts. One of them is if there's an absolute prohibition, then that zoning bylaw is absolutely preempted. And the other 2 parts are that the municipality must engage in a reasonable accommodation, and this must be the minimum practicable regulation. If you want to know what minimum practicable regulation is all about, this was a phrase basically stolen from the Americans with Disabilities Act. So there's a lot of law on what those 3 words mean. I conclude by saying that where I started, absolute unvarying antenna height limits are preempted. You know, you might have to litigate, but you're going to win. And a variance procedure does not save an unvarying fixed maximum height. Now, with respect to what reasonable accommodations means, there are a couple of courts that say this means that the town must negotiate with you. Doesn't dictate what the outcome of the negotiations must be. And from labor law, we know that an obligation to negotiate does not necessarily mean an obligation to agree, or that you must concede with the town's position. But I leave you with this thought: be sure to prove the height, your need for the height you've requested. Thank you very much. And now we'll have Dale Clift, anyone else. Where'd it go? All right. Do you know how to convert it into slideshow?
Yes, I love it. Hi, everybody. I'm Dale Clift, Dale the Nail, because if you look at my call quickly, NA1L, it looks like nail, right? Put this in slideshow. Okay, I'm going to put that in slideshow mode. Right. And then from the beginning to the current slide. How's that? All right, and then I advance and I hit this? Yes, or the space bar. Or the space bar, okay, good. Right. So there's nothing like, oh, let me start my timer. Okay, it started. There's nothing like a good story to illustrate how these things work. And I have a great story for you. There was a case in Connecticut. By the way, I'm the corporation counsel for a medium-sized city in Bristol. Means I'm the city attorney. So I've seen it from both sides, pro and anti. But in Connecticut, we had a great case, a fellow by the name of John Drabick, and it was the East Lyme, Connecticut Zoning Commission. So let me tell you about him. John is a technician class operator, KC1KLZ. His proposal was for a 175-foot tower. Wow, right? What he wanted it for was to put up a repeater antenna so that he could get coverage throughout the coast of Connecticut, the downbound Long Island Sound, also across the way into Long Island, and to link up with another repeater in Middletown, Connecticut. So that's what the purpose was. East Lyme is very rural. It's characterized by the zoning regulations as sparse development, low residential density. Well, this is a very well-prepared case. He brought in an engineer who provided expert testimony about, the safety, the integrity of the tower, and so on. He brought in an expert on property values. I have to chuckle about this one. He hired the tax assessor for another town. Obviously, the East Lyme assessor couldn't testify against his own town. And he had a great legal counsel by the name of Eric Garofano out of New London. So he had a great team. Of course, the neighbors come out, it's mostly visual impact. And it's going to diminish the neighborhood, the beauty, the impact property values, blah, blah, blah. We've heard them all, right? I found it interesting. The staff of the zoning commission actually prepared two resolutions. One was to grant it and one was to deny. And of course, they went for the denial. But in reading the deliberation, the two commissioners who voted against it, they were very well reasoned. And I think they looked at what was presented and weighed the evidence properly. But, when you got a lot of neighbors out there, a bunch of eyeballs looking at you, people get a little bit concerned about that. So what happened when he got shut down, denied? PRB won. It came to the rescue, by gosh. So just a real quick refresher for you. PRB 1 was issued by the FCC back in 1985 after a lot of lobbying by the ARL. The authority comes from the Supremacy Clause of the Constitution, where it says federal law can preempt state and local laws. But it's limited. It doesn't, you just can't hand a copy of PRB 1 to the zoning office and say, you got to give me anything I want. Municipalities must reasonably accommodate amateur operations. They cannot preclude communications, but they may regulate safety. So when it was denied, the attorney for John, he immediately filed an appeal in the Superior Court in the Judicial District of New London. That's our regular first-tier trial level court. And this is a great judge, Judge Barbara Bailey Youngblood. And what she did, I think, really sets the tone for people who follow John in applying for antenna structures. She basically said, in view of the commission, that's the zoning commission's failure to propose a lower height that could provide suitable coverage, that the zoning commission did not attempt to work out a satisfactory compromise. It also found that the zoning commission, its logic was flawed. It had suggested that, well, you want to put your tower on this tower that already exists, when it was shown by John Drabick's experts that that's not going to work for us. There was no negotiation. They wouldn't even consider talking to the Ham about, let's talk about this. And so because of this, the judge ruled, you know what? Your decision, it's preempted, it's thrown out. So what does that mean? Well, unfortunately, it doesn't mean that you automatically get what you want. As in most cases on appeal, it gets sent back to the lower level, which in this case would be the zoning commission, to say, here's my opinion, now you make a new decision, but make sure you follow the guidelines in my decision. That's what remanding is called, what that is all about. So the bottom line was amateur radio operators have no right to build any antenna, but cities must engage in good faith compromise. Here's the epilogue. So went back, it could have gone, haywire again, could have worked its way up through the whole legal process again. But they finally did come to an agreement. John went from a 175-foot proposal down to 155, not too bad. Had to paint the tower gray, and then each party was to bear their own costs. So it was a great victory for PRB1 and for amateur radio operators, at least in Connecticut, and it shows a reasonable accommodation through the judicial system. That's it.
Thanks, Dale. And as we promised, this is your chance to get free legal advice. We'll take questions from any and all. On the left.
Yep.
My favorite question, because we have a name for those who build first and ask for forgiveness later, and they're called clients.
Yeah, that's never been the case in my view, and I've been practicing that you can ask for forgiveness. It's easier. In 48 years of practice, I've never seen that. But that is a common saying in lots of different things.
I should also tell you that the best kind of cases I handle are those where the client has already built the tower without permission because it means it's going to be longer and more strenuous, and I'm going to make more money.
But that's only for lawn sheds and deck. When I get there, I have to switch to a commercial cellular tower, one for $200. And at that point in time, the antennas and the masts are not included in that maximum height. They only want to know how high the tower is going.
And this gentleman did employ a very well-versed lawyer in Iowa and was successful in the long run. He's just being modest. He did get success. On the right.
All three of you mentioned this concept of need, to show need. What does that really mean? I mean, can't the other side basically say, we don't need this, this is a hobby?
The answer is, it goes to the question, how do you show need? And for VHF, UHF, you're talking about coverage. For HF, you're talking about the ability to reach the areas of the world you desire to communicate. And that phrase, desire to communicate, comes out of an FCC report and order. So what you do is you look at the terrain surrounding your house, the directions you want to communicate, and the height necessary. And as a result, if you do one of these studies and you're a little thorough at it, you're going to show up with a lot of science, and the other side is likely to show up with not so much science. And as a practical matter, some evidence generally defeats no evidence. So you can, in fact, create a showing of need with propagation maps to parts of the world that you have a reason to communicate to. For example, you're an immigrant from Italy and you want to talk to Italy.
So does that mean that you need to engage a professional engineer?
Not necessarily. I frequently use Dennis Egan, W1UE. The question was, how do you show the need? And do you need a professional engineer? Glad you asked. I frequently use Dennis Egan, W1UE, who prepares propagation maps using HFTA and 100-year cycles, and it's all very fair. And sitting in the back of the room was N6AA, who's one of the guys who reviewed the actual procedure for creating these reports. And he and a whole bunch of other real engineers, and Bob's the only engineer on the stage. My undergraduate degree was in economics. I'm a JD MBA. You don't want me doing your engineering. You shouldn't leave me alone in a room with a screwdriver. The point I'm getting at is that you can, in fact, prepare a showing of need without, and if you really want to, we can go back in history and I can come up with a PowerPoint that W1UE prepared on how to do your own showing of need.
A short comment on the war story. One of the major cases I handled that Fred was a consultant on and went to the Third Circuit, the opinion of the board below, the trial board, was that hams can use satellites, don't need antennas. Remember that? And it was stupid stuff like that. Yes, they use satellites. You don't need, all that kind of stuff. So you really need to have your, but the other thing is don't use the word hobby. Nowhere, not to go off on a tangent, but nowhere in the rules does it call our service a hobby. You may think that that's just wordsmithing.
We are the amateur radio service.
Right. And if you search hobby, you won't see it in there. That sounds ridiculous, but we are a service. And if you look at the rules, and I always do this in cases when just quote is Rule 1, 97.1 through A through F. Quote those. The very last one is international goodwill, and I attribute that to contest or something. I never include that. But
Next question.
The first four. The first four are what you want to do.
I successfully did put up a 70-foot tower in Fairfax County, Virginia, which is no small task. But my biggest problem was trying to find a Virginia certified professional engineer to sign off on the plan. Right. And I got one, but he lived across the country and then he died.
That's K7NV.
Well, no, actually, this was a different guy. This is the guy that Passion used. He used to use it until he died, right? So, at any rate, do you have any advice for trying to find a professional engineer?
The short form is buy from Roan or Tashjian, and for a fixed fee, they will provide you with wet stamped PE drawings from all 50 states.
CCRs that say I can't put on an antenna that emits and it literally blocks out. Put it on. I'm not looking for a fight, but should I go fight now or just take steps?
Well, I think that they have effectively banned microwave ovens and baby monitors, cellular telephones, and computers.
I don't think it would phones, but it would.
The short form is you were in a very bad situation, and you should be writing your congressman to promote the ARRL's bill. And I'm glad you did. On the left here, brown shirt, yeah, or whatever it is. Yes, first row, second row. Oh, it's my pleasure.
Wrote a awesome letter, and I think I have the only officially approved tower in Waterford Township. And he didn't pay me to say
Thank you very much.
professional engineer on staff. They do a lot of city work. So something needs a PE for a tower.
Obviously a plant.
Purple shirt. Blue shirt.
How do you learn about covenants, conditions, and restrictions before you buy the home?
Two steps. Number one, you read the chapter in my book. And number two, you had to be provided with those covenants and restrictions before you closed, or it was an illegal closing, and you're not bound by them.
In Connecticut, and I have done real estate closings, there's a law that you have to get all of those documents in advance. You have, I forget how many days, you have so many days to look them over, and you can get out of the deal if you're unhappy with them. Get a title report. In many states, now, what you want to get an abstract, but in most states you'll need a title report. And if you look in there and it says subject to title restrictions such and such, you have to ask. Many lawyers will miss that and they say, you didn't tell me you want to be a ham. You don't have to ask in Connecticut. Yeah. That's right.
You're also paying your real estate agent a lot of money. Make that agent earn his commission.
You get them without having to ask for them. Also, the gentleman raises a good point. If you're buying real estate, you put it in the agreement of sale. So before you sign your contract, you put in that subject to revoking if I can't put up you put some simple terms, an amateur radio antenna support structure. Give them 10 days
in a
or
hat.
something. Yeah.
Yes, she had authority. And
Well, no,
I hope
we-
you married that woman.
We have a disagreement. Did she have authority? I ran into something like that where president said, I can do this. You can have an antenna. And of course, that wasn't the procedure. The board had to vote on it. So even though there was something in writing, it was invalid. So be careful about that, depending.
Sure enough.
Yeah.
Questions? Funny you should talk about that. 4 USC Section 5 in the footnote is an absolute right, and it's called the Right to Display the American Flag Act, federal law. So there's a case, Torpedo was the guy's name. He tried to take advantage of that, not for ham radio, but rather because he was a veteran and wanted to fly a flag. The Homeowners Association took the position that he had the right to display the American flag, but he didn't have the right to have a flagpole under it holding it up in the sky. The Homeowners Association was virtually laughed out of court. You should read the opinion. It's a scream.
One caveat, if you have a flagpole and you're allowed to do that under some laws, you have 40-foot flagpole, if you're going to sneak an antenna in there, which is simple to do, they can still stop you. Just because you can have the flagpole, they might say, but you can't have an antenna. So if you do it in a stealthy way, well.
So don't apply for a dual use.
Right. Right.
Center. Yes, it's all about you. Yeah, the gentleman's question relates to the fact that once he was no longer categorized as an antenna, he was recategorized as an accessory structure with a maximum height of 25 feet. And once they do that, they've stepped right into that gigantic pothole called a firm, fixed, maximum, unvarying maximum height. And lots of good case law on that. If they say 25 is the max, whatever the law is that they're citing in the local zoning ordinance, it's preempted. No? Next. Please.
sale agreement. And I said that the sale agreement is only valid in the absence of and that forced the seller to find out whether or not that was true. That put the whole onus on the seller.
Well, when you are in the process of buying and you're about to write a very large check, you have your maximum power in any negotiation.
Yeah,
And
if you're-
the fact that this gentleman had a requirement written into his purchase and sale agreement meant he was taking advantage of that maximum power, and it worked out for you. Glad it did.
Remember, the time to worry about this is before you sign any agreement or any letter of understanding or put down any deposit. After that, your power diminishes. You may have no rights. I've been to maybe 100 real estate closings, residential real estate closings. I do commercial ones now, sometimes for radio stations. And you really do need to look at the title report. If it says something you don't understand, you ask the lawyers, or you tell them, I'm a ham radio operator and I want to put up stuff. Is this going to stop me? And at least if they don't know, they'll find out.
A sad day in a doctor's life is when
could
the
I go
patient
back-
dies. A sad day in a lawyer's life when he has to say, there's nothing I can do for you.
Yeah, Fred, I like to go back to the very first question about, well, what's wrong with just putting it up without a permit? And I just wanted to give you a little bit of a cautionary tale. I've seen that a lot. People put in fireplaces without, fireplace permits if they're required, and so on. You might, if you have a problem, like the house burns down because you didn't get a permit for the fireplace, or somebody gets injured climbing on the tower, your homeowner's insurance might not cover that because it wasn't put up with a permit. So just keep that in mind.
By the way,
Absolutely
all
true.
3 presentations you've seen today are available. If you just send one of us an email, we'll be happy to get them to you.
Anything? This is, we shortened everything so we'd have enough time for questions, and we still have time.
One more comment here. When you go to the real estate to buy the property, they may hand you some HOA rules or the covenants and stuff like that. Don't believe it. Go to the courthouse.
Right.
Verify that, because my real estate company gave me CCRs for my property, but the attorney's office forgot to file the new CCR for the courthouse. So we were working with a bankrupt company and following their rules. So on my property.
Yeah, always do your homework. It's worth it. And it's more and more of a problem today. People buying houses and say, I've signed on the dotted line. Can you please look at this and make sure I can put up an antenna? Completely different.
Yes, if it's a satellite TV reception antenna.
You
Because there's a statute and
You don't,
on that.
you don't own the property outside of the 4 walls of
You,
your
you
unit.
can you
It-
cannot put up antennas on common land.
Right. So that could be an issue. So, but with permission, with a letter from the homeowners association, you could. So,
Middle?
Right. Yeah, well, there's no appeal period. Now, caution, 30 days was my example. In Pennsylvania and New Jersey and some other jurisdictions I'm licensed in, it is different everywhere. My point to you was that don't start any work until the neighbors can't complain, or if they do, it's of no consequence. One of my war stories, big case I had about 30 years ago, is somebody got the permit, put it in. He actually moved it back a little bit, didn't want his neighbors to see, at a 1-acre property, and put up a self-supporting tower with a huge tri-band or 5-band antenna on it. And he did it before the 30-day appeal period. He hadn't asked anybody. He just said, I've got the permit. The neighbors appealed one day before the end of the 30 days, and we went through hell for months. It was properly issued, but he spent a lot of time, I spent a lot of time, and even had to charge a little bit of money because we had 50 or 100 people opposing it. It's a high-end neighborhood. And so that's a war story. You don't do a thing until that appeal period. Check and see in your jurisdiction how long they have to appeal. A day after, they
Just
don't.
to elaborate on that, if you do some construction within the appeal period, you're effectively telling the neighbors that something is going on. If they don't know that anything is going on and you've done everything right, you can run out the appeal period and then they're stuck. And their lawyer has to say, I can't do anything for you.
Those permit placards you've seen usually have what's going on, but they're handwritten with a Sharpie and they're hard to read and just tell, I'm putting up a deck or something. It looks the same as if you're
On the
putting up
left,
a
I
deck.
think we're at the last question. Are we at the last question now?
Patience can be rewarded.
Please. Oh. Well,
Well, okay, the way it works in my state is you don't get a building permit until it's been approved for zoning, all right? Yes, at least in my state, that's true.
317, we're finished at 320. Go ahead.
City's ordinance says the height limit is 50 feet. Well, my tower is 75 feet. So I already know that correct me if I'm wrong, so that means I already know I'm going to be in court before I even put the foundation in. So what?
No, not necessarily. Well, you want to put up a 70-foot tower, you got to learn to put on your big boy pants.
Isn't it futile for me to even apply for
Not if you have me as your lawyer.
who has the money and my who has the time, to have to do this?
What you're discussing is the classic question: how much justice can you afford? And
absolutely.
And therefore, you should be out there voting for candidates who want to withdraw and retract controlling laws. Except that we have represented people who were real beneficiaries of the dancing on the head of a pin.
Right.
Everyone, we appreciate the time you've taken to sit here and be with us. We made it come in on time.
Good job. Good job. Well, certainly when you take out a building permit, that's going to go to the tax assessor. We're going to add. Okay, I'm registered. Never mind. I'm actually they're not well informed. You shouldn't have to do that. Right. You think you're gonna get in spending like $55 or whatever, go do it. But I'm surprised. Zoning varies. I'd be happy. I'm just going to sign off and get rid of our what you call here, eject, so that we don't screw this up. Let's see here. Let's see, where is it? Folder OneDrive, this PC. There it is, right there. Open, give access. Eject, there it is, right there. That's the one I want. Okay. Heck, he already pulled it out. I didn't even know that. I get. Oh, thank you, Dave. Fred, did you get your thumb drive? I must have gotten it. Okay. Just roll it off here. I'm going to give it to the guy here.
Let's see. All right. You think it's going to mess anything up if I close this laptop? All right. Huh? Okay. All right. All right. Looking good. All right.
So we meet again.
Do what?
So we meet again.
We meet again. This is mine. Howdy.
Ah, yeah, okay, great. So we got,
Yes. Come on now.
Great.
Very hard to see the tiny little button to click. All right, an error occurred. On my
Yeah, I'm totally confused. Bring this back up here. Move this over here. Well, well, now what? Oh, okay. We are crashing. Trying one more time here. All right. Oh. It's going to be okay, I promise.
No, I know it is. Oh, I don't know if I was going to say, I had an idea for something, but it would not work. JK.
Now that works. I want to go here. And go here and do up.
Oh my gosh, I was like, what kind of happening?
I would love to get this toolbar off of there.
If you can.
Yeah.
I would say that like
All right.
so is it just so I know for when I'm on here, am I clicking like the forward and back buttons?
That should do it.
That should do
Yep.
it. Okay, great, awesome.
Oh, okay.
Yeah, we'll keep that for the end. Thank
Yep.
you so much. And is that on or off? All right, cool.
Who's ready for a presentation? All right. Who's ready for a nap? Okay. I can give you one, but not the other. We'll see which one it is by the time we're done. I'm John Burwell, 44net Program Manager for ARDC. We have a few things to share. I'm going to talk about some 44net developments. I'm going to talk about 44net, and then we're going to have Rosie introduce some grantees to talk about some of the amazing work they're doing. I'm looking around, I see a few people I've seen before. I see a few that I have not, so welcome to everybody. We have some board and staff and volunteers here. If you would, just give a wave so we can all thank you all for everything you guys do for ARDC and the community. Speaking for myself, I've been really fortunate to work with some very talented people, some very committed people, and it's been very exciting. I want to share some of what we've put together for 44net, including 44net Connect, and then I'll hand it over to Rosie. For anyone not familiar with us yet, ARDC is a nonprofit that supports amateur radio and digital communications projects through grants and through 44net. A lot of people encounter us, through one or the other, but our goal is to help a broader community, help them experiment and learn and build things together. And as you can probably tell, we're all kinds of people, if you can see this slide. This is the vision statement the ARDC board adopted recently. It captures something we think is important about the community we're trying to support. Not really users or consumers of technology. I think the world has plenty of that. But people who are eager to learn, people who are eager to try things out, and people who are driven to contribute, to give something back. And we find there's a lot of overlap with the amateur radio community on that. We like not proprietary platforms or closed systems so much as open source technology. Non-commercial projects, things that people can see, get in and see how they work, things that they can study and understand, things they can modify and build on together. And in practice, I think for us that means helping people build systems that they can participate in directly. Things that they can learn from, things that they can work themselves, and things that they can share with others. So if that is the vision, what's the strategic question? How do you actually create the conditions for that kind of community to exist? Well, for us, that means helping people share knowledge and discover new ideas. It means giving people room for experimentation. You know, you need a little space to try things out when you don't know how it's going to go. And it means helping people build durable systems to create communities and programs that sustain themselves. And we do that through grants, which we'll hear more about shortly. And we do that through 44Net, which is where this organization's story began. For those of you who might not be familiar, for decades, ARDC and 44Net have supported hams experimenting with IP, networking, in all kinds of ways. It's known for its block of IPv4 addresses, but it's also known for its shared infrastructure, its open source tools, its growing body of documentation, its volunteers, and the projects that people build with this stuff, right? This is all behind the scenes, but it's very real and it's very important. And what we're seeing is when all of this comes together, surprising things happen. What we're looking at here, for example, is a microwave station, part of the Hamnet project, on a tower in Germany. Those are the Alps in the distance. I am pretty sure you can't see that from where y'all are sitting. Among the stations this node is serving is the Ham Radio Friedrichshafen Festival, which is one of those white dots just above the tree line. You can't see it. Working as I do with 44Net users all over the world, I see people doing all kinds of things. People are building these continental scale microwave mesh networks. This is Hamnet. They have some 1,000+ nodes connected with microwave links using 10 gigahertz, 60 gigahertz. They're linking repeaters. They're taking it to schools to help people learn, to help people teach. Some people are just using it to get an IP address for their Raspberry Pi, and that's okay. Because in a world where we have lots of CGNet and Starlink and cellular connections, when people want to do All-Star or Echolink or DMR, and they can't get to their device, we can help with that. The point is that there isn't one thing to do with 44Net. There's no one right way to do it. It's like amateur radio in that what it is what people do with it, right? And people are doing a lot. So this past year, a team of volunteers and staff rolled out a new way to participate in 44net. Historically, using 44net required a pretty high level of technical capability just to get started. You needed a lot about networking to know on day one. We had the IP mesh project, which works well, but it requires a lot of setup. We can announce subnets via BGP, which is great if you have a friendly ISP or data center. Not a lot of people have all that. So now we have a third path with 44net Connect. You may recall us discussing the POP project. That is what this is. This gives people a way to bring 44net IP addresses onto ordinary devices and networks using WireGuard tunnels. This includes environments that can make experimentation and hosting and doing very difficult, again, like CGNAT, mobile networks, satellite. So now different communities and projects can use one or more or multiple of these methods, depending on what they're trying to do and what kind of environment they're in. Not everybody does the same thing, not everybody uses the same model, but people can find a path now where maybe they couldn't before. And the uptake has been rather strong. Since its launch in November 2025, users have created more than 1,400 tunnels. I'm sure this number is out of date because it goes up every day, representing at least 30% of new IPv4 assignments in that period. And more than 500 of the users who created a new account on the portal since Connect was launched are using nothing but Connect. So this is telling us that at least a third of all new users were brought in by 44net Connect. This is a real driver of new participation. And I think it's a signal that there was a lot of demand for the kind of thing that 44net can provide that was hindered by the obstacles to getting involved before. 44net Connect, bringing those obstacles down, clearly has been driving new participation. So the question is, what do people do with it? People link their repeaters. We've got the IRLP, Internet Repeater Linking Project. Dave, what is K9DC, I believe. People are connecting to their stations remotely, remote operations. A lot of the radios these days have, a GUI that you can run on your computer. You can put VNC on that computer. You can dial into that computer remotely, so you can operate from wherever you might be. People are connecting their home labs. You've got a network at home, you're tinkering with networking, you want to get some real static IPs, some real internet IPs on devices inside your network. We've got some community projects using 44net as a secondary connectivity, like not primary for MCOMs, but as a backup or a second channel. People are using it just for mobile IPs. We have all of these cellular hotspots these days, and you never know what IP address you're going to get, but you can put 44net Connect on one of them, and that IP address follows you around. There's all kinds of other things. We're at booth 1302 if you want to come talk more about it. But the point is that people are excited that they can start participating without having to build the network first, right? It's hard to do networking if you have to do networking in order to do networking. So we've done some work to try to solve that problem. I should say that this was born of the community and it was carried through by the community. We're up here talking about it as ARDC, but the fact is this came from not ARDC, but from other 44net users. A lot of people contributed. Our own Adam Lewis was a volunteer, then a contractor before he became a staffer. Zachary Seguin in Toronto made enormous contributions. We should acknowledge the late, great John Hayes, K7VE. He really put the ideas in motion. He had some of the first concepts that wound up becoming 44net Connect. And I should thank the Technical Advisory Committee and, ARDC, right? We all work together to make this happen. One of the most encouraging things that we've seen over the past year is how many people are showing interest not just in using 44net and getting on 44net, but actually helping to operate 44net. With 44net Connect, for example, we built it so that volunteers could host additional POP nodes, and we're working on bringing some people online so that the community can help shoulder the burden of operating this service. Not long after I started, we quickly observed that one or two heroic individuals was not sufficient to run a network of the size that we had in mind. So for the kind of change that we wanted to see in the world, we needed to open up, right? We have a very talented, capable, engaged, energetic community. We wanted to bring that resource out so that it could help support this network. So much of what we've been doing over the past year has been to reduce barriers to adoption, right? Improving the portal, launching 44net Connect, but also reducing barriers to participation in general, creating new ways to volunteer, creating new ways to help run the system. We have volunteers handling support requests, verification requests, writing documentation, developing software, and supporting newcomers in general. Our mailing list has become very active. It's a very positive, supportive place. And at this point, none of our systems are down to one person who understands them, which is a big step forward for our resiliency and our ability to grow and maintain 44net. The software is open source in our Git repositories, and we're seeing people branch out into adjacent communities, right? Reaching beyond amateur radio. Dan, K2IE, put together a package for AmperNet that has been included now in the OpenWRT project. Mark, NI2O, and Steve Stroh might be here. No, he's not. They've been doing presentations, talking about us at conferences, helping people get started, advocating in general for us. And then there's some exciting stuff like another Dan, WI7FI, working on things like IP and Ethernet over LoRa. I met a fellow in Germany doing some high bitrate stuff over UHF. So we have, again, talented people doing a lot, and the result is a program where people are finding more ways to contribute than just by using an IP address. Okay? Now, the thing about this, I was in a conversation not too long ago where this became clear. The volunteers and the projects and the ways that people get involved, this has been going on for decades. We are now in our 44th year of 44net. This is a community with a long history of building and sustaining things together. It was in September 1981 that Hank Magnuski, KA6M, phoned up John Postel and asked for a block of IP addresses, saying, I think this IP thing is going to turn into something. We might want to set some aside for hams. And he was the 44th person to do so. So he was next in the list. 44net was born. We made a video about it featuring the people who were there. We got B. Dale, Phil Karn, we got John Gilmore. You can scan the QR code, or I can give you the link later. What we're looking at is RFC 790, where the allocation of 44net to hams was first published, misspelling amateur for all posterity. At the time, nobody really knew what the internet would become. But amateur radio operators saw an opportunity to experiment with, at the time, packet networking, routing, other digital communications, and they built communities around those ideas. And sure, the IPv4 space has survived, but also the community around it has survived. And it has kept adapting. So whether it was the packet radio links in the 1980s, or international microwave links and satellite communications today, hams have been keeping it moving, right? So everything that we're doing with the portal work, with 44Net Connect, with our technical projects, with our outreach, is in our role as stewards of this resource, cultivate the conditions for the next generation of experimentation and collaboration. So how is the foundation investing in carrying this forward and expanding its impact? There will be a test on every one of these cells later. The point is, the theme of what we're doing is look at what's working. And what ties everything together is that things work better when we make it easier for people to participate, make it easier for people to collaborate, and support people building on each other's work. It's easy to feel like you're all alone sometimes, but the fact is there are people out there interested in doing the same kinds of things that you are. And we want to help people find each other and use that energy to create something. Sometimes that means infrastructure. We've invested a lot in some of our core services. Some of that means software and tooling. We've been cranking stuff out the last year. It's all on our Git repositories. Documentation, there are hundreds of new articles on the wiki. We're working on helping people get onboarded more quickly. And we're doing more to help support volunteers who want to get involved as more than a participant. The goal is to move away from centralizing all of this activity, tying it all to what ARDC can do by itself, and to move toward making it easier for communities and projects to grow on their own, to self-organize, to self-direct, to have enough room, like I said, to experiment and to see what happens. And we're looking at it and thinking the conditions for this form this kind of matrix where you have people, you have knowledge, you have tools, and you want people to come in, you want people to work together, and you want to build something that lasts, right? We want to reduce the uncertainty. So there is a lot of individual work out there, and individual exploring an idea on 44Net is where a lot of 44Net activity begins. One person has an idea, right? They get to where they can try it out, where others can see it. And then others say, oh, that is a good idea. I kind of want to do that too. And it starts snowballing from there. And that's where we see it thriving, where groups of people are coming together to work on something. People are organizing around a shared project. This is clubs. This is national microwave mesh projects. This is repeater networks, youth programs, groups doing remote operation, educational projects, MCOMs. And in a lot of ways, the infrastructure itself, the project, is the meeting point. People are building the system that they use to get together with each other. So, you know, when B. Dale Garvey says, we have something here to enable people to collaborate across distances, right? Or Phil Carnes says, if you can build a qualitatively better way to communicate, even if it's hard to use, people will beat a path to your door. They're talking about the ways technology, specifically networking projects, helps people find one another, learn from one another, share tools, are you getting it? Share knowledge, and do more than any one person could do alone. If any of this resonates with anybody, whether that's the networking part, remote operation, RF, community infrastructure, education, open source technology, just experimenting and poking around, come by, again, booth 1302. Be happy to talk to you about what you're interested in doing, what you're already working on. We're going to have some live demonstrations if you haven't seen already. We've got a cool piece of history there actively using 44Net. We can talk to you about grants, which we'll learn more about in a minute. And yeah, come say hi. All right, so that's enough out of me. By now, you should be well aware we have a grants program. I'm going to introduce our executive director, Rosie Schechter, to get us talking about grants. Thank you all very much.
All right, howdy, y'all. I'm gonna scooch this a little bit. There we go. Oh, he's taller than me. Oh, pesky. So, hi, I am Rosie Schechter. I am the executive director of Amateur Radio Digital Communications. Thank you very much, John. He is our very first 44net program manager and has been doing a ton of work to bring 44net Connect to life and to really work together with all of the disparate communities who are working with 44net. So, thank you. We're going to switch gears a bit, and we are going to talk about grants. And actually, you're not going to see very much of me because I'm going to be handing it off to some people who are doing some really amazing work. One of my favorite parts about my job is that I have the privilege to be able to support people who are doing amazing projects. And today we're going to hear from some of them. And I'm going to ask them all to come up on the stage one by one. First is Frank Karnauskas of ANSAT. So come on up. Welcome, Frank. And just to keep it easy, we've got a second Frank Bauer from Eris, if you want to come on up. And then Kay Savitz of the Digital Library of Amateur Radio and Communications at the Internet Archive, also known as DLARC. Welcome. Welcome. So I'm sure you're going to have questions for all of them. I'm going to ask you to save them to the end. Hopefully we'll have some time for questions. And with that, I'm going to hand, I know you just sat down, but I'm going to hand the microphone to Frank K. Come on up. And then just to click it to right. There you go.
Well, good afternoon, everyone. I'm Frank Karnauskas with AMSAT, Radio Amateur Satellite Corporation. I think everybody here probably has at least a faint idea about what we're doing at AMSAT. We're a 100% volunteer-based organization now in its 57th year, and its primary purpose is to design, build, and operate satellites for educational and scientific purposes, or simply put, to keep amateur radio in space. I'm here to introduce you to our youth initiative. It's not a school-based program. It's a little bit different. We refer to it as a community-based program that any parent who is homeschooling their kids or any youth group leader can use. Of course, any teacher who would like to use the materials, God bless them, they're encouraged to do that too. For the pre-teenage kids, we've just introduced our BuzzSat coloring book. And as you can see, its theme is satellites in space help us live a better life on Earth. The coloring book covers 12 different topics, ranging from natural sciences such as meteorology and climate change to agriculture, broadcasting, search and rescue, just name just a few. Each topic is covered in a 2-page spread that headlines what the satellites do and what the benefits are that they provide. The stories are simple and uncomplicated, and they carry a positive message. Okay, let me get forward here. Okay, each of the 2-page spreads is accompanied by a 1-page learner guide that an adult, a teacher, or a group leader can use in working with the kids. Okay, the coloring book is also available in Spanish. The coloring books are available online at buzzsat.com, and they're, of course, absolutely free, and they are open source. Okay, for the junior high and high school crowd, we create courses on a wide variety of topics. Again, very similar to what we were talking about for the younger kids, but they're obviously in a lot more detail. We currently have 4 courses available online. 2 more are currently in development, and we'll have another 6 planned for completion by the end of the year. So we should have about 12 courses completed by the end of the year. That's our promise to ARDC. The sky's the limit after that, and we're finding new people who are willing to be content contributors, and that's basically what drives this whole program. We didn't want the course just to be a simple electronic page turner. We want to engage the learners on every page. So there's only 2 or 3 sentences per page with a strong visual. And every page has a question that must be answered correctly before the learner can proceed. If the learner answers the question incorrectly, they receive a mild electric shock, but unlimited chances to try over and over again. Once the question is answered correctly, that's when they're allowed to proceed. Some of the questions are true and false. Some require the learner to click on an item, such as a solar panel or a camera, some detail on a satellite or whatever. Or sometimes we just have to have them click on a polar bear because we're just here to have fun anyway. Okay, there's too much to show you right here, so we invite you to come to our booth, which is 1007, and we've got stickers, we have coloring book pages, we have crayons for the kids, and you can give some of the online courses a whirl if you so elect to do so. Okay, but whatever you do, okay, be sure to go to buzz.com, give it a look, have a little bit of fun, because that's where your future is looking up. Thank you.
Thank you so much, Frank. And yeah, I definitely recommend going and checking out those coloring books. There's a sample at the Air DC booth, by the way, that someone tried to like tape, it's taped to the table and they were trying to like take it off and take it with them. So I sent them to you. Anyway, so thank you, Frank. And now, next up, Frank.
Good afternoon, everybody. I'm Frank Bauer, KA3HDO. I'm the Executive Director of ARIS Amateur Radio on the International Space Station. And I love this picture of Sophie Adeno, who's on board Space Station right now, because it kind of sums up not only our school context. This is actually was a live ham video downlink. So students were talking to her at the same time they were getting the video from her through amateur radio on S-band. And at the end, when you watch the video clip of this, you hear a loud cheer from the students, and it really is emotional for her. She gave a nice little heart symbol to the students, and it really shows the impact not only to the students but also to the astronauts on board Space Station. So our program inspires and it allows and it engages and it allows students to experiment. And one aspect, an important aspect of what we do is we are an independent backup communications capability for Space Station. So that's something that people don't really realize, but from an amateur radio perspective, what do? We're there when anything else fails, whether it's on the radio waves or on the internet and all the above. So this is a capability that we have on Space Station. It's an important piece. And as you just saw with Sophie, it allows the crew, it boosts their morale by, they're sitting in Space Station, some of them in there for months and months. Being able to talk to the ham radio community and school students is a huge boost for them, and they really enjoy every minute of it. Chris Williams, who's on board, says during his free time, the best thing he does is talk to students on the International Space Station through ARIS. So basically, what we are is a workforce development powerhouse. We inspire, engage, and educate youth from K through 16, all the way into college, in STEM and STEAM activities through the 10-minute opportunity they have to talk to the astronaut on board Space Station. And we spend 4 to 6 months with them during preparing for the ham radio contact, and as part of that, they do all kinds of different activities from a STEM perspective, learning about space exploration, the research that's going on Space Station, the radio science, and actually engaging in amateur radio, either through QSOs on the ground, and then ultimately the ultimate contact on Space Station. And other satellite communications through some of the AMSAT satellites, as well as all the other international amateur radio satellites that are out there. So an important part of this is that, go back to emergency communications. The youth contacts keep the astronauts proficient in the use of the ARIS radio, and it keeps the ground stations, whether there are our ARIS international ground stations around the world or the ground stations at the schools, keeps them proficient in being able to develop ground stations, satellite ground stations, and operate them in space, to the astronauts in space. Now, we are very grateful for all of the support over the years that ARDC has provided to us, starting with our interoperable radio system that's on board Space Station. You can see that at our booth whenever you come by, but also most recently in a program called Stereo. And Stereo, we have acronyms for everything because, you know, that's how we do things in space, is with acronyms, right? And basically we have three main objectives for that. One is to distribute a radio kit to the students that are involved in these school contacts to get them interested in radio technology. Another is to do, you can put a kit in a school, but if the teachers don't know how to use it, it's going to be useless and put on a shelf. So we do workshops with the educators, in other words, educate the educators, as well as go to conferences and get some of the educators that have no idea what ham radio is, interested in what we're doing and getting them in and actually doing these school contacts. The third piece, which is, and all three of these are equally important, is that ARDC provides funding every year for us to keep our operations going. Now, what ends up happening is wherever we are, we're on Space Station right now, wherever we are, we need individuals working with the space agencies to actually get these contacts scheduled, to coordinate the operation of the radio system, and that costs money. And so we have partners, several partners, and ARD's part of that to make sure that that's not on our plate every day of worrying about where that funding is. We have it, and we can make sure that that operations will continue. So I mentioned the radio kit. We call it Sparky. It stands for Space Pioneers, which are the students, Amateur Radio Kit Initiative. And so Sparky is a kit that we provide. We have it all in a Raspberry Pi. The whole system, it has all kinds of capabilities with a RTL SDR dongle with it, so that they can learn about all of these invisible waves and frequencies that are out there that you know, has useful information that they don't even know exist. And so they learn about, basically we have slinkies so they can learn the basics of waves and frequencies, and then we get them involved in basic electronics using a snap circuits kit, and then they get involved in the codes and ciphers and the actual software-defined radio and learn all about that. They actually can use that to hear Space Station. So it's a really powerful kit, and we have lesson plans that go along with that system. So in conclusion, what I would like to say is, you know, talk to us. We're going to be at our booth. Our booth is 4301, 4302 in Building 4, the Volta building. We have a special guest, actually, he's in the audience. John Schaffner he flew as an astronaut on the Axiom 2 mission a couple of years ago. He was on Space Station for 10 days, did research, and he used the ham radio. He's a ham from his teenage years to today, and he still, like all of us, is a lifelong learner. And he'll be by the booth at the end of our forum and for signatures, but he also, for people who want to meet him, he's also around and even here today. So please stop by, and there's our QR code, and there's my email address if you want to get in touch with me. Thank you, Rosie, and thank you, ARDC.
Thanks, Frank. All right. Okay. Take it away.
Hi, I'm Kay Savitz, K6KJN. I'm the curator of the Digital Library of Amateur Radio and Communications, or DLARC, which is a project of the Internet Archive. If you've ever used the Wayback Machine, that is another project of the Internet Archive. And DLARC is a little slice of that pie, generously funded by ARDC. So DLARC is a free online library of amateur radio and related communications, amateur radio, shortwave, pirate radio, and other things like that. Our goal is to offer an unparalleled library of available online for free of everything ham radio. We are online at archive.org/details/DLARC. Please check it out. So this is a list of just some of the stuff that is available in the DLARC library that I could fit onto a tiny flyer and get up here. We have the full run of 73 magazine. We have old issues of QST and old issues of CQ. We have a bunch of other magazines, Monitoring Times and Florida Skip and Satellite Digest and things like that. We have newsletters from, we have 50,000 newsletters from ham radio groups around the world that have generously said that we could include their material in the library. We have conference archives going back more than 40 years for all sorts of ham radio conferences. Sometimes that means video, sometimes that means audio, sometimes that just means slide decks. They come from all sorts of formats, literally. Sometimes I got old PDFs, sometimes we digitize them from videotape. Sometimes it was in real audio format and I had to convert it to something someone can use today. We have digitized so much material for the DLARC library. This is ham radio stuff that has never been available online before, which includes rare newsletters, all sorts of manuals and things. In the last 2 years, we have scanned more than 2 million pages, made them digitized, put them online. They're all full text searchable. If it's audio or video, it's transcribed and full text searchable. So that's some of what we have. We have more than 150 call books and radio catalogs for every company that you can think of or ever heard of. It is really an unparalleled library, and it is thrilling to make. A few months ago, if some of you might be familiar with Fair Radio Sales, which was in Lima, Ohio. They sold old military radios and catalogs and stuff. When they went out of business, I said, hey, can we go in there and can I have a copy of everything? And they said, sure. So we went in there and got hundreds of boxes of material and scanned it and got it online. And that was how I spent a few days last summer. Let's see. Yeah, I already said all that. QSL cards, radio ephemera, and other things besides the magazines and the newsletters and things. So what can you do with the DLARC library? Number one, I want you to just use it, explore it, go in there, enter your call sign or your grandma's call sign and find out what comes up. Explore the books. Some of them were books and magazine things. Some of them were published yesterday. Some of them were published 100 years ago. There's so many manuals. I promise you, if you have a rare bit of equipment and you want a manual for it, there's a good chance. There's a good chance we've scanned it. So you can visit us at the booth. I can't read the number, 1506, I think. If you have material to contribute, something that you have created, your club's newsletter, a YouTube channel, a book, log books, your old just ramblings, whatever. If you want to contribute, I want you to contribute it. We have a list of most wanted things. These are the stuff that we have permission for, but we just haven't been able to find. Please check out our want list. But most of all, I want you to use the library. That's not my slide. I want you to use the library, check it out, explore it, and it is a 100,000 rabbit holes of ham radio that you can get lost in, and it's an amazing thing that I have get to help create thanks to ARDC. Thank you.
All right, thanks y'all. And let's give a second round of applause for all of our grantees, the ones that are here in the room, and also the ones that aren't here in the room. Again, I have the best job in the world. I get to really, use this wonderful, amazing gift of this endowment to support these amazing projects. Now, just out of curiosity, I know y'all have heard of AMSAT, right? Yep. I know you've heard of ARIS. Who here is hearing about the Internet Archive for the very first time? Okay, I'm seeing a lot of hands. This is great. I recommend not only going to check out DLARC, but go and check out the Wayback Machine. Go and check out everything that the Internet Archive has in store. I mean, how many terabytes of?
DLARC is 26 terabytes.
Okay, wow. DLARC is 26 terabytes, and they have the Internet Archive has so much more information there. So go and check it out. Archive.org, right?
Archive.org.
Archive.org. Great. Awesome. So the projects you've just seen show us what a community of learners, experimenters, and contributors looks like in practice. It's exactly the kind of thing that we here at ARDC are here to support. With grants, with 44net, and many of the most successful projects we see started out with someone who had an idea. So if you're somebody who has an idea or you're with a group that has an idea, we encourage you to reach out and to talk to us. You can submit a grant to us at any time. We typically review them in batches. The next round of grants is due on, the next round of applications is due on July 1st. And then the one after that closes on September 1st. And everything after that we review at the beginning of the next year. If you are submitting something for a scholarship program, we prefer to evaluate those proposals during our September 1st deadline. So you can submit anytime, but that's when we'll evaluate it. And then, again, applications received after September 1st, we'll review them in February of next year. Earlier, we mentioned our vision, a thriving global community of learners, experimenters, and contributors advancing freedom with open source information and communication technology. As we thought through this vision and the strategic approach of learning, experimenting, and doing, we also considered the kinds of projects that we thought might be the best fits. The answers are our priority areas of funding, which you can see up here. At the top, research and development, SDR transmitters, codecs, anything open sourced, anything that we fund needs to be open source. But yeah, reach out to us if you're interested in R&D, if you have an R&D project in mind. We also are very much interested in space-based communication projects, which is part of why AMSAT and ARIS are projects that we really appreciate and are at the top of our list. Whether it's a tool for learning, whether it's a repurposed commercial satellite, those are the kinds of things that we're interested in. And then, of course, free and open source education. So curriculum that you can be repurposed, shared with a bunch of different schools, videos, hands-on projects. We're very much interested in that as well. It's worth noting that we don't like, these are priorities, but we, have broader, we fund outside of these areas as well. So these projects are aligned and with these areas may receive priority, but we welcome all ideas. One thing that we really want to emphasize is that participation doesn't just start with a grant. You can contribute to projects. You can help document systems. You can volunteer for committees or teams, like our Grants Advisory Committee or our Technical Advisory Committee. You can experiment with 44net, and you can join existing community efforts. The common thread through all of this is participation, which, as we know, is something that has been a key component of amateur radio forever, basically. The common thread, again, is participation, learning from each other, experimenting together, and building things that people actually use and share. It's very important. So if you want to keep learning, read on. We do a full annual report every year. Thank you to our staff who puts a ton of work into this. Every single detail that we can possibly think about sharing with you, all of the grants that we've funded, anything that we've been up to with 44Net. If you are interested in our finances, it's all in there. So I recommend going and taking a look. You can go to our publications page. You can also scan that QR code to access it. So, and then of course, come talk to us. We're here, or we'll be here all weekend. We know that there's a lot of great stuff to see. We appreciate you coming out and spending some time with us today. And of course, come back and talk to us at booth 1302. We have some really cute QSO cards. You can also visit our website at ardc.net to learn about our past grants, to learn a bit about our granting process, to learn more about 44Net. John's also been working on updating our wiki, which is great. So yeah, reach out to us if you have any questions, which if we have a few minutes here, we can also try to answer in person. So thanks very much. All right. If anyone has a question in the audience, got this handy dandy microphone that we can come bring you. I see one right over there. John, would you be mic guy? Thank you.
With a grant, is there a particular format to writing the grant that we need to follow? Do you have examples of that, or is there the information on the website for that type of information?
Oh, absolutely. So I wish our director of grant making was here, Chelsea, because she has really worked to try and make our grant making process as simple as possible. We do know it's a ton of work no matter what, right? I think our grantees average like 20 hours to put into their applications. But the application process, there's a couple of different ways you can do it. We do have a form. So if you just want to give us information, answer things question by question, you can fill out a form. You can also submit a PDF style proposal if that's something that you're more familiar with. So any of the above will work. Does that help to answer the question, or did I miss anything? Cool. Everything's on the website. We do have examples. And reach out to giving@ardc.net if you have any questions. Adam Zimmel, who is at our booth, is available to help you take a look at a pre-application, let you know if it's something that maybe needs some more information before you actually apply. And again, Chelsea is also on hand to answer any questions. So yeah, we want to make it. We want for y'all to succeed. So yep. Who else?
Not a question, but more a testimonial. I represent the South Mountain Radio Amateurs, and we got last October, we got a grant in part to run 4 classes a year for the next 2 years for technicians licensing, and then also to improve the communications that we use in support of emergency communications and auxiliary communication services within our county, Cumberland County in Pennsylvania. And just 2 months ago, we closed out the first 2 classes of this year. We had 34 students sign up, and we have, through those classes, through ARDC's grant of funds to us, which enabled us to hold those, we added 29 new hams to the roster. A number of them are joining our club and going on to learn, basic ham skills, and even better, they're joining our emergency communications group, which increases the emergency resiliency of Cumberland County. So thank you very much.
Oh, thank you. I maybe am a little emotional hearing that, so I'm very happy. Thank you. Happy to help. Yeah. I'm going once. I'm going twice. Nothing for our grantees? All right. Well, you can talk to all of us. We're here all weekend. I really appreciate y'all coming to spend some time with us, and go and enjoy the rest of Hamvention. Thank you so much.
Most of you stayed awake. Good job.
I know we should have coffee after 4 p.m. or something. Thank you.
Thank you. I will be at Hamvention.
Yeah.
Okay.
Yeah, it's all right. I know. Yeah. No. Well, I think
We had the beta this time. There are different servers in different places running different code. So yeah, unfortunately, you gotta channels. Okay. I recommend setting up the new ones before you turn out the old
I think
ones.
what maybe we should do is switch off Friday nights here.
Couldn't be helped, I'm sorry.
That way,
Well, so that is just very old tunnel. Digitized stuff we wrap to like feedback into another feedback. We have central gateway and all sorts of university subjects. Super easy.
Yes, it can be tricky, it's fussy, but yes, we have.
You can get incoming traffic to it.
Sometimes the traffic out through it, so.
But it's also.
I have.
The way it works is.
I haven't.
We broadcast
done
a
a lot
routing
with
table
like this.
every participating unit.
And when you're doing
But then
dozens of
add
cases,
those routes to it.
yeah,
It's just me, it just sent them directly to me.
You need more of a.
That way then I'll go through some of the.
Running.
Yes.
Electromechanical systems keep you running.
So I cannot promise today we can do you, but in general, yes.
Well, so.
Good.
That's a separate project, but that's what 44 Connect does, right? It's the
I learned something.
protocol.
You know, we all learned something. Thank you again, Rosie.
Yeah. Absolutely. So, yeah, absolutely.
Take care.
Yeah. Yeah, absolutely.